We'll see how well this goes.
Okay, hello
I mean,
YouTube. Welcome
it's
to
the only way to properly go for green thing %.
No, we're not. We're not going for green thing %. Hello YouTube. Welcome to our Gasple LA first half any % speed run. It's not about like 100% or green %. We're just doing any %. So we're trying to finish it, and if we think we understand like a subject good enough, we're not gonna do all of the additional practice material. So it's kind of more like knowledge %. But yeah, we're gonna just start out with the very first stuff. I've done the Gasple introduction, okay? I am very new to this. We have a bunch of like 20 or 30 people in the lecture room here. The lovely attendant assistants. Oh my god, I can't fucking speak. And yeah, I think we're gonna get straight into it. I'm gonna go like before we start every lecture. I'm just gonna quickly go over the slides and like see what the like look at all the things with fancy boxes in here. Okay, so this makes sense. We the elementary row operations. You can multiply something by a multiple of another row. You can swap those around, and you can multiply it by a non-zero constant. What else do we have? It's consistent if it has at least one solution. Inconsistent if it has no solution at all. And well, echelon forms. So I kind of sometimes fuck up echelon forms because I like forget about rows like this, but they can exist. So we have pivots, and all entries below a pivot are 0. Then we have a reduced echelon form that the pivot is 1 and everything else is 0 above and below. Yeah, I think that's fair. Okay, let's start with the pre-lecture exercises of Gasple Part 1. Let's see how this goes.
Hey.
Hey.
One.
Yeah, I think this should have one solution.
Hey.
This thing has 0, right? Because you can multiply
0,
this
yeah.
one by negative
Yeah,
1.
0. Yep.
I mean,
This is 1. This is both on 0.
No.
Wait. Oh no, it's infinite.
No,
Oh
it's
yeah.
infinite.
Okay.
It's infinite because
Yeah,
it's
they
multiple
are
of 3.
multiple of each other. Yeah, I see. Motherfucker messes up on lecture 1 pre-exercise. SMA.
F.
SMA.
Huge F.
There goes
Well, I
green
mean, here
percent.
we have x1 equals to 7, so you know, this is just one solution.
1 also just goes to 1.
Whoa, back to lessons. Okay, and that's a split. Sub 1 minute, guys. So realistically, we only have 24 minutes to finish this all.
Realistically.
Yeah, this is what we
that
don't
won't age well.
extrapolating.
That won't age well.
this won't age well. What is that for shit ass question?
Well,
I guess.
it's the update your knowledge questions.
yeah.
Yeah.
They're all
okay.
gonna be like
Pretty
this.
difficult.
Oh, okay. So it's just hey, is there like?
No.
Okay, I'm gonna be honest, guys.
False.
No, it does not. It's rows times columns.
Yeah, it's
Okay,
it's
row times columns. I
yeah,
always
it's
fuck
row
that
times
up.
column, yes.
Yeah, it took me a while as well.
And
Jesus, that's a lot of text I don't want to read. All right.
that's true. I think that's true.
Wow. Okay, let me actually have a look at what it says.
Oh yeah,
It's just a
basically
list of solutions. It's just a solution set.
Yeah, that makes sense.
No.
No, it's
Yeah,
not.
because there's two
There's a
x's
multiplication
multiplied by
of two
each other.
things, of two variables.
It's in reduced. This is not in reduced because there's a 1 here above,
Yep.
and this is also in reduced, and this is also in reduced. Wait, is it not?
You have 0 on the last middle one. You have all 0 column. But all 0 row. Sorry.
This one?
Yeah.
Does that matter for an reduced?
It should be at the bottom.
It should have at the bottom.
Oh. Yeah. Okay, that makes sense. Yeah. Okay, that makes sense. Cool. So then this one should be in not an echelon form.
No. Oh yeah.
Yeah. So it's rows times columns. So that's 3,
Yep.
right?
3.
Yeah, it's just a minimum value of the 2.
I mean, regardless
So-
of your amount of columns, if you don't have enough rows, you can't have enough.
Yeah, okay,
Yeah.
that makes sense.
dividends.
Yeah. And same the other way around. Just the min of the
Mhm.
two. That's
I was thinking that
sure.
it wasn't true, but like it's you can only multiply by a non-zero constant, so it is.
Yeah, it is true.
Yeah,
And
because I was
that's
like, well, if
definition.
you multiply by 0, you can reverse that, but it has to be a non-zero constant.
Yeah, like you can't do that.
That would make putting stuff in echelon form a lot easier.
Fifth column is
Everything times 0.
Everything
Done.
times 0, yeah. Argument.
It's an augmented matrix, so the last row is actually
So-
like the answer, right?
Yes.
Yep.
But that,
And there
that
is
is
a
a
pivot.
pivot column.
So it's inconsistent.
Yeah. Okay, that makes sense. Hey,
Wow.
98%,
let's
not bad.
go! That's pretty good actually. Okay, what else?
I
do we
mean,
have?
it is the update your knowledge of the first lecture, you know.
Augmented matrix. What type of row operation should we perform next in the process of solving this system? I mean, I just move this one over there. Oh no, actually, multiply this one by that one. Get rid of that one here.
Yeah, replace
say
one
But
row by
I-
the
this-
sum of the
this-
I would
parts and
say
multiple of another row.
This is a shit question, because you can also multiply this one by -1 and then subtract it. You can also just do it in the other way around, so...
I think he's talking about the mode, like in
I would say you
search
have to-
for something that leads you closer to the actual.
What you're
answer.
supposed to do is replace one row by another by the sum of the others.
Yeah.
Yeah.
I mean, all of them
Okay, that's
works.
But
It
you
doesn't
can
really-
do a lot of
Oh,
different
wow, we
things.
could have
Yeah.
just seen... At the first
I don't
row,
think this was
one
here
times the
before.
third row, and the augmented matrix. Okay, then we get... No, not that one. Then we get a... Where? Oh, here it is. I was like, wait, why is it not there? But it's there. So, plus 1 times to the third row. So then we have 1, 3, -2, -11, 0, -3, 0, 6, 0, 3, 4, 2. Because you just add this one to that one. 0, 3, 4, 2. Let's go. Only one more form.
Replace one row, I would say just add second and third.
Yeah.
Because then the 3 and -0 cancel out.
Yeah, exactly. So I think if you add that one to that one and that one to that one, yeah.
Mm.
And then this one to that one. But then just a half times that. Okay, that makes sense.
I mean, that's if you want to get the reduced echelon form, not just the echelon form.
Yeah.
Yeah, okay, you only need the echelon form, that's true. So provide this, okay. So then so we have 1, 0, -2, -5.
You have already messed up, I think.
Where?
Or
I add
you
this one
not
to
like
that one, right?
miss?
Shouldn't be. I thought you were adding the second to the third.
Yeah,
That's
it's
what I'm
actually
thinking.
you don't
Oh,
have to go
yeah.
to reduce yet.
God damn it. Okay, that makes sense.
That might come later.
Yeah, I'm just really always trying to make it reduce, but I don't have to, you know.
Now
No,
your matrix
that's
is
not what I
fucked.
meant with enter. No!
That's so
I will
often.
punch you.
It just big brain off the Gasple.
Holy
Why
shit!
can you just remove an entire row of a matrix like that?
And
It's
just to
it's
be
a
clear,
genius
just for
move,
you,
though.
Grapple, this is not matrix multiplication. Okay. So you add the 6, the 6
Does
to
Grasp
2,
do matrix multiplication?
probably.
I think, yeah.
I feel like you could solve a lot of questions by
Find
that.
the row reduced echelon form of the matrix. Okay. And then row reduced echelon form is the same as the reduced echelon form, right?
Yep.
Okay, so then I'm gonna use my handy tool.
Yeah. There is a difference between row reduced, but I have forgotten what's the difference.
3, 8, 52, and 10. Okay,
I'm
so
pretty sure it's just another term they use, not necessarily something important.
Yeah. Let's see, the first thing I do is swap around these two rows,
Alright, I'm done.
so that the pivot is on the top. Then I subtract this row from this row. Then get this becomes 9. Subtract 7 from 52. That's mathematics, whoa. And then we subtract -1
Math.
from 10, then we have 11. Okay, then we
Grab
get
your calculator.
Yeah.
You are allowed to use a calculator, right?
Yes.
You can for just simple calculator if you can.
Yeah.
Casio
Not also
80
like
and
I'm gonna
fancy.
divide this all
main one.
by 3. I know the right side doesn't look as nice, but whatever. Okay, then I will add this row, or I will add the top row to the bottom row. That's inconsistent.
Yes.
It doesn't care as long as you can get a result. It's fine.
But then would this be reduced?
You can just equal it to 1 because basically if RE is inconsistent.
Yeah, okay. Then I can just say, Bob.
Yeah.
I have multiplied it by the inverse of what was already there. Wait, it has to be reduced echelon. Excuse me.
Yeah, it has to
Yeah.
be reduced
Yeah, I
also.
was about to say, huh? Okay, so I can divide this all by 3. Oh god.
I would say
Yeah,
subtract the
go
second one
from
from the
bottom to
first
top.
one before you do
Yeah.
division, because then you have the friction and stuff.
Yeah.
The friction.
Wait,
I mean, couldn't I technically just add?
0,
You can take out all the answers, I think.
Yeah, because I can just add like
Yeah.
5. Okay, yeah. Just make it all 1.
Well, you can all make it 0.
You
Even
should
better.
just omit 0. Yeah.
Yeah.
Yeah,
okay,
because they
that's
need
fair.
to be for this echelon form.
then-
And
then
now you
I
can
can-
divide by -3.
Yeah. So this becomes 1.
One
This
five.
becomes 5.
5. And now you can
Then-
subtract it easily.
Yeah.
Or add it.
Just add this one to the one above, so that becomes 0. This becomes 12. I can divide this by 3.
I think you're missing minus sign. It should be 4 as I got.
I got 4.
Okay, never mind. Oh, I
Okay.
made a mistake. Oh yeah, I forgot to divide. Yep, never mind. Never mind.
It's good that other people are checking me because I am like very dumb.
You haven't even done this yet. It's very good for a first time.
Let's go! Okay. Are we just gonna do this? 23.
Yes. We are doing this a bunch.
Yeah.
Okay, well, it's good that
I'll send you a jar file so you can do it with a Java program.
Bruh.
Oh, cool! I'm getting sent viruses already. I'm not even halfway through my stream.
Yes.
That's a Poke Champion gamer moment. Okay, so I can already tell that this is gonna be inconsistent as fuck.
Yep.
Yeah, because we just add like a -2 times the top one to this one. So that becomes 0. That becomes 0. That becomes 0. And let's see.
1.
Or, well,
just
no,
put it 1.
we don't add -2. We just add 2. So this becomes 1. Then I can get rid of this. I can get rid of this. I can move this one to here. I can add this row to this one. 3, 25. That becomes -3.
Minus 3.
Okay, then I can add, I can multiply this row by 5/3. Then I can add this row to that one.
Why not just divide it by 3?
Yeah.
Uh,
I mean,
then-
everyone works.
wait, so this was -5? Yeah, okay. So this becomes 0 and this becomes 20. Then I divide this all by 5. And I divide this all by 4. And then this is our final answer.
And that's you made a mistake. It should be 5
Should it
because
be?
it's 20. Yeah, it's 20 before.
Oh yeah, I divide 20 by 4 and it becomes 5. Stuff like this is gonna be why I fuck up my exam, I swear to god.
Yes.
Like
I
half
actually
of us,
did the
man.
practice test earlier
Half
today and I
of us.
did the same thing like 5 times.
What a mood. Okay, give the augmented.
I really hope I don't do that
Oh
again.
well, that's easy. That's just easy. That's just a 0, 5, -10, 1, -4, 5. What an exercise,
Next
guys.
question. Solve it.
Fuck. Bring your augmented matrix to reduced echelon form. Okay. I'm gonna see if I can just do some big brain stuff here.
Oof.
You can't.
I don't think so.
1, -2, 1, -4, -5.
I'd say first switch the 2
Then
rows.
just add that, add 4 times this row to the other one, so that becomes 0. And 4
And then
times
just switch the
-2,
2
that
rows.
becomes, yeah, and then I can swap 2 rows around. So this becomes this becomes this.
Yes, -0.
I mean, technically it's true.
Let's go.
Hey.
Didn't even use
Let's
my Word
go.
document. Use your reduced echelon form to solve. Okay, well then we have x1 is -3 and x2 is -2. So I will create a vector of -3, yeah, -3, -2. We are straight up gaming. We're only 15 minutes in already. And we're 4 out.
Wait, you guys are doing
No!
you guys are doing pre and post lecture questions?
Yep.
Yep,
Apparently
we're doing
we
every
are.
one of them.
Yeah,
I
I mean,
think this marathon is probably going to take us until the end of the night.
it might.
I've done the Grasper exercises myself, and I think honestly, just the post ones are good enough.
Yeah, the pre ones are really just.
We gonna do that? Up to you guys, honestly. I'm just here for you.
Yes.
I mean, the
I would
pre ones
skip
are,
the
the
pre
pre ones are
ones.
very fast regardless, so that's not where the time goes.
I think so.
Wait, what did I do? Okay, I add 3 times top 1. So this becomes -2, this becomes 1, this becomes 1, then I swap them around. Well, actually, I don't even have to swap them around. This is just the vector 1, -3. We are so gaming, holy shit.
Bruh.
Bruh.
How many more of
bruh.
these are there gonna be?
You guys ready for this? This is so useful. Like I think we should put a I don't think we should necessarily skip out on certain exercises. I do think we should just say, hey, if we understand this, then we're gonna be done with it.
Sure.
Yeah, just like skip them until something else comes up.
Yeah. So I divide by 3 here. Okay, this makes sense. I'm gonna multiply everything by -1 because, you know, I want to. This is my lecture. Then I subtract 3 times top 1 from the bottom one. Subtract.
0.
That's a lot of zeros. That's a lot of minus signs. Okay, I'm very bad at this.
You put them there yourself.
Yeah, but like -4 minus -3 times 4, whatever. So it's -4, 0.
Oh no.
Let's go. I really hope that's the only question. No!
No, it's not.
Nah, no way.
It never is.
Okay.
You're not going to see the end.
This is why we're doing knowledge percent, because then we don't have to like do everything. Because that would take a long time. It's almost as if these questions were made to be done in one go. And yet here we are with more than 30 people. How curious.
We should just be making these matrices in LaTeX. Come on. It's
Yeah,
not
but
pain at all.
Oh, that's gonna be.
I don't know. I've
Pain.
never used matrices in LaTeX.
I've used tables in LaTeX.
Yeah.
Same thing.
Well, yeah, but like that.
Literally the same syntax.
I
That's
know.
horrible.
I know.
Also, if you two don't want to calculate, I already got the answer. Just can type in if you're too lazy.
No, I'm good. So I add 2 times top 1, so it becomes -20. 2 times top 1 becomes -42. Subtract 3 times top 1. So that's 20. You know, I think we're actually. What do you guys think? Do we understand matrix row reduction things?
You're gonna do a lot more of it during the rest of the run as well.
That is true. That is true. I think.
Yeah, I think we do actually.
And
Yeah.
yet, I will fail in the actual exam to do it properly.
What a mood.
That's the one thing I did properly in the practice exam.
I just want to see real quick. How many is
60. 60.
Yeah, don't do that.
This is within my fucking DNA right now. Like you got
Lecture
60.
Yeah. Oh, so we did like both. Okay, cool. Whoa! Only took us 15 minutes. That's better than the calculus one. Probably because we skipped
if
off
we're
of
skipping stuff, yeah.
Okay. So let's have a look. What is the lecture about? At least I like these. They're still simple.
That means at this pace we're gonna be done in like 90 minutes. Yeah, I don't believe that.
Well, not really, because we have like 12 lectures, and every lecture takes 15 minutes.
Yeah.
So 12 times 15, that's like, what?
Oh yeah, there's 12 actually.
Yeah.
Yeah,
I mean,
for some
there-
reason,
most people
Actually-
will probably only stay for 10, but
most people won't necessarily care about lecture 11 and 12 currently, I think.
Yeah,
Yeah,
no, I
I am
don't
gonna do 'em
actually.
Yeah, do them. It's just like,
Yeah.
well,
Oh yeah, all these beautiful examples.
yeah, I like our lecturer didn't do these, so I'm looking at this like, what the fuck? Okay.
Well, at least
We did
like,
everything slowly.
at least
Yeah.
you don't have to do lecture 7. You can take lecture 7 out of there.
Yeah. I already have it out of there. I think. Yeah.
Oh
Yeah.
yeah, nice.
Oh, thought.
Hmm?
Let's go.
Thought.
I wrote thought.
So Pog!
If she breathes, she's a
Yeah,
thought.
But
Well, this is just x times the matrix, and then
How many lectures are we so far, by the way?
we just did lecture 1,
No, but like how many have we done yet?
12.
oh well.
'Cause
Okay.
I'm-
Wow,
I'm-
there was like nothing important there except.
I thought that only the first 10 are in the exam.
Yeah,
Yes.
only the
Well,
first 10
yeah,
were in
but-
the exam.
But this is not only for the exam. This is so that people get their shit together.
Yeah,
Ah.
like me. I didn't do anything for LA except for attend the lectures, so this is just
Oof.
me.
Bro, you're crazy.
Yeah,
you do
Yes.
that?
thank you for asking.
Well, I mean, he's a crazy guy who's been doing this all year and has got 6 out of 6. So
That's true. I don't know how, but
I'm to be honest, I'm quite jealous about this skill. Like you can just like speedrun-ish stuff.
yeah, honestly, I'm just kind of dumb, but like everybody here helps me through this. Like if I did this alone, I would not be able to do this. Honestly.
yeah, you help us. It's a how did the biologists call it? A mutually beneficial relationship.
Yeah, mutually
We,
beneficial.
we leech off of you. You leech off of us. You know?
Exactly. Okay. What
You're
are
you're just the center of a soul parasite.
I have a
You should
fucking
look
bio.
to my own relationship.
Right.
You need to know people. Come on. You had biology probably.
I had biology. Yeah. I just wasn't very good at it. I'm wondering if Gasple will accept me saying negative or minus like to a thing, but I doubt it will, so I'm just gonna say positive.
It probably will.
Oh, and then
So I'm pretty sure it literally just like calculates it.
yeah, okay, that's fair. Then we could realistically even put like the vector and then an x equals probably should add an x3. And that is equal to the vector of -3, 3. Wow. How many questions are there? Both. Okay. I can do that. Yeah. Give the first equation of the system. Oh, that's like 6x1 plus -5x2 minus 5x3 equals -9. Yeah, that's correct. Pog champion.
Is there actually any way in the editor to actually put the X like subscript 3 and stuff?
You mean like this? X2.
Yeah, like is there any way in the actual UI to do it? Or is it just text as well?
I think you. Huh. Oh yeah, you
But I-
can here.
Oh yeah, it's there. Yeah,
Yeah.
they did put that one in.
Yeah. Yeah.
Jelle, if you want to be quicker, but also, and you're probably not going to do this since it's not going to work, it's not going to help you much on the exam, but I'm going to post it anyway. I mean,
Yeah.
it might already have been posted, I just butted in. But
Where did you post it? What? Yellow.
His computer
I love
broke.
having a Discord that
Love
shuts
that.
down when you press Shift Enter and accidentally press Shift Enter instead of Enter.
Oh yeah, Yellow Discord breaks sometimes. That's fun.
Oh,
Yeah.
that's fine.
I've got better Discord and like 7 plugins, and one of the plugins does this even when I turn it off. So, but yes, I have posted in General VC channel a thing where you can just say, okay, fill in this and this, and it tells you to input the matrix, and then you can say add 2 times this row to this row. So you have to do the thinking, but not all the manual calculations.
I feel like we are not allowed to use that on the actual exam.
Of course not. No, definitely not. This is just to make training quicker. So like I said, you're probably not going to use this since this will like it doesn't train you in just math or arithmetics, which is a large part of this thing.
Yeah,
Like,
just not making those calculation errors is the biggest part. Since
Yeah,
we're not heading in like steps, you're
Yeah,
gonna have to do it right one time.
exactly.
So I get it if you don't use it, but I'm gonna fucking use it.
And rightfully so. It's a really nice tool, but I don't think I am.
Okay.
Just use the graphic calculator on the actual exam.
Okay.
Let's just jump to the post. I don't think we can do the update. Oh, whatever. I'll say the post one is more general compared to the update one.
That's true. How many questions are this? 9.
9.
Yeah, I think it does help for like getting the concepts down, so I'm gonna do
Yeah.
them. It's equal to the set 0 A1 A2.
Last one, yeah.
Yeah. But infinitely many elements. Well, no, because this is x1 times. Well, I think it might be.
No. No, it's not. The
No,
order
it's not,
doesn't.
but they do use it like that sometimes.
Yeah, but it's not.
It's not.
Yeah, okay, that's fair. If you did like x times this and then x is equal to, then yes, but no, because they can be like linearly dependent, and then you only have a point. The columns of A span m r to the power m. Span A is equal to r. The matrix A is
I think it's the final one. Each vector
Or
B
says
in Rn can be written
B.
as linear
yeah,
combination
this
of
seems
vectors.
like definitely the most logical.
When you're not sure, choose the longest one, and mostly should be correct.
Based. Pivot position in every row. What's the following statement?
It's an argument matrix, or is it going to be a coefficient matrix?
Well, this is just A in the thing ax plus is equal to B.
Oh. Oh, okay, then it's coefficient matrix. Okay, then.
Yeah. It has a pivot position, so it has at least one solution for everything, right?
So yeah, I think
Yeah,
I think so.
I think so.
Yeah. Let's go, dude. I have like 5 brains. This is not
What?
defined because it's like -5 times this row times -3 plus -3 times this row plus 2 times doesn't exist.
Yeah, it's three times 2, and the last one's 1, 3 times 1, so.
This it does exist.
Yep.
Okay. I'm gonna try something real quick. So we have 3, -5, 7, 1, 8, 3, and then I'm gonna put the 2 and the -2 here. So this is -2 times 1, so that's -2, plus 2 times 3, so this is 6. This is -2 times 8, so that's -16. And I'll elaborate more if this actually ends up working out. I just don't know if it will.
This works.
Okay, so then we have -6, and this is plus 14. So then we have a matrix or a vector of 4, -26, 8. Okay, so this is my way of doing vector matrix multiplication now, and also matrix multiplication in the future. So what you do is you put like the first element over here, the second element over here, albeit a matrix or a vector. And what you do is you do like the first in closest proximity to the number you're trying to calculate. So like this one and this one, and then the second one. So this one and this one. So this one and this one, and then for the second row it's also this one.
Want to know how I visualize it?
This one, that one, that one, that one, that one.
I pick up the matrix, topple it over, and put it so that like the 2 is above the 3 and the -2 is above the 1.
Yeah.
So you see what I do?
Yeah, like the vector, and then just put this one over here.
Yeah, that
this
works for
one over
vectors, yeah.
It works, but
Yeah.
it's a lot harder for matrices.
No, then you just split them up into vectors. I mean,
Yeah, okay, that works. But
Fair enough, but this is quicker.
Damn it! There should be a better way to like get rid of all the things.
Select all of it and press delete.
Oh, press delete. I thought. Okay, yeah, I was using backspace, but that deletes the columns, but just delete works. That's cool. So we this is -5, 0, 4, 3, 5, -5, -4, 3, fuck, -4, 3, 4. And then we have 16 plus 0 plus 20, and here we have -20 plus 15 minus 12. So then we get this is -7. Actually, I'm gonna make the vector real quick. Or the vector. Then we have 36 and -17. I really like this method. It is so quick.
I find it extremely confusing that you go the exact opposite way that I do.
How do you do it then?
I go outwards in, you go inwards out.
Ah,
So I'm like,
yeah.
no, that's not right. Oh, wait.
Yeah. Let's see. Is the vector a combination of the columns of the matrix? I don't think so. I don't see
Best
an-
way to check is make an augmented matrix out of it and see if it is.
Yeah. But I'm really lazy.
Yes.
I don't think it is. Damn it! Fuck. Okay. Then it probably.
Then it probably
dude,
is.
I am
Also wrong. Grasp will be like.
Yeah. Okay, that's fair. Vector or linear combination. Okay, then I'm just actually gonna do the math now. That's too bad, but it's just gonna have to be done. Okay, 3 -2 -23 -2. I interchangeably use negative and minus, and that's really gonna piss people off.
Sucks for people.
That's true. This is my domain, bitch. Okay. So what are we gonna do? I mean, to check if it's a linear combination, we only need to see if it has a pivot in every row, right? Okay. So I'm gonna add 3 times the top one to this one, and 2 times the top one to this one. So that is 0. This becomes 0, and this becomes 0. Wow. Okay. This becomes 1. Oh wow, that actually does. I just okay, cool. I tried taking a shortcut, but it was actually the right answer. So this becomes 0. This becomes 0, and this becomes. So that is what -46 plus 54. That's like 8, and this becomes 0. Yeah, it don't be looking good for this.
You could have already stopped after the first one because it's inconsistent.
Yeah. Okay. Delete 3, 4, -2, -18, -6, -9, -1, 10, -6, -9, -1, or +1, 20. So I am going to subtract this row from this row.
Sure.
Yeah.
Just an element. It's element of set. It's not element of span.
They do that a lot.
Yeah,
They
if
do that a
Oh,
lot, and
that
they
is-
have taken up a lot of time.
That is
If
such
you
a
look in
good
general,
Well,
I
they do
I
ask
wrote
the
a
same
picture in
question
there of like a giga brain fucking question in VC General.
I mean, this is always. Oh
No.
No!
That's a stat.
It's the set.
This is so sad. Alexa, play
Yes.
Despacito.
That's the stat.
The W is
Literally
well,
every
it-
time that you see that in the exam,
you
you,
skipped
have
the
to
question,
double
brother.
check. You have to double check.
Yeah, I don't want to keep second guessing myself because of this bullshit. Whatever. Okay. So
I hope they don't do that on the actual exam.
they probably
Oh, they will. They will.
They will,
Oh,
yeah,
no.
definitely.
So I add 2 times the top one. So that's -5. It becomes like -26. Yeah, and I can multiply this all by -1. Then we have like a matrix that is consistent. So it is. Yeah. Right. Yeah. Okay. So that does mean that this is an element of this, right?
Yes. I think it does.
But cowabunga.
I haven't encountered a moment where it didn't. So
That's a good one. Is the vector a1 an element of the span of a1, a2, and a3? I'm gonna guess 1 times a1 and 0 times a2 and a3. This is so hard. Alexa, play Despacito. In the plane span by. Okay, it's a really hard word to say in the span of. Okay, -1, 3, 5, 4, -17, 7, 3, -4, h. So I'm gonna add 4 times this one to this one, and 3 times this one to this one. 4 times. Yeah, okay, so that is -5, and 3 times 3. That becomes, what is it? It's 9, so 9 plus 4 is 5. And then 4 times 5 plus 7, that's 27. And 3 times 5 plus h is 15 plus h. So we want, wait, can I actually not just say, I'm gonna add this one to this one, this becomes 0, and this becomes plus 27, that becomes 42. Haha, dude, it's 42, isn't that funny?
It's the funny number.
Bruh.
It's a funny number. Holy hell. But does this mean that there is a pivot in every row, but there's also a row that is like this, so that means it's consistent for every h that is, So the only way for it to be consistent is this is all zeros, right?
yes.
So then
Yep.
only in the case of h equals -42. Wow, okay, wow,
Let's
that was
go.
actually, that was relatively, like, simple. Okay, can you find a vector that is not a span? Well, let's have a look if we can. Well, and we only realistically have to check if they are like linearly dependent, right? 316. I don't think they are, honestly, but let's have a look. So I add 3 times the top. I subtract 3 times the top one from the bottom one. So that becomes 0. Yeah, this just becomes something else than that. Like, what is it, 7? So there is no. Yep. Because it spans r squared. You shouldn't say r squared, it's r2.
R squared.
R squared. I am a Chad. Well, I mean, this is just obvious, because this is a double of... Wait, actually, is it? Yeah, because we're row reducing. So this row is just
Yeah,
a
it's
0
1,
row because
2.
you can... Yeah. So
just 1, 1. So you can just say.
okay, let's
You need to put in a vector for me. Yep.
yeah. The vector
sometimes
1 1. Oh, mother. Shut up, everybody. I
I
will literally punch you
And-
guys.
This has happened so many times. Like, oh my god.
Yeah. Okay, a lot of words.
Many, many words.
Many, many, many words. So give a
At least
vector
4.
equation. At least 4. There might be more, but I've concluded that there's at least 4.
You should become a consultant.
Yeah, I should. Let's use this one as a check if it's able to understand this. Because it might just use like some kind of math regex that looks for x1 v1 plus x2 v2 or something like that. I just said the word math regex and I already hope it doesn't exist.
It does.
Of course it does.
And it looks like they're using it as well.
Please don't. No, not the math regex. Not the math regex. What did I do to piss you guys off? Please don't. No!
No!
Do the math regex!
Why is that a thing?
Okay. The matrix equation. Well, that's just easy. That's just like this one. I really hope I get it wrong now because I said that's just easy. -8, -3, -1. Times
Bro,
x.
the negative one has. Watch out.
I would have gotten this wrong if it wasn't for you guys.
Got you.
You should use -0.
Oof.
Are you sure it's really
Consistent.
times X?
Yeah, how do you do the subscript from the earlier question? You
Oh
you
yeah,
did it though,
so you
without
do
having
x
to go
and
in the
then
menu.
underscore. So underscore 1.
Oh,
Yeah,
The
that's,
shift minus sign.
Are you
if you're
sure
using a
this should
Windows.
be times X?
Hmm?
Are you sure this should be times X and not a vector that contains x1 and x2?
I'm pretty sure. Because,
Should
like,
work. That's
this-
the way
this-
you should write it.
No. Wait. Do a matrix equation. I thought you were talking about.
I put x1, x2 in the vector.
Isn't it like
Well, I mean-
053 times x1 plus -1 minus a -1 times x2? That's what's coming up in my
Okay,
mind.
so what the vector x is x is a is equal to this vector,
Not sure
And
if
if you-
Gasple
if you do-
recognizes that, but it should.
and if you do
Yeah, that's
matrix multiplication,
example.
you will get that this is all just multiplied by x1 and this is all multiplied by x2. So that's why these two are equivalent. So you could just say x here.
I wonder if Gasple knows that though.
What do you mean?
Yeah.
Please specify x.
Yep.
Okay, and now try with x1, x2. Like with just a vector.
Yeah.
So I
Okay,
wonder if
Yeah, it says specified explicitly as a vector.
they're
GG.
bunks.
Hey.
They're fucking bunks.
Gasple is so stupid.
Bro, imagine losing points if you just put x.
I don't think
You
you
know
lose points on the actual test.
Yeah, in actual test,
Like
and
they'll
i-
just be like, yeah, that's right.
yeah, and if you do, you can just fight it.
True.
Equivalent to
just
the
literally beat him up.
yeah, square the fuck up, bitches.
Put it as actual bold as well. Just to make it very obvious.
Hmm?
You can put it as actual like bold text as well, because it just accepts any LaTeX.
Okay, that is pretty funny. Yeah, they're probably using some math latex bullshit to make sure I don't just write the matrix times x is equal to a vector. And this will be wrong. Fun fact, because I didn't go out of here.
I wonder if they would like count that as wrong as well.
They probably on an exam
Like
maybe
Gasple will,
not.
but I don't think they will.
That's true. Give a matrix equation. That's just like -6, -1, -5, -6, -2. Could I just write like all this in minus sign inverse and then like times -x?
Probably not.
Yeah, no, I couldn't in Gasple, but it would be correct, right?
I think it would be correct, yeah.
Motherfucker, I
You're
wrote the
missing an
wrong-
X.
Yeah.
There must be a way to add more columns/rows to a matrix.
Yeah, most likely. I'm just very dumb.
Yes, you can press shift and enter, I think.
I really hope that I'm gonna test it and that you're gonna submit my answer and mark it wrong.
Wait, what can you press?
Shift and enter.
Let's
I
have a
think.
look. So shift enter. Holy shit!
Oh.
Holy
Can you add more or more columns? Can you also do that?
Yeah, but Gasple breaks,
Well-
so you know.
Yeah,
Wait!
Grasp break. Oof.
You would actually die if you do that.
Guys.
and it also
You
checks your
mind
answer
if
every time,
I-
but it doesn't mark it wrong because. Okay, that's a very interesting.
I just
Oh,
stopped drawing.
it doesn't even reach the bottom.
Plot twist: they're going to ask us to find the determinant of a 25 by 25 matrix.
Oh
Just,
no.
just
They
roll with this
shouldn't.
into a diagonalized. Easy
Bro, I
game,
hope they're
guys.
gonna put like half of the stuff being zeros.
If they give everything except 5
Yeah.
numbers as zeros, I'll do it.
I mean, or if we give a triangular matrix.
Yeah,
think
Oh,
I'll
so.
that
do
is
it.
okay.
Yeah, there was some stuff about that. I just don't remember it because I'm bad at maths. Fuck.
Triangular matrix is just multiply the middle parts.
Yeah.
Or
So
like
it's
the
the same
diagonal.
as like just the diagonalized matrix.
Yeah.
Oh well,
Yeah.
that's cool. Okay, boys, fun stuff. I'm going to add subtract the top one from these ones. So when you subtract -3, you add 3, so this becomes 10. Oh boy, I sure hope I know what I'm doing here. And then I add the top one to this one, and add no, subtract the top one from this one. Fuck. So that is 20, and I add 12. This becomes 55. Okay, and then I'm gonna divide this one by 5. This becomes -1, this becomes 1, this becomes 4. I divide this one by nothing because 13 is a prime number. Fuck you. Gonna multiply this one by -1 just for like convenience sakes. And then add 3 times this one to the top one. So this becomes 0, this becomes -3, and this becomes -24. I'm gonna add 10 times this one to the bottom one. So this becomes 0, this becomes 3, and this becomes 15. Then I'm gonna multiply this one by 1/3. And this becomes this. That's the same as dividing by 3, by the way. I'm gonna do the same here. Becomes -1. Actually, I'm gonna also multiply by -1. This becomes 1, and this becomes 8. So then we have the equation. Oh god, that doesn't work here. Do I seriously? Am I seriously about to just pull up another document? So what this gives? This is x1. Oh, I have to do it in their neat little brackets. x1 plus x3 equals 8. X2 minus x3 equals -4, and x3 equals 5. And I forgot 2 backslashes here, so it's going to complain. And I'm going to recompile this. So this is what it says. What do we have to solve for again? Oh, just to know the answer as. Okay. So, well, we know this is 5, so I'm just gonna substitute this with 5. Add 5 to both sides. Then we get x2 with 1, and this is gonna be +5. So I'm gonna subtract 5 from both sides, and this becomes 3. So then we get the vector. Actually, gonna recompile this so you guys can see what I'm doing. So then we get the vector that is equal, or just the vector itself. 3, 1, 5. Let's go! Okay. Alright, I think all in all this is like not too bad. Solve the following. Oh, so we just have to do this again. Oh, and this is just pre-lecture as well. I'm gonna do this one, and if I get this one, actually I wanna do this until I get one where we have a free variable, because then I have to use this syntax, and I just want to test if I'm like able to do that. So yeah, we got -4, 8, 3, -13, 12, -24, -5, 27. I imagine the exam is just going to be a bunch of this, and I'm really not looking forward to it. Subtract this one from that one, -0, this, then we add 5, then we subtract 27, that's -24, divide this one by 8, that becomes 1, this one becomes -3, to be honest, I'm just going to do it the easy way, and I'm just going to multiply this one by 3, so that becomes -12, this becomes 24, this becomes 9, this becomes -39. And I'm going to add this one to that one, or I might as well subtract this one from this one, or add this one to this one. Then we get 0, this becomes 0 as well. This is going to be inconsistent, or have a free variable? I don't know. Yeah, it's probably going to have a free variable. So then I'm going to add 9 to -5, that becomes 4. -39 plus 27. That's like a lot of numbers, like 12, or -12, I mean. So then this becomes 1, and this is, well, this is still equal to -3. Okay, so this just gives us some information, but not too much. Then I can divide this all by 3. 8, this becomes 3, this becomes 13. So what we know is, if I open up my LaTeX again, we know that x1, or -4x1 plus 8x2 plus 3 equals -13. And we know that x3 is equal to -3.
And we know that x2 is equal to x3 as well.
Do we though?
Wait, no.
No, this is just like the same thing over and over.
Yeah. I'm sorry. I'm tired.
So, oh, this should be 3x3, my bad. Okay, realistically, what can we do with this? So we have these equations. What if we fill in Oh, there's a thing here that didn't want it. So x3, I'm gonna fill x3 in as -3, so that's become -9. Then I can add 9 to both sides. This becomes -4. Okay. So we have a free variable. That's probably gonna be x2.
Why don't you first simplify it to reduced echelon form?
You mean like getting rid of this 3?
Yeah, and also getting the third row to be all zeros. It's just a lot cleaner, in my
I mean,
opinion.
Yeah, okay, but like if I get the third row to be all zeros and then like subtract 3 times this, then I will get 4 here, or -4 here.
Yeah, and now
That's
like
already what we had here, or well, not because I forgot an 8 here, but that's already what we were doing over here.
yeah, but like right now you can basically already put in the answer just x1 equals minus. Well, yeah. Well, if you simplify it further, because currently it's not in reduced echelon form, you have to multiply the
Yeah,
first
okay.
row.
I can multiply by -1/4. This becomes 1. This becomes -2. This becomes 1. This becomes 1. This becomes -2, and this becomes 1. Okay, but how do like what would the equation for this be? Like for this form?
So for that form, it would just be x1 equals 1 plus 2x2.
Yeah.
X2 equals x2. And x3 equals -3.
Yeah, but how do we put it into a vector form?
You just pull all the ones that are x2, you move it into a different vector and put it with like s with a like in the Gasple.
Yeah, and you put
Oh, so what I would do here, right, is oh shit, one too far. So what I would do here is I would say the original one without the x2s. So we have this is gonna be this is gonna happen a lot more often, guys. I promise. It's gonna be really funny. You guys can laugh at me for a bunch. So I can say these things are because this one is like this part is dependent on x2 and this one is part is dependent on x2. So then I can say plus x2, and I'm gonna change this to s in a bit, but I'm just gonna keep it like this.
You don't have to. You can just leave x2.
Oh, can I?
Yes.
Oh, I'm gonna check that, but that makes sense.
It's what I've been doing for all of the assignments. It works.
Okay, that makes sense. And x1 is equal to 1 plus 2x2. And since it is in terms of x2, I guess x2 would be 1 here. So then it would be 3.
Wait, no. Wait.
I don't know what I'm doing, so I'm just kind of going off what you guys are saying.
Can you go back to the reduced echelon form in the table?
No, I think the 2 and x2 and then
Yeah. So basically, the last column is the one with the like the last one, the solution. So for the first vector, no, the 1 minus 3 0.
Oh yeah.
That's that's the first vector without a variable.
Like this?
Yeah, and then x2 is simply it's -2 1 0.
I don't think
sorry, 2 1 2 1 0.
This vector is incorrect. It should be 1 0 minus 3.
Yeah.
Minus 3 is x3. It's not x.
Yeah, I was about to say like this, no way this is correct.
Sorry, 1 0 minus 3. Sorry, my bad.
Okay, I was about to say no way that's correct.
Yeah, this should be correct.
Okay, I am trying to see like the logic behind this though, because I'm not just gonna straight up copy it. So how come this is this?
Okay, basically because like when it's already in this form, you can just rewrite it like the first row. It's x1 minus 2x2 equals 1. So you're just moving it to x1 is equal to 1 plus 2x2.
Let's see.
Because as x2 is changing, the center part is changing. It goes with it. So it's like if you were to change.
Oh wait, so I write x2 in terms of x1 instead of the other way around.
Well, no, just well.
Huh,
You're basically just trying to find the solution for x1, x2, and x3.
Yeah.
For free variables, just x2 is equal to x2, and whereas for the other ones, you can just find it from the reduced echelon form if they have x2s in them as free variables.
Oh wait, I see. Oh yeah,
Yeah.
okay. So this equation, like it was just now, is fine because then yeah, okay. So we split this equation up into the part that is in terms of x2 and not in terms of x2. So the null
Exactly,
part is,
exactly.
Okay, yeah. So then the null part,
And
the one here goes over here, and the 2x2 becomes this. Okay, yeah, that makes a lot more sense.
I would also add x2 equals x2 just because it makes it easier visually, because then you just add that, because sometimes I tend to forget the 1
Oh
for
yeah,
the
okay, yeah.
x2s.
If you want to, I can add that. But yeah, this
Yeah.
helps a lot because I did not understand quite how to get this thing, but like it makes sense if you look at it
Yeah.
at the broader scheme of things. So you
Yeah,
have
yeah.
these constants and these things in terms of x2.
Yeah.
Okay.
You still have to change. Oh, actually, it does allow that. I
Uh,
thought you actually had to use the S
yeah,
letter
like
instead
Gala
of
said,
the-
I could do it, so I wanted to try it, and it worked for some reason. So
Oh,
yeah.
well,
Yeah, it probably
whatever.
checks for either STU or X something.
Yeah. You probably check for
It's
anything.
just a lot cleaner, in my opinion, and makes it a bit clearer what you're actually doing.
Yeah. Okay, so it says the columns of A span a plane in R3, and U is equal to that vector, whatever. So we know because these are two columns, then we know that these two are linearly independent, right? We just have to check if this is within the span of this, and we can do that by making a matrix. Yeah, and that's because if we want to know if a constant times this plus a constant times this is equal to this, then we can just say constant 1 is x1, constant 2 is x2, and you can just have x times this, and then we can, you have the form for an echelon form. That probably didn't make, or for a matrix form, that probably didn't make a lot of sense for you guys, but it made sense for me.
I mean, good for you, I guess, then.
Yeah. Okay. So I'm first gonna divide this one by 3. Then I'm gonna add this one to this one. Then I'm gonna add 9 times this one to this one. That becomes positive 15. Then I'm gonna divide this by 5. Then I'm gonna divide this one by 15. Then I'm gonna see that is no, that's inconsistent. Because
So the answer
x1.
is no.
Hmm?
So
Yeah,
the
so the
answer
answer
is
is
no.
no. What?
Well,
Huh. Then I probably fucked up somewhere in my. How can x1 be negative 3 and 1 at the same time? Then I probably fucked up somewhere in my.
most likely.
Okay, I'm gonna check where I fucked up. So I divided these two by 3. So then we have 1 and 5. So then oh wait, I added this one to this one, but I should have subtracted it. So this becomes negative 25 instead of negative 15. Then I subtract 9 times this from this, so this becomes 0, and this becomes let's see, 9 times 5, that's 45, this becomes negative 75. Yeah, then it becomes consistent, because you can divide this one by 5, that becomes 1, this becomes negative 5, you can divide this one by 15, that becomes 1, this becomes negative 5. So then we have a solution, namely negative 5, 5. Yeah. Okay. Does the equation ax plus b have at least one solution for all possible b in r squared? Well, that's only the case if okay, so it's for r squared. It's only the case if there's if you reduce it to an echelon form and there's 2 pivots, right? Add 2 times this one becomes 0. Add 2 times this one, that becomes negative 2, and then we subtract 2 times top 1. This becomes 0. Yeah, there's 2 pivots, so I believe that is the case. Okay. Seems logical. Well, no. Give a vector b for which the matrix equation ax is equal to b has no solution. Okay, so this is basically equal to the matrix. Wait, it's -5. I'm just doing this to make stuff a little clearer for myself. So -5, -25. Then we have b1, b2. Multiply everything here by 5. And then subtract the bottom one from the bottom one. So this only works if b2 minus 5b1 is equal to 0, right?
Yeah.
Yep.
Okay. And otherwise it doesn't have a solution. So I can just give a case
Yeah.
where that's not the case. Namely
1, 2, basically.
1, 1. Oh, and then
Or
I can
1, yeah, 1, 1.
There we go. Ooh. There are vectors b in the matrix equation exist. I love how they just answer their own question later on.
They always do that.
Describe. There are also vectors for which this matrix equation is consistent. Describe the set of vectors for which the matrix equation is consistent. Well, that's only the ones with this outcome, right? Because we can have
Yeah.
like. I mean, it does always pass through the origin. We know that for sure because the span of just a linear combination of two vectors always passes through the origin. The question is, do they form a point or a line? No, it's a line because there are like. Huh. That is a good one.
As long as one vector spans it and the one vector isn't 0, 0, it's a line.
Yeah, that's a good point.
No, it's a line.
Ha!
Shut up.
King of comedy.
Dude, this is so peak comedy. To find a vector x that satisfies the equation. Well, I mean, this is just easy. This is just.
Watch him fail.
Dude, pog. -2,5, right? Yeah, obviously. There we go. Because like the vector -2 times 5, then you get -2 times this vector plus 5 times this vector equals this vector, and that's what we had. Wait, why did I already skip the pre if I'm still doing pre? Okay. Does it have at least one solution for all possible b in R cubed? Well, it does. It does. I think. Huh. In this case, does it have a free vector? Because x2 just doesn't really do anything.
Honestly, at this point, I would just try to solve it just to see if it has an empty line. You know?
Yeah, sure.
Because honestly, most things can just be like. Most questions can be done by converting something to a reduced echelon form.
Yeah, I agree.
It's not the fastest way to do stuff, but like, by God, does it work?
Add this one to the top one. We get -4. Add this one 3 times to the bottom. Or wait, actually, no, not add. Subtract. So this becomes 0. This becomes -2. Subtract 3 times this one from this one. Then we get -4. But no, here we have.
Yeah, do have an M0.
Yeah. So because we have 2 of these, we can just subtract 1 times the bottom one from the top one then.
Mhm.
So if I just move the rows around a bit, so this is our final row reduced echelon form.
Yep.
And if we now have like some equation here, so B3 is a free thing. I still struggle when I see a augmenting matrix or matrix like this to understand what it means when I see something like this.
I mean, this isn't an augmented matrix. Oh well, now it
Yeah.
now it is. Well,
Yeah.
but it isn't because you just added it to the reduced echelon form. You should have added it to the normal form and worked from there. I think.
Yeah, okay, that makes sense.
Because now you're not doing A axis B, you're doing U axis B with U being the reduced echelon form.
That's true. Or AX equals B prime, where B is the form we would get. Yeah.
So
That's true. I can do that real quick. Just have it like properly with the B stuff. Okay. So then we have B1, B2, B3. Multiply this row by negative. I'm gonna multiply by negative a half. Then I'm gonna subtract this row from the top one. So this is plus B2 over 2. This becomes 0. This becomes negative 2. No, it's negative 2 or negative 4? Let me see. So I subtract this one from the top one. So when you subtract negative 1, that adds 1. Yeah, okay. Then I subtract 3 times this from here. This becomes 0. I subtract 3 times this from here. This becomes positive 2. And this becomes plus 3 times this. Okay. Well, then I can add this row to the top one, right?
Yeah.
So then this becomes 0, and this becomes plus. Oh.
Yeah.
I can add these two together because this is a half B2 and this is 3 half B2, so this becomes 2B2. 2B2T, the oldest Minecraft anarchy server. So in the case that B1 plus 2B2 plus B3 is not equal to 0, this has no solutions, right?
Correct. Yes.
Okay, so then I just have to fill something in for that. So so I give a vector B, in which case it's 1, 2, 1. Let's go! Okay. Okay, that's good. There's more. No! Okay. Describe the set of vectors B in B3 for which the matrix is consistent. Well, it's only for these vectors, right?
Yeah.
I mean, all of these 3 can vary, so it's definitely true the origin.
Mm-hmm.
But I'm not sure if it's a plane or a line.
Well, if you've got 3
It's a
things
plane
that
because it
can
got 3
vary-
variables.
Yeah.
Oh yeah,
No.
it would be like saying z is equal to x plus y.
Yeah. Or something like that.
Okay, cool. Possible create a tributary matrix with the property that the matrix equation is consistent for all B. Ooh. Okay, let's have a look. So we have a tree, so that is 3 rows, 2 columns. So that's like this, right? And then we have some kind of B1, B2, B3. I have to find something that is consistent for all of these.
I mean, you could just use the 0 matrix.
Hmm?
Couldn't you just use the 0 matrix? That one will just always be consistent.
Well, no, this will all be inconsistent, right?
No,
Unless
because it will
be a 0 vector.
Oh wait, you know, you're right. Never mind.
Yeah. So the thing is, we could use like in the case of a 3x2 vector, we could do this. But I think like if we have pivot positions like like this could be reduced back to this, and then we have some condition for which B3 would not be possible. So I think the answer is no. Yeah. So my reasoning behind this is that we have like eventually you will row reduce any matrix, and if it like in the best case scenario for us, it will have maybe something like this, like 2 quote unquote pivot or 3 quote unquote pivots, but this one can always be reduced back to a 0. So there is always a row which will have here something in terms of B and here 2 zeros. And that means there is always a case where this is inconsistent, namely in the case where this is where this is not equal to 0. Okay. So that was the pre-lecture exercise of 2. Wait, that was the post? Why did it say pre?
That was pose. Yeah. Gasple error. It's Gasple because you see the title is always pre-lecture exercise right now for some reason.
That is really fucking weird. Okay,
They probably
let
made the 3 and then copied them and then made a post out of them.
That's like 3.
Yeah. Okay, so that means we are 1 hour done and we have 2 lectures done already. That means it's only going to take 6 hours. Ha! That's
Hey,
like,
only 6 hours.
It's better than calculus.
yeah, exactly. What was calculus, like 8 hours?
Wait.
I'm going to be honest, I thoroughly doubt this is going to take only 6 hours. I think it's going to take way more.
Like, I'm doing the rest now. Like, from 8 onwards, it's just do this one thing 7 times.
Oof.
Yeah, okay.
Like, honestly, once you've calculated the inverted matrix for 2 of them, you can do it for all of them.
Yeah, but then I do have to get like down how to calculate an inverted matrix. So we'll
There's
see.
one trick, and it's really easy.
I know. Okay, so we have homogeneous systems. Fucking what a word, man. And that's just basically it's homogeneous if ax is equal to b. And it's always consistent, obviously, because you can find a solution for it, x is 0. It has non-trivial solutions if and only if there's at least one free variable. And with the trivial solution, they just mean b is equal to 0. Or sorry, x is equal to 0.
For so long, I thought they mispronounced it, and it was in fact homogeneous, but it's a different word.
You think the math teachers mispronounced it? I mean, don't get me wrong, it definitely could.
Don't they call it the homogeneous equation or something?
A humongous equation, yes.
Humongous what?
Humongous what? Okay, so a consistent, non-homogeneous equation.
Homunculus.
Yeah. Can be written in the form. Okay, yeah. So we have like the basis solution plus something else. Okay, cool. I have never used this in my life. But this does make sense though. Like if you solve the system for ax is equal to 1, then the b will just be an offset of that. Cool. Given a matrix A with an echelon form as below, what does the solution look like? Oh. Dumb fuck. The span of 2 vectors in R4. Well, that... Oh yeah, okay, because the 0 still has to be added here. And there's 2 vectors with pivot positions. So if we had another one with a pivot position here, and a number here, or even better, like with a 4x4 matrix and a pivot position here and here, then it would be a if it has 4 pivot positions, would it be like the entirety of R4? Yeah, right? Because they're all linearly independent. But yeah, this is just 2 vectors in R4. Linearly dependent, I think you guys know this by now. This has been drilled through our fucking school quite a bit. I mean, this makes a lot of sense because, you know, if you have the 0 vector, that can be written as 0 times another vector. Okay, cool. And if it's something important, like if you have p vectors and it's higher than the number of dimensions, then the set is linearly dependent, which makes sense. Let's get there. Okay. Try solving the following homogeneous system of equations. No, I don't think I will. I really prefer just doing. Oh wait, okay, that's cool. Just doing this in Wiskunde Bay where we only had like 2 solutions and we could just use our normal way of solving this stuff, but now they had to invent vectors and matrices. Okay, so
All math dreamed up by the utterly deranged.
we don't need more than addition and subtraction. Okay, well this is a free row, obviously.
Wanted to multiply? We had a tool for that. It was called repeated addition.
Nice. We add 3 times top row to this one, 3 times top row to this one, 3 times top row to this one, and 3 times top row to this one. Woo! That's like a lot of complicated fraction math that I really CBA, so I'm just gonna multiply everything by 8. Okay, then I'm gonna add 3 times this one to that one. So that is gonna be, or subtract 3 times this one from that one. So subtract 3 times this, so it's gonna be plus 15. Might as well calculate this real quick. So this is negative. This is 72 plus 15. That is, what, like 58, 57. Okay. Yeah. So this is our I can reduce a bit more, but then it's gonna get quite ugly. I think this is even a prime number. I'm not quite sure about that. But yeah, these two don't share any factors. These two don't share any factors.
I mean, you can leave it as a fraction, like when you're
Yeah,
writing.
okay, I can do that. So I can say 1, and this is divided by 24, and this is 1, and this is divided by 8. Now x3 is gonna be really pissed at me. So we now have. Oh wait, let me actually grab the other one. This one. So we have the set of solutions. So we have x1 minus the fraction of 57 over 24. x3 is equal to 0. And we have x2 minus 5 8, or minus the fraction of 5 over 8 times x3 is equal to 0. Okay, and this, like, now that I know how this works, I can easily say this. I can say the vector of so let me recompile real quick. Oh, I should have excusez-moi, should have put this in terms of x1 and x2. So I can just say it's equal to this. And this is equal to that. I think it might even be better to put it in terms of x3 instead of the other ones. So we now have it like this. Now we can divide by the reciprocal, or multiply by the reciprocal. This is going to become 8 over 5, and this is going to become 24 over 57. Oh, forgot to take this to the other side. Okay.
Why would you do that though? I don't understand.
I'm trying to figure it out in my head, but it's not really working.
Like I don't get why it would be easier to put it as x in terms of x3, because like in the other form you just have the first and second and third vectors, like the first, second, and third entries in the vector, and it's fairly neat. Like this, I don't know what significance it has.
I see. So we have x3, and then we have 57 over 20. No,
I got a different result.
Would you write it in terms of x3 or in terms of x1 and x2? Because I believe it's x1 and x2.
well,
No,
there's
it's
only one
x3
free
because
variable.
x3 is the free variable here.
Okay.
You're noting as a free variable. But I got a different answer than you. What I got is 2 minus 5 and a 1.
That seems a lot more logical. Let me tell you that. So I'm gonna go into my math again. Okay, to be fair,
Actually, no, never mind. I made a mistake. I made a sign mistake. Never mind. I saw it was 3, not minus 3. I saw it was plus 9. Never mind.
Okay, let's see if this works.
YOLO.
No.
No.
Okay, can you scroll up a bit? Thank you.
Okay, so I believe this is like good here. Then I add 3 times this one to that one. 12. This becomes an 8. And like -3. So this becomes -5.
Wait, you added 12. You should have added 9 on the second one. Because it's 3 times 3, not 4 times 3.
Good call. So this becomes 5. And this becomes this minus 3 times. Actually, that's -5. Yeah. So this becomes -1, -1.
And this is a lot nicer.
Yeah, I was about to say this is. I prefer this one. I'm gonna be honest. And then this becomes -2. Yeah. Okay, then writing it with this. So we have. X1 is equal to, or x1 negative minus 2x3 is equal to 0. X2 minus x3 is equal to 0. This is a lot nicer to work with. I'm gonna be honest. Okay. Oh, and I forgot the clothing thing. So well, then we have x2 is equal to x3, which is really nice, and we have negative 1 is equal to 2x3. So then we will have, well, x3 is equal to x3, x2 is equal, recompile. X2 is equal to x3, and x1 is equal to 2x3. Yeah. Let's go. Notice the left side of our equation has stayed the same. Now my question is, how does that help us? Can I literally just write 0, 25, 25 plus what we had before? No, right? There's no way that's possible.
No, something will be changed. Something gonna change.
No, because you'll be reducing it like the echelon form. Like you can get rid of the last 25, but you'll still have the x2, what you worry about. But the like the x2 times, like the vector won't change. It'll just be, you won't have 0, 0, 0 anymore. So.
Oh, so like this thing will stay the same, but it's gonna have something plus.
Yeah, exactly. It will have, yeah.
Okay, well let's solve it. See if that helps us.
I mean, if you're solving, you'll get it anyway. But yeah.
Yeah, but I don't know. Like, I don't think there's anything that really helps us so far. Like that adds any shortcuts or something. Well, then we can. Whoa. So this is still the same. Add 3 times this. Well, this is also still the same. So this becomes 0. This becomes, what was it, 5? This becomes, or yeah, 5, and this becomes -5. Then I can divide all by 5, so it's 1, negative 1, 5. I can add 3 times that to the top. Or subtract 3 times this from the top, so it's 0. And we subtract.
Well, you could have stopped there just because you already have the vector, and you won't make any more changes to the second line. Like I was just saying, like you could just stop there, yeah. Since
So
you
you're
just need
saying
0,
that I
5,
can
0.
then just have 0, 5, 0, plus what we had before.
Exactly, yeah.
Okay, that does make sense actually. As what was it, 2, 1, 1? Yeah, probably.
Wait, what? That's not right. Maybe we forgot a sign somewhere. But I don't think so.
Yeah, I think this is just correct here. Huh. So let me have a look. So I add 3 times this, I add 3 times that, I add 3 times that, and I divide by 5. Huh. I'm just gonna continue solving it like I would normally, see what happens. Oh yeah, I think I see what happens. So I'm gonna.
Oh wait, I'm dumb. I'm sorry. That's my bad.
Yeah, no, it happens. So this becomes negative 15. This becomes 0, and this so this is plus 3, so that's 6, I think. And then I can subtract all by 3, so this is 2, and this is 5. So would this be correct then?
Wait, isn't that 3? Hold up. Isn't that 3?
Oh wait, yeah, you're right. It's 15. 15 divided by 5 is 3.
Caught it.
But would this be correct then?
Yeah, I would say yes.
Huh.
Okay, I'm wrong twice.
Hey, dude, I just want to say I really respect you for like trying and helping.
Should this be -5 instead of -3? Because that's what I got. I mean, you could give a shot. I mean.
Yeah, we were dividing by 3, so -5 was correct.
Well, okay, all right. just don't listen to what I'm saying, okay? Just don't.
Oof.
Don't do that. That's an oof. Okay, I'll shut up now.
No. I appreciate your input. It's good.
Sorry, it's early in the morning. I literally like woke up. I saw you were.
It's early in the morning. It's already afternoon.
Okay.
Yeah, no, but no worries, man. We all make mistakes. I make more mistakes than anybody. I'm the biggest mistake maker. That's what they call me, you know.
I mean, to be honest, this one you can already call out as inconsistent because it's not -39 is different than -41.
Yeah.
Yeah, just right now. Like it's always.
Just right now, yeah.
But that means that this is gonna be 0, 0, 0, something that is not 0, like a.
Yeah.
Yeah.
So that means that this is indeed inconsistent.
Hey, let's go.
Biggest one. Hey! I swear to God, I will do this on my test. I am not afraid. It's even about solution of set of a non-homogeneous linear system and its corresponding homogeneous linear system is true. The solution sets are equal. Yeah, just forget about the B. It's not important. The solution of a non-homogeneous linear system is parallel to the solution set of the corresponding homogeneous linear system. The solution of a consistent non-homogeneous linear system is parallel to the solution set of its corresponding homogeneous linear system. A non-homogeneous linear system can also be inconsistent. Yeah, okay. This makes sense. Consider the following. Because of the memes, I can no longer think about consider the following with a straight face. Oh, maybe I should add the 0.
Also, the only reason we have to redo another exercise is because we screwed up the first one so badly.
I'm going to punch you.
I'm sorry.
So I'm gonna add 2 times this one to this one, add 2 to this one to this one. Add 2 times this one to this one. It's gonna be -4. That's gonna be -4. No, that's gonna be 4. Wait, what the fuck do I? No. Okay, 4. So multiply this by -1. This becomes 0, 0, 0, 0. This row doesn't even matter. Okay, well, subtract this one from that one. Subtract, no, what? This one from that one. Multiply everything by -4. Okay. So we have, x2 is equal to x3, and we have, or x1 is equal to x3, and x2 is equal to -4 x3, and x3 is equal to x3. Okay, that's good. So now I can say x3 times the vector of, you just got vectored. 2, 1, 1.
Yeah, I got a different one.
Oh. Then I'm dumb. Where did I fuck up? Wait, I wrote negative.
It's 1 minus 4, yeah. You have 1 minus 4 there.
How did I oh, I didn't press recompile!
Oof.
Oh, fucking hell, that's
Also, that doesn't look right.
Yeah, no, yeah.
Okay.
Do I not have autocompile on? I thought I had autocompile on!
Oof.
That is so
Big
tilting!
oof.
Wait.
No, it's -4, 1. You should reverse the sign. Because it's 1, if you go to the table you made,
it's
it's x2 minus x4, so...
Okay,
and the first one should be -1 also.
Yeah.
First one should be -1, yeah.
Oh, yeah, okay, yeah.
Yeah.
Okay.
And by the
Yeah,
way, with
so this
Grapple-
would have been the actual solution. Yeah.
Yeah. And by the
Okay,
way,
yeah, I was just a little bit hasty there. You know, nothing good ever comes from hastiness. That's not true, but
Yeah. By the way, with Grapple, like even for these 1-point solutions, if you mess up even one thing, it won't give you full marks, and then it will count as not having finished it and give you another exercise.
okay, I'm not gonna punch you this time. And this time I'm just gonna punch Grapple because that's
Yeah, no. Like that's what I meant last time as well. Like straight up, that's how
Yeah.
it works. Like, you know, even though it says you have 3 attempts, it will just not give you points if you failed it once.
yeah. There's even more. Long. Haha.
It's
You
exact
can just
same
skip
thing
the
as
last
if
one,
it-
yeah. Easy off.
Okay, you know, I think we have completed the pre-lecture exercises.
Yeah.
It's not finished.
We don't want to live with the shame of that being orange, you know?
Exactly. So it's white. That's better.
Exactly.
Please don't take that out of context.
Oh shit.
Okay.
Yo, bro, it's on YouTube, bro. GG.
Oh shit. What
Oh,
if I don't
shoot.
upload this? I can also choose not to upload this.
Yeah, no
I'll
homo, guys.
edit
No
it out.
homogeneous.
Yeah.
Yeah, there you go.
Okay, let A1, A2, and A3 be in vectors in Rn. Cannot be answered if you know whether or not the consistent linear system corresponding to the augmented matrix is consistent. Well, we know this. We know this. We know this. We know this. We don't know this. That makes sense. How many solutions can a matrix equation of the form AX is equal to 0 have? Well, it always has one solution. Because, you know, x is 0, the trivial solution. So it's either 1 or infinitely many if it has like a free variable, right?
Yeah.
Yep, that makes sense. Let A be a tree-by-tree matrix. Suppose that a solution set of the matrix equation goes to the origin. What do you know about the solution set of the matrix equation? AX1. Well, we know it can be 0 if A is just the matrix of all zeros. So it goes through the origin. So this is wrong, this is wrong. I think it's this one then. What? But we know it goes through the origin, right?
Yeah, but
Well, no, because AX equals 0 goes to the origin. AX equals 1, 2, 3, we don't know because it could also be inconsistent.
Wait, actually, we know that it doesn't go to the origin because it's
Yeah,
offset
we know that
from
it
this
doesn't.
one.
Yeah, it's basically it's like ax plus 0. You have the x 0, you have the base solution plus the xh for the specific
Yeah,
solution.
but
So I
it's
think
like let's see, where is it? It's this kind of case.
yeah,
So it's offset from this one. Okay, yeah, that makes sense.
Yeah, but it could also be inconsistent. So I would say it's the second one and not the
it's
third
the second one. Yep.
because yeah.
Okay, that makes
Because
sense.
if a is all 0, then it's inconsistent.
If x is a non-trivial solution, then every entry of x is non-zero. No,
Nope.
this doesn't make sense. Lol. The column of the matrix A is a linearly independent set if the equation ax0 has a trivial solution. No. You can also just have a linearly independent, a linearly dependent thing with ax equals 0 having a trivial solution, namely 0. So, that doesn't say anything. The columns of any 6x9 matrix form a linearly dependent set. So 6 rows, no? Yeah, 6 rows, 9 columns.
So no.
I would say yes because you can only have 6 pivot positions with 9 variables.
Yeah, so like 1, 2, 3.
Oh, linear dependent set. Yes, then it's true. Yeah.
Yeah, because you can only.
That's how it's asking about linear independence.
Yeah.
Never mind. Yeah.
So even in the ideal solution, you would only have like this many, and you would still have a few like variables that are free. Wait, would these variables be called free, by the way?
Yes, they would.
Yeah.
Okay, yeah. I'm like still messing a bit with the definitions because I'm like not a very fast person. But yeah, okay, that makes sense then. Form a linearly dependent set. No. What? Oh, dependent. I thought it said independent. Fuck. Okay. Which of the following can be linearly independent? A set of vectors?
Yeah.
That's
That's the
a dumb
definition,
question.
basically.
Okay. Is that to be linearly dependent if and only if there exist non-zero weights such that the list of vectors equal to 0? No. Well, yeah, okay. Yeah, that's true. Let me check the rest real quick. Well, this one is tempting, but it has to be non-zero, right? Because then otherwise every set is linearly dependent because 0 times v1 is 0 times v2. This one.
Well, I'm pretty sure the definition was that not all 0.
Yeah. I didn't see that this one existed, so it's this one. I know that, but this is basically like saying, this one is saying that everything has to be non-zero, and this one is saying that there has to be at least one not zero. So this one is correct. Okay, cool. Which of the following set of vectors could be linearly independent? Well, this is wrong. This is wrong. This is wrong. This could be. Okay. Poke champion. So this is the pre-lecture exercises done of. Oh no, this is the start of the post.
Except it's yellow now.
Shh. We're not going green percent. I pity the fool who does a Gasple green percent. I've seen people
I did
talk
that
about
for
doing
calculus.
it. Yeah.
Oh no, I mean I have a lot of yellows as well. I thought you were a perfectionist.
Yeah, no, but like there are people who do it, but yeah.
Imagine
could be
people
me.
who do the green percent on those additional like practice material as well with the 60 exercises.
God.
Just for the green percent. Imagine you get that one wrong and have to redo it.
Yeah, the 60 exercises green percent, it's nah.
And also, I don't think it's that useful because it's literally just repeated questions from this one, from the post-lecture ones, like the 29s. Like, it's literally the same questions. Like, literally.
Okay, let's continue. Giving the matrix, find one non-trivial solution to the matrix equation by inspection. Do not use row reduction. Well, this times 4 is that. So the matrix 4, 1. Or actually it's 4, negative 1.
Yeah, you need
Because
a
then we
negative.
get 4 times this, minus 1 times this. Yeah. You cannot see it, but I'm like flexing my muscles.
All two of them.
All 2 of them.
All my 4 brain cells work together, flex both of my muscles. Okay. 2, 8, 4, 0. -1, -4, -2, 0. Okay, so... Oh, I knew this was gonna come. Annoying. Well, whoa. Oh, wait, actually, never mind. So, I'm gonna... This is gonna be -4, this is gonna be 0, this is gonna be 0. Dude, what a cool solution, guys. We have... this. Then we have... Well, I can add 2 times this one to this one. 2 times this one to this one, 2 times this one to this one. And then... Well, that's it. So now we have... the set... Oh. Set -x1 minus 4x2 plus 2x3 equals 0. X3 equals 0. And now it should automatically recompile. Let's go. Well, we know x3 is equal to 0, so we can just get this one out of the picture. So then we have -x1 minus 4x2 is equal to 0. But then we can say x1 plus 4x2 is equal to 0. Or -x1 minus 4x2 is equal to 0. So this is what we have now. So I can say x1 times the vector of... This is 0. Oh. You can't even control Z in this shit, man.
Bruh.
How much do I pay for this again? Okay, half this year, but... Okay, and x1 is just 1x1, and it is -4x2.
I got different result again.
God damn it.
Yep.
Um,
I think you make a mistake during the simplification.
the simplification or the row reduction?
The row reduction, sorry.
Yeah. That could very well be. Oh yeah, and this is where I was fitting in stuff. So yeah, this is -2. Okay, so if I
You could just
subtract
erase.
the bottom one from the top one, then I get -4 here. Well, this becomes just 1. If I add 2 times the top one to the bottom one.
Why is 1? Should it just be 0?
Wait, this one? Fuck, I forgot.
Yeah.
I fucking copied it wrong. Okay, that explains it. Ugh. Okay, cool. Fun stuff. And then this one becomes...
Also 0.
Wait, is
Just
it all
0
0?
row also. Yeah, it's all 0 row. It's 2 all 0 row, and with only 1, so you have 2 free variables.
Fucking hell, okay. So then we have... Well, this is my first equation with 2 free variables. Always the first time for everything, huh? I'm gonna multiply everything by -1 real quick. So then we have 4 plus 4x2 plus 2x3 equals 0. So this is what we have now. So I'm gonna write... how would you solve this? So I'm gonna write everything in terms of... x1.
Write it as x1 equals something, and then that something is your answer.
Okay, x1 is equal to negative this minus this.
And also x2 equals
Oh, wait.
x2, x3 equals x3. And then you just put that in the vectors.
X2 equals x2. X3 equals x3. Oh, yeah, okay. So then we have... so our solution is... so x2 times -4, 1, 0. Plus x3 times... I see. Once you have it in the right form, it's really easy. But I struggle putting it in the right form. 0, 1. Check my answer. Nice. Okay. And now the answer is 5. -10, 5. Well, this one, we know this one is a bunch of zeros again. And we know this one is... It is also a bunch of zeros?
Yep, it's basically the same.
Okay, cool. Let me guess. The next exercise, this won't be all a bunch of zeros. But then we basically have the matrix 5, 0, 0 plus this whole thing.
Minus 500.
Yeah, don't forget to multiply it by -1.
I keep
Yep.
doing that.
No, I'm pretty sure that one is a 5. Oh, wait, never mind.
No, that is a minus 5.
Yeah, never mind. Whoops.
No,
Don't worry.
This is good. This is discussion.
I almost
negative
screwed him
5
over
plus-
again. Huh.
Okay.
Wait, what?
Grasp
Yeah,
error 101.
This is my favorite way of writing down vectors. Don't worry, guys.
Yeah.
Do not ever try to copy paste in Graspel.
Yeah, I
mean,
know.
well,
I
mean-
should have known better.
I mean, you can copy paste before you submit it, and you can get
Yeah,
it right.
you can copy paste what you just wrote.
Yeah, that's true.
Yeah. But you can't copy
Like
paste
somehow that works, but copy pasting from anything else that's rendered in the same way does not.
Hey, it worked. Pretty sick, and now it's gonna be something that's not. Aww.
Yeah,
But you just type no, we
Just
already
write
know
no,
this.
just write no.
Just
And
write
then-
no.
Yeah, the third one's always a no. It's
And the last one gonna be the longest one.
Okay, but realistically, I do want to check why that's the case, though. So we
Because the
negative-
first and the third are basically the same equation, but you got different results. So no.
yeah. I mean, the first one just cancels out the other ones, and both of those are inconsistent. You
That's
can see
true.
because
Yeah.
the first one's 0.
Okay, that makes sense.
So
0 is
Solution
and the
longest
longest
one.
one. It's the same set of
Why
questions.
is it
Yeah.
always the longest one?
because it's probably the most detailed one. Just
Do you
different.
have sufficient information to solve the system AX is equal to 0? Oh, we have this.
Oh, I like
this-
it.
Ooh. So we have 3 pivot positions, and yeah, the rest is just a bunch of shit.
Yeah, you can solve it. The fun
You
thing
can
is
solve
that
that, yeah.
after
Yeah,
this,
but we
it always
don't know
asks
this.
you-
We don't have this matrix. We have a matrix that is row equivalent to this one. Yeah, okay, never mind.
Yeah,
That
still,
is-
they're row equivalent, so it's
Yeah,
this
exactly.
matrix equal to 0.
It's yeah, just basically row reduction of the E, just
Yeah.
reduction of A.
Yeah, and now do it. Whoa.
Fuck.
Ah.
Fun.
So we
Although
have- this is a really big one. as
It's
well.
already in reduced echelon form.
No, it's not,
Or
it's
actually,
not.
it's just an
No.
echelon, but
you have to
It's not that
remove the
bad.
zeros above each one.
yeah, it's already in
do it.
echelon form. It's not that bad.
Yeah.
Okay, so I'm gonna subtract. Oh, and this should be a 0, and the rest
There's
just
a
assume
fourth
it's 0.
zero. There's a 4. Remember, it's a 4. It's a
Yeah.
4-dimensional. There you go.
Okay, so now I can say subtract 2 times this one from this one. This becomes a 0, and this becomes a 1. Then
You
I
sure?
add
You sure?
-1 minus. Wait, did I do 2? Yeah. Okay, so if I subtract 2 times -1, that's same as adding 2, and -3 plus 2 is 1.
Yeah, actually, never mind. I'm just stupid.
Yeah, that would happen.
Ignore me!
So we add 3 here, and we add -3 here. That becomes that becomes 2, right? That was a 5 first. Yeah.
It was 5. Yes, 2.
I have a really bad habit of removing stuff before I'm sure. So I subtract 1 of this one, so that is same as adding 1. That's 3 here, and the rest is just a bunch of zeros.
Yeah, and that's it. And now you can just write it in with the thing.
I also really like how you're just leaving up the top table with, like, random data.
Yeah, this is important.
Like, what is the metric that you use to decide to swap to the next one?
A fitness function.
Ah.
Yes, I don't understand how fitness functions work. Okay, so now that we have this, I'm gonna go to this again. Like, I know that there's probably a better way, and I could just write it down when I see this, but I'm just gonna do this.
You could probably write it down like in the table itself if you want. It's faster. You just have like the 1 equals in another box, and then just have the -4, 5, -3.
Yeah,
then
so
the
we
same.
Or just write it immediately in Graspel. Even better.
Yeah, you could write immediately in Graspel from this point, but just make sure not to forget like to take the things to the side and like minus them when
yeah,
you're doing
so
it.
so it will be like x1 is equal to negative, positive, negative.
Yeah, and then the second, third, fourth, and sixth are all free variables.
Yeah.
So
this
just
would be. So we know at least that x3 or x5 is equal to x6. So that's good.
yeah.
Oh god, and I have to write like 6 long vectors.
Yeah, and they have to be wait, no. What?
Yeah, because an x here is 1, 2, 3, 4, 5, 6.
Oh yeah, you're right.
And
I mean,
we know at least like because there's a 0 here, we know that there won't be any like
You only need 3 actually.
Hmm?
You only need 3, I think.
3 free variables. You mean?
Yeah, you only need 3 like vectors here.
Yeah.
Yeah.
X2,
So-
x4, and x6.
Oh yeah, because we should write them in the terms of the free variables.
Yeah.
The
Plus
first
X.
one's like 410000 for the first one.
Give me a sec. X6 plus 4 plus x6. That's also.
Wait, it's also doing that shit for you, where it just doesn't open on first click.
Yeah, you have to click twice.
Why?
Why?
What?
Huh, that's
Now
so
you've
weird.
noted. Now you've noted because I said it. Now you're just gonna be annoyed.
So
Yeah, like no, but I did see it when I was doing exercises before.
x1
Yeah,
is equal to
so bad.
-4 times this one.
No. You have to put it's a 4. It's 4 because you have to put it to the other side. It's positive.
No, he
Oh,
already
yeah.
did that. He already
Yeah.
did that.
So 4, 1, and then the rest zeros.
No, is it that -4? You already changed
Yeah,
the
I
signs on
already
them.
x1 is equal to.
Oh wait, you're right.
Yeah, you already changed signs.
Okay, so then and that's the rest just zeros.
No.
No,
the second
x2
one
is
has to be a
x2.
1.
Yeah, okay.
X2 equals
But
1. Yeah.
wait, do we just go down this list? But there's only 4 entries here.
No, you don't. You
Okay, well, that's,
go another way, but
it's just coincidence that they're both 0 then.
Yeah.
Okay, and oh shit, I actually should have. Let me actually row reduce this one real quick. So...
No, you can't.
why would
Why
you do
not?
that? It's already good though.
Oh
Oh,
wait, no,
that-
yeah,
oh,
you're
yeah.
right. I can't. Excuse me. I messed up. So x4 is equal to
5.
well 5x1, and then 1x4, and because there's nothing else here,
That's
that means the rest is
X5.
zeros. Oh, sorry. Good call. And the rest is just zeros then.
Yeah.
Okay, and then for x6, that's this one, and now it's gonna get interesting. So we know
It's
x6.
-3.
Yeah, we know x6 is -3 x1. We know
0
it is 1
x2.
0.
x2. Oh no,
0
0
No,
x2.
no, it's no x2.
And 1 x3. Yeah.
1. Yep. 0 x4.
0 x4, 1 x5, 1 x6.
Yep.
Yeah.
I see. So we're kind of like,
Yeah, and now if you did your math right, this will work.
And that's the answer I got.
If you
so-
did your
Let's
math,
go!
right, it was a bit,
There you go.
Guys, I like my -0.
It's beautiful.
Graspo has its own
Zero is
stuff.
negative.
it's important.
Graspo has just proven that 0 is a positive number, since there's also a negative version of it.
Yep.
Oh yeah, true. I mean, like if you write 0 as 1 over infinity, then you can have 1 over negative infinity, and it's all both technically still 0 if you take the limit.
Yeah.
Yes.
So you could have 0 and negative 0.
Okay. Well, I think the answer is gonna be no. Because there's no question for us to actually do it.
No, because you can have 00004.
Hmm?
So,
Oh
I mean,
yeah. Also, the fourth one is just
you-
0, 4 by default.
that's the issue. You have the information to solve the system, but you know the system doesn't exist. So does it still a yes or is a no?
Ah.
Huh.
Because there is, you can solve it, but it's not solve. Okay, then it's no. Okay.
Motherfucker. Okay, yeah. They made a mistake here. It should have been A2. Okay, so you can only use a row reduced form if b is equal to 0, which makes sense because the operation would also affect b. Yeah, that makes a ton of sense actually. Because if you have like some kind of matrix in terms of whatever, and this is 0, then you can row reduce it whatever the fuck you want, and it doesn't matter. But if it's b here, then this becomes like b divided by 2 or b whatever the fuck you're doing. But it's not the same thing. So you don't. So this question would be yes, but only if you have 0 on the side here. And we also know it is inconsistent, but yeah. Suppose that a solution set of a certain system of linear equation can be described as whatever the fuck this is. We can visualize this as a line in our tree. We can describe such a line by giving a point on a line plus a direction vector. Give a point on a line. Either enter your answer as a vector. Well, okay, that is easy.
By the way, can I ask a question?
Yeah, go
Does
ahead.
anyone know will we have a true/false question on the midterm exam?
30%
don't.
of it will be.
No, we don't.
That's in the
Okay,
end
nice.
term, right?
Oh, yeah, that could be. Sorry, I don't know about the
Pretty
midterm.
sure they set only on the end term.
Yeah, you can get through.
Okay.
You can get through false, but I don't think it's on a midterm. Only an end term.
Okay.
Yeah.
Yeah, the
Thank you.
information literacy will only be on the end thing, so we don't have to do the uploads weird stuff during proctored exam thing.
Oof.
Now,
Okay,
at
this
least.
makes sense. So, we have to give a point on this vector, so we can just say, okay, the point I'm gonna take is the point where it's like not in x3. So that's 0, 3, and 0. And then it will also be plus x3 times -8, -2, 1. This one. Describe such a line. Give a direction vector for this line. Well, didn't I just do that? Holy shit. Okay, so that is -8, -2, 1. But they even give it themselves. Okay.
I mean,
don't
yeah,
mind.
I think they just want to check if you know what it is.
Yeah, okay, that makes sense. Wait, this is post lecture already, right? Did they just fuck this up here? Yeah.
Yeah, it's still just fucked.
Yeah. Okay, cool.
It always keeps the title of the first thing you entered it. Like
Oh
when
wow,
you...
that's interesting, actually.
Yeah. So if you navigate through Gasple, it like won't change it for some reason.
I wonder why that happens.
Can I
Okay.
ask a real dumb question real quick?
Ask
Anyone know
ahead.
what a singular matrix is?
That means it's non-invertible or invertible? It's one of the two.
Sorry, can you repeat the
so-
question?
What
Yeah.
a singular matrix is.
Singular
All
matrix
same value and everything.
Wait, no. Is singular
No.
matrix-
Singular is non-invertible. If you can
Singular is
non-invertible.
non-invertible, I think.
Yeah, you're
No,
right.
it's
I
not.
mean, if it's only the same value, then the determinant is 0.
No.
Does not have a matrix
wait.
inverse.
Yeah, exactly. Because
Yeah.
it doesn't have like another. That's why it's singular.
And that also when its determinant is 0.
Yeah.
Okay.
If it's all the same values, then it cancels out. The determinant is 0. So,
Yeah, and it's also
Yeah.
there's also not invertible.
Okay. Suppose the 0 vector is a solution for the equation ax plus b. So we have a times the 0 vector is b. Does that imply that the matrix equation is homogeneous? But we had homogeneous being only the case where ax plus b is equal to 0. But b doesn't have to be 0.
Well, if you times anything by the 0 vector, wouldn't that like?
Yeah,
make
'cause-
b a
Oh
0?
wait. So it is a solution. Okay.
So
Yeah, okay,
I
that
would say
does mean
yes.
that it's 0.
Yeah.
Because,
so it has
like,
to be
when this is let's see, when this is as input, and we know that this as 0 times this is equal to this, and yeah, then we know that this is 0 as well. Yeah. So then we have yes. Suppose the matrix equation ax plus b has a unique solution. What does it tell you about the matrix equation ax equals 0? Has no solution. Doesn't exist now. And with a unique solution, they mean that's the only solution to.
I think they mean that there's only one combination of the vectors, which gives you b.
Yeah,
Yeah.
since there's a pivot in every row.
Yeah, so then we know that ax
Yeah.
equal to 0 has exactly one solution then, right?
Yeah.
Yeah.
That
Because, I
sounds
mean,
about
it didn't say
right.
b cannot be equal to 0. So if b equals 0, then this thing's gotta be true. So, one solution.
Yeah, so it's still the same thing.
Yeah,
Yeah,
nice.
because b can be 0.
Let A be a 3 by 3 matrix with 3 pivot positions. Does equation ax equals 0 have a non-trivial solution? I mean, it could be.
Non-trivial
Wait,
being not the zero solution, basically.
No, it shouldn't have because
Yeah, I don't think so.
if there's 3 pivots and everything has to be equal to 0, then
Yeah, if it's 3
what
pivots, then
else?
we can bring it back to its reduced echelon form. And the only way for this to be equal to, for this to exist is if words are all 0.
Yeah, x1
You-
equals 0, x2 equals 0.
You
x3
need
equals
it to
0.
be linearly dependent if you want to have more than just a trivial solution.
Yeah, but something being linearly independent means it also has. I mean, it doesn't exactly mean that it has a pivot position every row, does it?
Doesn't it though?
Well, it does.
Oh, okay,
well,
cool.
no, sorry, what?
No, never mind.
I mean, or am I just confusing stuff?
Yeah.
But
I don't know.
if
I honestly don't
something is
question.
linearly independent, there should be a pivot position everywhere. I think.
Okay.
Yeah, I'm pretty sure that's
I
right.
would say yes. I would say yes for this question.
Does...
Because you do have a pivot point for every.
Oh fuck! I clicked it wrong.
Yeah, it should be yes.
Holy hell! I thought it said
Oof.
yes. What do you mean? But
What
yeah,
have
if we
you
have a
done?
pivot position, then
Oh,
yeah.
fucking Gasple with putting like the yes answer on the left every time and then switching it to be on the right.
Oh, they always
is
switch them around
stupid.
like it's random. It's literally random.
Yeah, here, look,
I know,
look,
but-
motherfucker.
Yeah, but like that actually caused me to mess up so many questions. I kid you not.
So wait,
Same.
a 2x3. That's just like 2 rows, 3, like this, right? So this would be 2x3. So with 2 pivot positions, then we have this one, and then we do have a free variable, right? So.
So yeah, it should have a non-trivial solution as well.
I'm not sure if.
Well,
it has...
actually, hold up. We might have insufficient, and like if we can, yeah, we might have.
I would say. Wait.
I think it does.
We don't know because
We don't know what
No,
this is for a fact, but like
both those could be 0. Would that
No, because
change
you do
anything?
have a free variable of x3, right?
Yeah. That would
Which
be
that gives you
random.
insufficient information, I would say, because you don't have a pivot point on every column in this case.
Well, since x3 can be like anything, so I guess
Yeah,
you can have more than one solution, definitely. So yes, I would say.
we're gonna see.
Hey, I didn't screw up this time.
I mean, yeah, because they would be linearly dependent. Because one of the three must be.
Yep.
This is an important one. A homogeneous solution with is always consistent. Wait, does that mean that for ax? Oh yeah, okay, because there's like. Yeah, okay, this makes a lot more sense. Like, just x equal to 0, but it has non-trivial solutions if it has at least one free variable. Well, we had one free variable, so there are also non-trivial solutions. Okay, so this is just literally a question asking information from the slide.
Gasple tends to do that.
Yeah. Have at least one solution for every possible b. Well, it has one solution for every possible 0, and then we can just offset it by a bunch, right?
I don't know.
No, it's not the same thing. That's not the
No,
same
that's
thing.
not the same. No, actually, I don't think that's the same thing at all because.
Actually, wait, no, it does. It does. You know why?
Why?
Because it's got 2 pivot positions, and it's in R2.
Oh, true. Yeah. So it spans R2, so B can.
It spans R2, so there's an answer for every B.
Yeah.
Yeah.
Have at least one solution. Just in my head, instantly goes. There is a pivot in every column.
Yeah. So how many of you have that like long list of like 17 equalities like memorized?
Not me.
Not
No.
memorized, but I
Which
get the
equalities? What?
The invertible matrix theorem, I think it was called. That small,
Oh, wait.
that small insignificant
Fuck.
thing.
Yeah, I should really go memorize that before the end term, because I
Yeah.
think we're gonna need it a lot in the proofs.
Yeah, I think so too.
Yeah.
So we have.
Wait, I'm gonna sound stupid, but which one?
It's a really long theorem.
Let me
You
actually.
remember that theorem where they're now putting dots in between instead of all the points because it's too long to fit on a single slide?
Yeah, they're almost dead at this point.
Oh, the one they keep adding to as well with every
Yeah.
lecture.
Yeah.
Oh yeah.
Yeah,
But I
don't
think
know what-
the one in lecture 6 is the only one we need for the midterm because they add stuff in the eigenvalues lectures.
I mean, they add something like I think in lecture 10 or 9 as well. Because I went through it recently. I just
It's this
compiled
one.
all of them together.
Yeah, that one.
Yeah, but yeah,
But this
They've got even longer now.
Yeah, they'll be added on to, but for
Oh,
now.
that one.
It does
Okay.
get longer.
Okay.
Yeah.
Longer.
Where if
beautiful
any
theorem
of
that
those
everybody
are
loves.
true, then everything's true.
Yeah,
Exactly.
they are like saying the same thing.
Yeah, I am not learning that for the midterm.
I'm
God.
not doing the midterm.
True.
Wait, are you ready? Sure.
Yeah,
I'm not doing the midterm.
Me
Like
neither.
setting up all the Graphful stuff is just a bunch of work, and the only thing it will even benefit me is if I get exactly between a 0 and a 5, or a 5.0 and a 5.5.
I mean, yeah,
Isn't
but
It's worth it if you want to be safe, but I think I've got this. Like I've
Like,
got 30 I can
there's
miss
the
him.
person who didn't do a
Either
single
we're getting a
exercise
fucking-
before now in Graspel, and he's just
Yeah, but I didn't do that for calculus either, and that worked.
You're doing really
True,
well
okay.
for someone who hasn't done any of the Graspel exercises. Like, I'm still making the same mistakes, and I already did them.
Yeah,
I
no,
mean,
I
the
appreciate
mistakes
that.
are
Thank you.
calculation ones, not actual like theory ones. So you know.
I mean, personally, how I feel about linear algebra is like it's gonna start easy, but like once eigenvalue and stuff, then it's gonna like kicking really hard. That's why like I was trying to get a safe grade on midterm at least, because the end like with my experience, it's gonna be really hard.
Yeah, it could
Yeah, I
be
can understand that.
falsely easy, like making you feel it's easy at this point, and then just turn to be super hard.
Yeah.
Also, how many of you have done the book exercises?
None.
No.
Not I've done a little, but not necessarily like whole sum. It's like I've done like.
Do you think they'll be necessary for the midterm, the book ones, or no?
I don't know. I haven't.
I
They
don't
done them
won't
either.
be necessary. They might help.
I'm saving them for practice during the end term. So I
I
have
want
like
to
fresh
say
things
the
to do.
exercise isn't necessary, but like if you go to the chapter and like read most of the theorem and stuff, that should be more. Like so I personally I feel that works out more than the doing the exercises.
Yeah, okay, I see that. I think for the
Oh, wait,
proofs,
it was actually
definitely the
really
book
easy.
might be better. Easy.
Ta-da! So, yeah, what think about this one? But you just have to have a number so that a plus b plus c equals 0. Whatever.
I think they have an even lazier solution for this in the actual thing. Yeah.
Oh, motherfucker. That's pretty smart.
I mean, it works.
Good question. I think it is.
No,
let's check,
it's I think it's linear dependent.
No, yeah, it is dependent. Because look at it. If you
Yeah.
divide both sides by 4, like, no,
Left side by 5, right one by
Yeah.
Yeah,
4.
yeah, sorry.
Yep, you're right.
Yep, but you got this idea, so it should be no, because it's actually is independent.
Yeah,
Oh my
they keep
God.
asking independent, and then I read dependent, and vice versa, and it's so annoying.
Literally my heart stopped for like 1 second when Jeremy was the mouse on the yes. I was like, no.
Yeah,
No, but like
the urgency in your voice, like no.
Like, they
Listen,
confuse you so
it is
much in Graspel.
important. It is important.
That's true.
I bet
It's
you-
like
I bet- I
0,
bet you
0,
it's also
0.
random.
Instant answer.
I bet you it's also random whether you write independent or dependent, like in the exercise.
oh, I hope so. Oh no, oh god.
I mean, it doesn't matter
Oh.
for you, but
It doesn't matter for us, actually. Yeah. If
Well, I mean, the exam isn't Graspel.
if it's not randomized, that just means they're mean. If it is randomized, well, it doesn't change anything anyway.
let's try this one. I don't know this by heart, so let's try it.
Yeah, we need to solve this one probably.
Well, I'm gonna add this one to this one, or subtract. Subtract. And then I subtract -4, that's same as adding 4, so that's 6. Then I divide by -3. Subtract this one, so this becomes 0, 1. This becomes 0, 0. This becomes 0, 0. This becomes 0, 0. This becomes 1. So these are linearly independent. Yeah. This times 4 is that.
Yep.
Yeah. I wish they gave a question like this in the exam. That'd be cool.
No, they're not.
Yeah, these are not linearly dependent.
I mean, there
Yeah,
might be
No, I
questions.
Yeah.
meant we're not gonna get questions like these in the exams.
Oh,
but
like
yes,
that.
as well.
But yeah, these two are different, so, you know.
Yeah,
have
they're
one-
independent then.
If you have one constant between these two, you can't have 7x2 equals, or like 7c1 is equal to 6 and 5c1 is equal to 6. So it is linearly independent. This one is not, because this one times 2 is that one. Well, okay, but this is just the same as asking what is the matrix, like what is this matrix solve for?
I mean, more or less.
Well, let's have a look then. Well, we can get rid of these two numbers. Oh wait, what? Why did I put down? Wait, what?
You're right there.
Yeah, that's
okay.
correct, yeah.
For some reason, I thought that this was a 0 and this was a 0, so I was like, wait, then I can just. But it's not. Okay. Yeah. Okay. I had a little bit of a stroke, but that means that I can like add -4 times this row to that one, right? So this can be a 0.
I mean, to be honest, there's
You
an
can get rid
easy
of the
way
middle one,
off for this
so,
kind of
yeah.
question. There's an easy way out for this kind of question.
Yeah,
It's
probably.
basically because you know x2 is independent from x1 and x3, so just say x2 is equal to 0, and then you say x1 is -2 times after x3, so just -2, 0, and 1. That should be the answer.
Or you
Yeah.
could
Okay.
just complete
I
this
get what you're
by-
saying. That makes sense. So I'm still gonna work
Wait,
this out
what?
real quick. But
Sorry, can you
Oh.
repeat that?
So how I think about it is because x1 and x3 are linear dependent, and x2 are linear independent. So I just say x2 is equal to 0, because they're gonna get rid of the independent and stuff. And then you have the dependent of x1 and x3, and x3 is like has to do with -2 times of x1 to cancel out. So x1 is, so for example, x1 can equal to -2, and then x3 should be equal to 1.
Okay, I'm
I-
sure that was very well explained, but my brain is
It's
broken.
hard to wait. Give me a second. Let me organize. Yeah, I don't know how to explain this well.
Hold up, that's not correct. It's
No, it should be other way around. It's
-2
-2,
and
0, 1. Yeah.
yeah, since it's x3, not x1.
Yeah. Sorry. Yes.
So you mean?
But
oh, wait, no,
x1
I
is
think I
always
got
one
it.
x1,
I think
right?
I got it. I think I got it. My brain is broken.
Yes. So it's -2, 0, 1.
Why is
You want to
x1
express it in
-2
terms of x3 instead of x1.
No, because you're giving this equal to 0, right?
What? Yeah.
Wait. What?
What?
x3 is your free variable, so you want to express it in x3.
Oh,
Yeah. Do we have to though?
You don't have to, but
I think
it's
yeah.
clearer and
Wait.
gives the right answer.
Why is this not correct then?
I
Because
mean, you can also say x1, but then it should be -1/2.
No,
Shouldn't it be
no, no,
-1/2?
no, because
No.
this is
Then-
already in the form x1 is equal to 0 -2 x3.
Yeah.
No,
So
Yeah, what you're
you-
currently saying is x1 is equal to itself, and x3 I think is equal to
Negative
-2
half.
times x1,
Yeah,
that's not
yes.
Oh yeah, I see.
which I think is like technically correct.
Let's see if it's correct.
No, it's not. No.
No, it's not correct.
No,
It's
no,
not
It's
correct.
at least not correct. in the
There's
answer.
no way this is correct.
No, this
Okay.
is no way, no, because they're not gonna recognize x1 or x2 or x3 either. They're just gonna see it
Try
as one
minus
variable.
Yeah,
half.
they
I
just-
think -1/2 is 1 for the x3. If you want,
No,
if you want to use x, no, I mean you can use x1 for here, but then you just minus
No.
half for the x3.
What? No.
Like this?
What? No.
Pretty
no,
sure that
no.
will get recognized as right answer, but it's not what you should answer.
No, I don't think that will ever be recognized. I'm willing to bet this will not get recognized as the right answer.
It's saying the same thing.
It's saying the same thing if you're
Actually,
using the
let's
x3 as the free variable.
Actually, you're.
Yeah.
Yeah, it's saying the exact same thing, but what they say there should have been the answer.
Yeah, but this is just the same as that one. You just multiply everything by -2, so...
Yeah.
I
One
don't
is
like this.
one is using the x1 as free variable, which doesn't really look nice, but I mean it works. Or you can use x3, which make it looks better.
Yeah.
I don't know.
The reason it should have been x3 is because you want to express everything in terms of x3, which is a free variable.
No, because it's not even x1 is not a free variable. That was
No,
from
x3 is.
there. You just wrote it as x1. No, x3
Yeah.
is. X1 is.
Yeah, x3 is.
Yeah, but it doesn't matter because you're just writing a variable. And
Yeah, it doesn't matter
actually
which
care
variable
that
you use, it's just that usually you guys put it in the terms of the free variable, I just choose not to.
Yeah.
Would recommend not doing that on the actual test.
Why not?
Yeah,
It's correct.
I mean, yeah, but
No, but there's so many things that could go wrong in.
It was so many extra steps.
Yeah, like. Please
You don't want to do extra steps.
I mean, if you have time,
You don't check your steps.
I finished the
If you
calculator
make a
exam with, like, an
mistake in
hour and
those extra steps, you just lost points for
Just
no
take
reason.
the elevator.
Yeah.
a half.
You know. Well, why
The
do you have to
columns
bother
of
with
this
steps?
form a linearly independent set. Let's have a look. $67, okay. Add this one to that one.
I think it does.
Add this one to that one. Or subtract this one from that one. So this is going to go 3, this is going to become 0. Turn this one can go away, this one can go away. This will become a 1. This will become a 0. This will become a 1. It's linearly independent. Or linearly, yeah, independent. Dude, we've been on a roll, guys.
I mean,
These have been.
Let's
really
go.
short.
Exactly. Okay, I wanna quickly test this out. So, delete not backspace. So this is 0, 1, -2. This is 3 or 1, -1, 4, and this is -2, 1, -6. Is there an easy way to combine these three vectors so that they are like? Because this, yeah, I think it is. Because if you have this vector plus 2 times this vector will get you. Yeah. So like this vector plus 2 times that vector will get you the vector 0, -1, -2, or +2, and then you can just add this one, so it is linearly dependent. Dude, we're actually doing green percent now, right? Holy shit. Okay.
that's
For which
easy.
values of h will b lie in the span of a1 and a2.
It's not even A1, A2, it's just A1.
Yeah, okay. So that is when
Just
a
take
is
it to
2,
Yeah.
basically.
Woo!
That was
I wish we
easy.
had a test question like that.
Yeah.
Then this is equal to for h is not equal to 2. Or actually, I should do nec.
Wait, no. Well, hold up.
Wait, no,
hold up.
no,
Just
because
for
because
all H.
A1 and A2 already make it linearly dependent.
Yeah.
So
Okay, so
regardless
it's no
of
h.
No, all H. What? No.
All H.
OH.
Linearly, dependent. Haha. I love how I just guess some shit and people start yelling. I love it.
It's like, no, stop it.
It's the best way to get a right answer on the internet. Say something that's so obviously wrong that people will be forced to correct you.
Yeah, no, but that's what I'm doing. I just constantly say some dumb shit. You guys are like, no. I'm like, hey. It worked.
If only that also worked on the actual test.
Yeah, you
Just
just say
the
like,
lecturers being like, this is so stupid. This is how it should have been.
yeah, you just say, well, I have a thing here. I'm just gonna use integration or integration by parts to use the chain rule from derivatives, and they're like, what? No, you should do this. Okay. So we need this to be linearly dependent. So I'm just gonna row reduce this, and it's gonna.
Oh god.
Basically, you want to mix the two first and get your answer for H.
Hmm?
I'm not My brain is broken. Forget it.
Okay. So
Don't worry.
I'm gonna subtract this one from this one, so that's 0, and this is -2. Then I'm going to subtract this one from, or add 3 times this one to this one, so this is gonna be 0, and this is gonna be 1. Then I'm going to add, let's say 3 times this one to this one. It's gonna become 0, and this is gonna become +1. And then I can just, wait, isn't this like for all h? Oh wait,
No,
for h
h
is
has to
not
be -1.
For
Yeah.
h is not equal to
Wait,
-1.
shouldn't be h equal to -1 because it asks for linear dependent.
Fuck, yep. I usually write down the answer for when it becomes linearly independent, and then I look at what the question is. So, yeah.
Hey.
GG.
GG. We are pretty smart, honestly. And with we, I
Or
mean,
we could have actually just. Actually, no, that one's fine. It has to be dependent. Remember.
Thank you. I almost made a mistake.
okay. So let's reduce this. We can divide this one by 3. Then we can subtract this one from that one. Or let's do that one from this one. So then we get 0. When you subtract -2, you add 2.
-7.
Oh, this is it.
Oh wait, no, subtract it. Oh my god.
When you subtract
Bro.
-2, you add 2, so this becomes -3.
Yeah.
Nice.
And you subtract 4 from 1, you get -3. Well, then I'm just going to add this one to that one, so this will become 0, and this is going to become h. So this was 3 before? Yeah, so this is going to get 0, this is going to get h -3, or -3, for which is linearly dependent. So that's for this one is
Plus 3.
not
then.
equal to,
Wait,
or
no.
is equal to 0, so that's going to become h is equal to 3.
Yay. That should be right.
Yeah.
We are absolutely gaming this one.
Then I think we're actually doing all green right now. It's like we have green strike of like how much? Streaks of how much?
22.
Oh no, I never know how to
No,
answer
not the
this
whole
one.
thing. Not the whole thing.
No,
though.
we made
Yeah.
mistakes. I know that.
But at least like a good 8 in a row right now.
Yeah.
How many different? Oh,
You guys ready
Alright.
for this one? This will be painful.
Yeah, I know.
This is a stupid one. Oh, this is a hard one.
I remember doing this when I was doing these exercises. Like
Write down all
a week
possible
or so
shapes of an
ago.
echelon form of a 3x3 matrix whose
I am not
columns form a
redoing this.
linearly independent set. Use the symbols blah blah blah. I like how to use a different star here than here. Well, this is fucking annoying.
Not.
Okay, so
Now, what star should I use?
So let's see. Echelon form means, and it's not reduced, right? So it's just an echelon form. So this is going to be a square here, square here, square here. These 3 are set, right? And this is 0, this is 0, this is 0. Oh, but there also can be less than 3 pivot positions.
Yeah.
Oh, no, wait. Linearly independent set. So there are 3 positions.
Linear independent, so you have 3 pivot, yeah.
Yeah, and that just means that this can be 0 or arbitrary entry.
Well, arbitrary entry can be 0.
Oh, okay, yeah, then it's just like this then. So
well,
then
no,
it's just
because
one
otherwise,
form.
why would
Because
they make the distinction? Wait, otherwise, why would they make the distinction, right? Okay.
well, yeah,
No, but
yeah, but this has to be non-zero because it's.
But
Oh,
then
okay.
everything else can be 0, right? You can
Yeah,
have star slash square.
Oh wow.
Oh, wow.
It
I mean,
can
yeah.
be only a star because everything that a square can be is already contained within the star.
Oh, right.
Yeah.
Oh,
And
this is
now
a
we
big
get
brain
a
moment.
sucky one. Write down the possible shapes of a form of a 4x2 matrix where. Ugh. So we have like A, B, C, D, and then we have E, F, G, H, where
I think that's 2 by 4.
Yeah,
That's
wrong
2
way
by
around.
4.
Oh wait, so
I
then
mean,
they're
It's
A1
4
and
row,
A2 are
2
vectors.
columns. Yeah.
Yeah, good call. Then we have A, B, C, D, E, F, G, H, and we
and
have
A must not
A1
equal
is
2
not
E.
equal to a constant
Yeah.
times or a constant. Yeah, okay, you can do times B or A2.
Basic linear independent.
Can
Yeah.
I just say that big A and small a just annoys me?
Auto
Okay,
capitalize off the
specifically for you, I'm
word.
gonna put an A here.
That's beautiful.
Oh,
Spanish A.
A. Okay. So we have linearly independent things, and we have possible shapes of echelon forms. I mean, echelon forms just means that this one is a 1 and this one is a 1, right? And then these aren't. But then we can also have... Huh. The question is, can we have a case where we have less than... Yeah, because this would also be an echelon form, right? Oh. This would also be an echelon form.
Yeah, I mean, is it asking it for it to be linearly independent as well, or no?
Yes, I think
Yes,
so.
it does. But
yes.
Then it has
there-
to be 1-1.
no, but they're like they cannot be linearly. Oh wait, no,
Dependent.
they cannot be linearly independent, right? Because we only have 2 pivot positions and 4 variables, or 4.
Yeah,
So the answer is gonna be 0.
I guess.
Fuck.
I have no idea.
Yeah, no, it made more sense in my head. So then I guess either this one, or this one, or just completely this one. But no, this one is not allowed because A2 is a multiple of A1, namely any multiple. So that means we have to have like either this. No, wait, because then there's still a multiple.
Can you have a like arbitrary entry under the 2 pivot?
No, because then it wouldn't be echelon form.
Oh right.
Yeah, so we know that it has to have at least this, and then it can. Then I think it's just this, right? So then it's just 1.
No.
Why not? What's the other options?
No, actually, you're right.
Yeah.
No,
No.
no, wait a second. Wait a second.
Okay.
Couldn't we have the first one be 0 and the second one be 1? So pivot only on the second line.
Like this.
Yeah.
Yeah, that one would
For
work.
which A2 is not a multiple of A1, so
Well,
You've got zeros. You cannot multiply zeros to give you 1.
yeah, I see. So it's 2 then. What should be wrong again? Okay.
I mean,
Yeah,
Gasple
so we
will still
have
count it as
this
wrong.
one and this
but-
one. Okay, that makes sense. Oh, we got our half one.
Oof.
Or at least we didn't, fail 3 times in a row.
Imagine.
This is such a dumb question. They're like, hey, here we show that these vectors are linearly dependent. Are they linearly dependent?
No, I guess
wait.
the answer is no.
Actually, because it's
Just
also
kidding.
it also for the. Okay, yeah, the set.
Yeah,
okay.
no, linear dependent always for the set. It's not a span, it's always a set.
Okay. So then,
I mean,
the
it
set is
is what?
linearly dependent. Yes. Okay,
Yes.
Yeah. Well, that's. I wish the
Because-
answer is only questions like that. It is linearly independent, and Z is ooh. Well, yeah, I think that's true.
Yeah, that's true. Definition of linear independent.
Yeah.
Definition, yeah.
I mean, it's not just the definition of linearly independent, because otherwise there wouldn't be this much text. But yeah. Which vectors can be removed without changing the span? That means that's basically a fancy way of saying is this set linearly independent? And
X
for it to
or
know which
Z.
one.
X or Z.
Yeah, because
Yeah,
there's
because
like
these are like
either of the
multiples.
two make
Yeah,
it
it's just
dependent.
x
basically.
equals -5 times, or z is equal to -5 times, or -4 times x. If S is a linear dependent, I'm getting like my fucking throat is starting to hurt because I'm talking so much.
Just don't talk.
You want me to speak out loud and you just click
no,
the
but
button?
then the stream will go to shit.
If S is a linearly dependent set of vectors, then each vector is a linear combination of the other vectors in S.
True.
That's false because at least one, but not all.
No,
Yeah,
yeah,
that's
yeah,
true.
yeah. At least one, but not all.
Yeah, it doesn't have to be.
This
You
is
could be
RNL
the
stuff.
third. You could have three vectors. The second vector is a multiple of the first, but you can't make the third vector with these two.
Let me give an example. So we have 0
1, 1,
or
1.
1 0. We have 2 0, and we have 0 1.
No, I think you. Oh yeah, that
You
works.
cannot
Yeah,
make
that
0
works.
1 with any of the other vectors, but you can make.
Basically.
It's a linear. Oh shit! It's a linear independent set. So then each vector is a linear combination of other vectors.
False.
Yeah, that's right. Like one sentence. How many
How many
columns?
pivot columns? Well, bro, you told me your
Okay, yeah,
pivot
no.
was
You can talk. You can talk.
How many pivot columns must a 4x3 matrix have if its columns form a linearly independent set? Carefully explain your answer to yourself.
Is this even possible?
You've got 4 rows and 3 columns. Yeah, you can have a linearly independent set. You just need 3 pivots. Wait, no. Yeah,
Don't you
just
need
three
4 pivots? And you can't have
No,
that?
no. Your set won't span the whole of R4, but it doesn't matter. Your set will be linearly independent.
Oh yeah, true. You're right.
You can describe what's it called? Not a plane, but an R3 in R4. Fuck is it called?
A hyperplane?
Yeah, you can describe a hyperplane in R4, but not spanning R4, and the vectors that compose it are literally the span of it. So, the basis of it.
Yeah.
Okay, so I
So I
think the
guess
answer for this one is just 3 then.
Yeah, 3 pivots.
Basically, you just need a pivot in every column. That's all you care about.
Yeah.
And you can't have a pivot in every column if the number of rows is lower than the number of columns.
Yeah, that's when you are guaranteed to have independent sets.
Basically.
Like this one. Whoa.
How many pivot columns must a 4x9 matrix have if its columns span R4?
4. What? One for each column
wait a
spans. Well, one for each. Yeah, row.
Wait.
There you go.
Yeah, I think there's 4.
Yeah, I think 4. That makes sense. And then the rest is dependent, but we don't really care.
Yeah, exactly. Let's go!
Hey, 90%, not bad.
Good. That is pretty good.
Actually pretty good. I mean, I had all the
pretty
using
good.
in my ass, but
And
let's do the
next
addition.
sector. Oh no, don't do the addition. Oh god. Oh god.
Let's not.
Yeah, you guys want to do 40 fucking questions?
That's 60, not 40.
So that means we only took an hour for the lecture 3 post. And we didn't even do all of it. Okay. So let's have a look at lecture 4. We're already like a fourth of the way through here. That sounds really depressing.
I mean...
That means
yeah.
like we're gonna take 4 times as much time as this. 4 times 2.5. That's like 10 hours.
Yeah, doable.
That's actually pretty doable. I expected like more. I mean, it's gonna get harder.
I mean, we are jumping sections.
Yeah.
And we're also not doing the book exercises.
Yeah.
It's only going to start taking longer and longer the further we get.
Yeah.
No, probably not actually. Like, honestly,
They're probably gonna be less questions, but they're gonna be harder.
the workouts actually don't take more resources. You just have to know the way to do them. Like getting the determinant of a 4x4 matrix with a couple of zeros takes probably as much time as reducing that matrix.
That's fair. Okay, so these are the properties for linear transformation. Did I just do the same thing exactly? Oh, okay, so it's just a remark. T0, 0. You can get this all out of the thing. Okay, that makes sense. Yeah.
That's yeah, that's so weird.
Yeah.
I love stuff like this.
I mean, it's funny.
Like
Yeah.
like you can have this image in a linear algebra lecture and it's like totally serious, but it looks so funny. Okay. Whoa, is that an applet?
Yeah.
Marijn Roelvink. Hey. Oh yeah, this is the standard matrix. That I remember that. Hello.
Greeting.
Whoa. Okay, this all pretty like logical so far.
Actually,
This
I
is the
have
only like
done.
interesting one.
I have done the. Yeah, you need to know the rotation.
Yeah, do know that.
You need to know how it works. Because I don't know who has tried the practice exam, but it had a question where you had to like give a matrix with transformation of a function to spin it around the origin by a specific angle.
Yeah. I mean, realistically, what would the determinant of this thing be? This one minus, or this one times this time minus.
Cos squared your angle, plus sine squared your angle.
Isn't that like always one, or am I confusing something?
Yes.
Okay,
Yeah.
so the
Yes, sure it
determinant
is.
of the transformation of the rotation.
Well,
transformation
yes,
is always one.
because think about it. You're not changing the size; you're rotating it.
Yeah,
That
it makes sense.
Yeah. Because the determinant is also a function of the distortion of the image.
Yeah,
Like
yeah.
if
Like
it
you can
takes
tell.
more space or less space. But here the image takes the exact same amount of space, just rotated. So it should be
Yeah,
one.
the area doesn't change. Like if the determinant is 2, then the resulting shape is 2 times bigger.
Yeah. Cool. Pre-lecture Graspel. Probably gonna be a lot more fun than the post-lecture Graspel.
Oh, only 3 questions.
Yay!
As I said, a lot more fun than the post-lecture. Let me get my Spanish A out of here. Let A be blah blah blah. Transform the information blah blah blah. So practically, what we have is we have this vector, this matrix times this vector. So we're gonna use our trick that we said at the start of the what's it called?
Session?
Session. Thank you. So we have -5 plus 12, and we have 2. This is a lot easier than I used to do it. I'm gonna be honest. So we have 7 and 2.
So yeah, it's just generic basically.
Hmm?
Yeah, it's just a generic
Yeah,
value.
this one is just a generic answer. So then we have 5b minus 4a, and this is minus 2b. 5b minus 4a minus 2b. This used to be so hard. Holy shit. -1,
I mean, it's not
-4.
super difficult. Like
Yeah, okay, but like I always had issues like figuring out what exactly to do, and I used that crappy image, which to be fair, like it worked, but it just took so much longer than this.
True.
So this is -4 plus 2. This is -4, and this is -10.
Yeah.
Like, look at that. I'm doing this shit on my own with like what less than
Minus
5 seconds
2
for this entire
minus
thing.
4 minus 10. GG.
GG.
And same thing, the generic one.
Couldn't I just say right? So this is
Minus A, minus 4B.
-4b. This is -4b. and this is negative 5c, right?
Yeah.
Yep.
Yeah,
Well,
because
this
we're
is-
literally just doing the matrix multiplication of, or
Basically.
matrix vector multiplication of this thing. And you could see this as like saying x here, but instead of x, x1, x2, x3, you have a, b, and c. Okay. So next one. Let A define a transformation. Find a vector whose image under T is equal to. Ooh. So we have.
We have to reverse engineer it.
Imagine if I could apply my reverse engineering skills in like an actual, in like an exam question. That'd be cool. I don't think they'd let me run Hydra during the exam though. Oh wait, no. So we have this thing is 17 and this thing is negative 40, and we have to figure out what this is.
2 unknowns.
I think we should figure out how pissed RP now gets if you attach a debugger to it.
I mean, it's basically again, it's just
this is
a
really easy,
simultaneous
actually.
equation. It's just a simultaneous equation again, same as with all the other matrices we've had before.
Yeah, so it's this one, and then we add one of this one, and then we subtract 5 of this one.
I mean, you can do that.
You can also just solve the matrix.
But you can also solve the matrix.
Yeah, but this one,
Right.
this one was easy. But if it was harder, I probably would have done that. Yeah. Let me see if that's actually correct. So we have 1 plus 1. Yeah.
At this point, I kind of just hope it's gonna be wrong. Nah.
My quick, dude.
By the way, for all of these questions, you can just verify them quite easily.
Yeah, you can. Thought.
Does anyone know if the practice exam they put up is the actual like same length as the exam we're gonna have?
Yeah, it's a similar one.
I doubt so, because that's
It
not
felt
the case
so
for
short.
calculus. Yeah, it felt quite easy, to be honest with
But
you.
it did say it's supposed to be an hour and a half. So
Yeah.
it should be.
So
of a
is
similar
anyone gonna
length.
finish lecture finish exam in like 10 minutes?
Maybe not 10
I-
minutes, but like I'll probably
Half
be
an hour I
finished
can
in
do.
under like
Yeah.
45 minutes at most if I take my time.
I'm not gonna do half an hour because I'm like actually gonna like recalculate my shit 5 different times.
I mean, yeah, at least we have some time to properly do our stuff.
Was the practice exam really difficult? I'm doing it later today.
No, it's not really that difficult. It's
It wasn't
No.
really
quite
difficult,
easy.
it's just that I was sleeping.
You do it at like 1 a.m. or something.
I just woke up and I decided, let's do this practice exam. And the amount
Oh,
of
this morning?
calculation errors
Okay.
was insane. I don't
Yeah,
want
I
to
can
talk
imagine
about
that.
it.
Yeah.
I like how all the math like lectures are always in the morning as well. It's like they want us to like not be ready.
Yeah.
I've overslept like multiple math lectures, both in calculus and LA.
Yeah. Like, why are they always in the morning? Like, what the hell? Like the first thing.
Usually they start 8:45, but then I wake up at like 9. I'm like,
Yeah.
oh shit. And luckily they haven't done anything then, but still.
I swear calculus was 9:45 and they moved it even earlier for linear algebra. Like, why?
I also like how Yura is just doing the exercises now.
Yeah, I was thinking about this one. I was like, how am I gonna do this? But I thought, wait, I'm dumb. I can just like a good person will notice. I am not very smart, so I just made an example. 2 times 1 matrix. I multiply it by a 1 matrix or 1 vector, and I get out a 2 vector. Done. Or other way around. Whatever. I know the answer to this one.
Yes.
Yeah. I do a 1 vector and it gets a 2 vector out. We cannot determine whether T is linear based on this information. Because what we know we get with this, if we know that probably C times T of A is equal to C T of C times A, but we also need the other property of linearity. I'm not sure if that's a word, but I'm saying it is. So
X squared would satisfy this transformation.
Wait, shouldn't for all the linear transformations the origin point that doesn't really change, right?
So we know
Yeah,
this one,
origin doesn't change.
but we and like also it's this then this, not this
If this,
then
yeah.
RNL gang.
this. Or we're not gang. Oh, gang shit. So we cannot determine.
Like x squared would be a valid answer for
Yeah.
that transformation technically.
Okay, so we input a 5 long matrix, and then we get out a 1 wide matrix. So that means our matrix is actually just this size, and that is 1 by 5. The hesitation in me. If so, this is true.
It's the second one. It's the exact thing we were talking about.
Yeah. Exactly. So it's like this implies that, not this implies that.
Mm.
Okay, and this was which one? This was the update your knowledge.
3. Update your knowledge on 4. Yeah.
How many? 18. That's like
It's
oh,
doable.
Yeah, I think that's doable. That's doable. It's fine.
Yeah.
I think this is the shortest one out of all the post-lecture exercises.
No,
There
it's
is one
just-
with 8. There's one with 8, I think.
Really?
Was it determined
I
one or
seem
something like
to
that?
remember one with 12 or something.
There's no
Oh,
way that's
well.
not just the update your knowledge. Like, I swear.
No, I don't think so. There is one post lectures exercise that was less than 10, I think. I think
Okay.
at least less than 15.
Wow,
Yeah,
okay.
I think it might have been 12.
So we know right now that we have this vector, and we multiply it by x, and that is equal to that. So that is indeed just ax equal to b. That's an augmented vector or augmented matrix. An augmented vector. You just got vectored. And they just ask for a vector whose image is this. Oh, we can do some quick maths on this. So we can add 2 times this one to that one. That will become -4, and this will become -2. We can divide this one by 6. We can add 2 times this one to that one. I was like looking at this like but yeah. And well, I think that's it really. So now the question is, what is x? We just have to find one vector so that x1, x2, x3 satisfy these equations. So we know x3 has to be 2. We know x2, x3, -3, x1. Actually, I'm gonna turn this around. Makes it a little easier. So we know our vector has to be in. This is 3 by 3, so our vector has to be 1 by 3. We know the last one has to be 2. The second one doesn't matter, I don't think. It's free one. And the first one, we know that 3
-3.
minus 3 minus
8.
yeah, no, sorry, minus 8 is
3x,
equal to,
3x, yeah, 3x
yeah.
minus 8 equals
So if we
-1.
have 3 times x1, then we will get then we'll
Wait.
get 9. 9 minus 8 is wait.
Wait.
Yeah, we had the vote. We had the same thing. So yeah, this would say that 9 minus or 9 plus 8 is equal to -1. That's not the case. So we should have -3. So that should be -9 plus 8 is equal to -1. Yep.
Yep.
Okay. I was just making sure that you like understood. But yeah, this is the case. Okay. How many vectors have the image this one under transformation t? Well, b is a free variable, so what's this what we got? Yeah. So infinitely many because b can be whatever you want it to be. Right?
Yeah, I think so.
Cool. Dude, we are gaming. Find all vectors in R4 that are mapped to the 0 vector by the transformation x becomes a of x. Give your answer in parametric vector form. Okay. Delete all of this. -2, -3, -5, -1. Oh. Becomes 0. This becomes 4, 4, 10. This becomes -13. You have never seen somebody fill in a vector the way I do. What you?
Yes, because you're doing it wrong.
No. This is good. This is good. This is just my
We can
unique
fix
way of
it.
filling in
It's
a
still
vector.
recoverable.
This is just my unique way of filling in a vector. Okay, so we have a matrix. Filling in a vector. Fuck off, matrix.
At least there's plenty of learning opportunities with your filling in of a
Exactly.
vector.
Exactly. There's a bunch of prime numbers in here.
They really do like their prime numbers.
Yeah, I'm gonna add 2 times the top one to the bottom one. Then I'm gonna add 2 times the top one to, or subtract 2 times the top one from this one. Then I'm gonna subtract 3 times top one from this one. So I said 3, so that's 6. This is 1. Then I'm going to add this one to add this one to the bottom one. So then we get 0, 0, something that can be turned into a 1 by some kind of scalar multiplication. That means that I can turn all of these into zeros. Okay, then I'm gonna add, I'm gonna subtract 2 of the top one from this one. Wait, does that mean that this is also a 0? Yeah. Huh. And then I'm gonna add, then I'm gonna subtract 3 times this one from the top one. -9, that is -4. Okay, so this is our eventual answer, right? And then that are mapped to the 0 vector. Yeah, so then we have to find out what x is with this. So we know for a fact that x4 is equal to 0. We can already put that in our answer. Let's see, what else do we have? We have a free vector, x3. Yeah, because it's a homogeneous system. We know that there's no what's it called? Like no part here that I have to add, so I can just write everything in terms of x3. So we know x1 is equal to, or x2 is equal to negative x3, or negative 3x3, and we know or x1 is equal to 2x3. Therefore, let's see. Okay, x3 is always equal to 1 of itself. 1x2 is equal to negative 3x3. Does that mean that, do we just enter negative 3 and 2 in here?
Yeah, I think so.
Okay, sounds good. Yeah. Hey, okay, cool.
Hey.
We Gucci. We gaming. And now the next one. Does the vector lie in the range of the transformation? Explain your answer to yourself. In the range, so that can be an output. We can check that by actually we can check if this is a multiple of that, right? No, that's not true. Because that would be asking if this is an input which would result in a 0 vector. Yeah. Okay, so we can check this by, oh shit, delete instead of backspace. -2, -3, -5, -1, 3, -10, -14, 18, -10, -13, -7, -4, 6, 4, 7, 13, 4, 4, 21, 11. Okay. So first thing I'm gonna do is I'm gonna flip all these signs because that's easier for me. Get a negative here, flip all these signs because I really dislike dealing with negatives. Then I'm gonna add 3 times or 2 times this, or subtract 2 times this from this one. So that becomes 1. This becomes yeah, and this becomes this one, and then we subtract -6, so we add 6, and this becomes 4. Then I'm gonna subtract 2 times this one from this one. So this becomes a 0. This becomes a 1. This becomes 3. This
Someone has
becomes
an
an
echo.
8, and this becomes a 18 minus -6, so that's 18 plus 6, that's like this. Okay, and then I'm gonna subtract 3 times top one from this one, so that is 2. This becomes 6. This becomes 1, and this becomes -5. Okay, next one, I'm gonna work with this one, so I'm gonna subtract 2 times this one from this one. Minus, that's gonna -3, and then I'm gonna subtract -12, so that's adding 12, that is 7. Same for the top one, so subtract 1, 6, and we subtract -4, adding 4, that's 8. Then I'm gonna add okay, realistically, if I'm gonna add 2 times this one to this one, and this is gonna become 0, and this is gonna become what is that? Like 6. And we know that this is never true because yeah, 0x1, 0x2, 0x3, 0x4 is never equal to -6, so that is no. Alright. I mean, realistically, we only have 11, right? Because 7 is not included. So we are... That does make my division a lot more annoying, but whatever. Let this be the linear transformation defined by this. Use a rectangular coordinate system to plot the vectors. Which is the following geometric description. Okay, let's have a look. Paint.net, busting out the paint. So we have our two-dimensional axis that is perfectly straight because of Paint.net's ability to make straight lines. We have the line -3, -3, or the point -3, -3. I'm gonna make a little dot here. So this is V. Then we have -2, 0. So that's -2, 0. That's like here. And this is U. And this is V. Now let's see what the transformation is. So I'm gonna make our get rid of this. Oh, get rid of this stuff real quick. So then we have -1, 0, 0, -1, and then when I do -3, -3, this is gonna become 3, and this is gonna become 3. So the T of U is gonna be a 3, 3. I think this is just a reflection through the origin, but we'll see. So this is gonna be T of U. And then when I enter -2 and then 0, well, this is going to become 2 and this is going to become 0. So yeah, it's just a reflection through the origin. I'm gonna finish the picture real quick before I delete it.
Third one?
Hmm?
The third one? The rotate over.
Oh, it rotates by radians. Yeah, okay, that makes sense.
Yeah.
Because that's a reflection through the origin, it's the same thing. Oh.
Yeah.
It's scaled all vector by the same factor, namely -1.
Oh right,
Actually
yeah, because
multiple
it's.
answers correct then. That's cool. We might
I hope
actually
that
get a
doesn't
green
happen on
percent
the
this one.
exam. I hope that don't happen on the exam though.
What is a geometric description? This is just scaling it by a third, right? Because if this one is scaling it by -1, then this is scaling it by a third. So it scales all vectors by the same factor. Let's go! Using my instinct. Now, next question. So we have U is -3, 2. We have V is 1, -1. And then we have the vector 0, the matrix 0, 0, 0, 1. I think this might just project it onto the x2 axis, but we'll have a look. So we'll have -3, 2. Well, this is going to be 0, and this is going to be 2. Yeah, so it's always going to just drop it down to the two x's. That which is what we call the y-axis. So this one would be dropped down to here. This would be dropped down to here. So this is just going to be this one. Is there any other correct? Okay, no. Okay. Use the fact t is linear to find t of 2u. Well, okay, that's the t of 2u is equal to 2 times t of u is equal to 0, -18, right? Is that correct? So t of 2u is equal to 2 times t of u is equal to 2 times this is equal to this. Check my answer. -1 times t of v, that's equal to... I'm going through these relatively quickly, but that's just because these are using stuff we already know. Oh, and this is interesting. So we have t of 2u minus 1v is equal to t of 2u minus t of 1v is equal to 2 times t of u minus t of v. So we have this one twice minus this one. So that's going to be -3, and this is -18. Oh wait, minus 3, so it's 3. And this -18 minus 3 is -21. Okay. So let's see, what else do we have? Linear transformation, and that's E1 to that. Okay. So we now know actually that the vector of like what it's called, a standard vector of this transformation is equal to -2, 1, and 3, 3. So we can use this to find the this and the fact that it's linear to find this, and it's just going to be equal to -9 minus 2, that is -11, and this is -9 plus 1, that's -8, so it's 11, 8. Or -11, -8. Oh. Is that correct? -9 plus 1, -9 minus 2. Yep. The same thing, right? Is this the same thing? -2, and yep. Okay, well that's also relatively easy, because that's just, let's see, so this is x1, x2. So we have 3x2 minus 2x1. Oh well, I mean, realistically that's just, and this is going to be x, I should be using subscript, excuse me. So all of these are still relatively easy, but I think we're still in the pre-lecture exercise, right? Oh no, this is already the post? Okay. Pog champion. Plus 3x2. Yeah, okay. So we're already a third of the way through this one, and we're only like busy for, what? Like 20 minutes? Only. Let this be a linear transformation, and let the linearly dependent set in Rn. Will this be a linearly dependent set as well? Actually, we've done this before. We've done this in the thing, so I'm gonna explain this real quick. This is a pretty important one to know. So the very definition of linear dependence is that v1 c1 plus v2 c2 plus v3 c3 is equal to 0, right? So we know that this is true. Let's see, okay? So then what we can do is we can get the linear transformation on both sides. V3 C3 is equal to t of 0. Recompile. Oh, yeah, I forgot to make a new line here. Okay, but now that we know this, we also know that the t of this thing plus the t of this thing plus the t of this thing is equal to t of 0. And we know t of 0 is equal to 0. That's given. Or that's like part of the definition of a linear independence. Or it can be concluded from the definition of linear independence. Let me say it like that. That means we can get these constants out of the bracket. And then when we recompile, you will see that actually C1 times the transformation of V1 plus C2 times transformation of V2 plus C3 times transformation of V3 is equal to 0. Therefore, these three are now still linearly dependent. Yeah. There we go. Do we still have enough people? Yeah, we still have like 19 people to go. That's good. What do you guys say? When we're done with this, do we want to have like a quick lunch break?
Yeah, I would say so. I think I'm starting losing concentration now.
Yeah. We have like 10 more to go and then we have a lunch break, but this one is easy. Is the transformation given by this thing linear? Yep. Is transformation given by this thing linear? Oh wait, what?
No, which would be the best way to prove that this transformation is linear?
Huh. Okay. Due to
Wait,
the technical
what?
limitations of Gasple.
So both of them are correct.
Yeah.
Just random choose one. Both of them work.
Let's go. Okay.
Which one do you click?
I clicked the top one.
Actually, for me, the bottom one just said it was wrong and just refused to go further.
Ha! Nice. Is the transformation given by this thing linear? You've changed both. Is effect a matrix transformation? Give the matrix A. Well, I mean, isn't that just 1, 1, 2, -1, 2, 2? Isn't this just the matrix?
Shouldn't it be switched around? Or wait.
Because we know that t of x is equal to a times x, and if we multiply the vector, let me say x1, x2, if we multiply the vector x1, x2 by this matrix, you will get this matrix. So I'm sure this is correct. Is transformation given by this thing linear? No, because there's a multiplication. Choose a tactic that is not linear. Let's see, what would be the easiest way? This one. It does not hold this property because we can have the vector. Yeah, let's see. So we can have. Let me make some space here real quick. 1, 0 plus 0 plus 1, 1. And because one of these will be 0, that means the whole row for this one will be 0. But it doesn't necessarily have to be the case for the other one. So let's have a look. I think these vectors will work, but we're gonna have a look if they do. So this is my vector v u. This is my vector v. I'm gonna clear this one out to do the actual multiplication. So we will have. Wait, I can't just do multiplication because it's not. Okay, whatever. So it's 0 x1 plus 2x2. So for the first one, that's actually going to be, I'm going to put them over here. So this x1, x2. So that is 0 here. This is 2, x1, x0. Well, since one of mine is 0, this is going to be 0 as well. And this is going to be 2. And this one it is going to be 2. It's going to be 2. And it's going to be what is this? 0. And then if we have the matrix 2, 1, that's going to equate in 2. And this one will be 2 times 2 times 1. This is going to be 4. And this is going to be this is 4 minus 2. That's 2. So Jesus fuck, that's a lot of writing.
Jure?
Yeah.
I hate to break it to you, we're not gonna buy it at $120. It's up €15 or $15 pre-market.
Yeah, I saw. But that's just Hedgie trying to shove the pre-market. We'll see.
We'll see.
If it reaches 120, I'm gonna buy more. If not, then whatever.
Yeah. Okay.
So we
Sorry.
have the vector 1, 0, comma. Then we have the vector 1, 1. Fuck. I hate the fact that you can't control that here. 1, 1, comma. Then we have t of u, or t of u, so that is 0, 0, 1, or 0, 0, 2, comma. Then we will get t of v, that is 2, 2, 0, comma. And then we have t of u plus v. And that's going to be 2, 4, 2. Check my answer. Let's go! Okay. We're halfway through this one. After this, we're having a break, so it's good. This one is linear. Yeah. A bunch of text. I don't care. Let this be the linear transformation that first rotates each point counterclockwise in the origin by this radius and then reflects the line x1 and x2. Find the standard matrix of this. Okay, so for our first thing, we had the rotational matrix, right? That was, and I'm gonna do this by heart.
Cos minus
Cos.
sine, sine, cos. I
Cos
think.
minus sine, sine. And I'm filling them in because like in this way, but because that way it's easier for me to remember. Do it however the hell you want to remember it. Whatever works best for you. Okay. So let's see. So we need the cosine of 3 pi over 2. And everything basically of 3 pi over 2. And I don't even have to calculate this. I can just leave it like this because actually we do have to realize real quick. It says counterclockwise. Is that the way that
Yeah,
actual rotations go?
That's the good direction.
Okay. Because there have been questions where it's like, yeah, it rotates clockwise. Oh, you should have done minus or 2 pi minus whatever the fuck we were doing.
Yeah, no, it's counterclockwise is the good direction.
Okay.
And to be honest, if they ask me to do clockwise, I'll probably just do counterclockwise, but then do it like the spin up until where I need to be.
Yeah. Anyway, so we first have this one, and then it reflects through the line x1 is equal to x2. So wouldn't that just be the matrix? Wait, the line x1 is equal to x2.
That's just
Wait, that's just like
line
this
to
line.
the origin, yeah.
So how would we do this in a matrix form? We didn't. Wait, we already did that, right? So that is the -1, 0, -1, 0, right? Like, oh, like this one. Let me actually try if this is what I think it is. So if I have this thing and the point 1, 1, this is going to be -1, this is going to be -1. That's such a trivial example, but it without a doubt I have proven. Okay, so we first have to take this matrix, and I'm going to move this one out of the way real quick. So it's going to be 0, 1. Oh, moved it down too much. So what's going to happen with 0, 1 is going to be negative sine 3 pi over 2. And this is going to be cosine of 3 pi over 2. And then this stuff gets used as the input for this thing. So then we get -1 times. Yes, this is. Okay, yeah. I was wondering if what I did before was correct. But I think it is. So this is going to be negative cosine times 3 pi over 2. So for our x coordinate, or sorry, not x coordinate, for the first part of the vector. First of all, I'm a dumbass. This is the second part of the vector. And the first part of the vector is actually going to look like this, because we multiply with the identity matrix, like indirectly, right? So then we get cos 3 pi over 2, and this thing is sine 3 pi over 2. Then we use this as input, and then we get negative cosine 3 pi over 2, and negative sine 3 pi over 2. So this is going to be our first one. So this will eventually be our matrix, these four. Now I really hope I'm correct. So negative cosine 3 pi over 2. This is going to be sine 3 pi over 2. This this is going to be negative sine 3 pi over 2. And this is going to be negative cosine 3 pi over 2. I think this should be correct. Fuck! Okay. Oh, that's annoying. Why is this not correct?
Hello?
Yeah.
Oh, okay, no, sorry, my Discord will just random disconnecting me somehow, so my internet's dead.
Yeah.
Okay. No worries.
I don't know. At the same time, I got some sound problem.
Why would this not be correct though? Maybe they're not allowing us to use the sine and cosine functions.
They're just -1. Sine 3 pi over 2 is just -1, and cosine 3 pi over 2 is just
0.
0. Yeah.
So this is gonna be. This is just 0. And this is just 0. This is just
So be.
-1. And this is just
Oops.
1. That's annoying. Then I fucked up somewhere here. Either that or this matrix is not doing the right thing that I expected to. So it reflects it through the line x1 is equal to x2. So now if I have a point here, so that's negative, or negative 3, 2, what's going to come out of this?
Yeah, I think your matrix is wrong because the way that you have it now, if you let's say you put a dot on the like take a point that's on the line, technically that point should stay in the same place if it's reflected. But what you're doing is you're doing a how do you call it, a reflection across if the line would be perpendicular to itself, like the other
Oh
way.
wait, yeah, I'm doing a reflection through like the point in
Yeah,
the origin, and it should be a reflection across the line. How would we do a reflection across the line
like
though?
for example, take the point 1, 1, and then you'll see that it's wrong.
Yeah, 1, 1 should stay 1, 1, and this is going to turn it into -1, -1.
Exactly.
How do we do it then?
I think maybe the other way around.
Yeah,
No.
like this you mean?
Yeah,
Just
maybe
switch the order of
I don't know.
rows. Just switch order of rows.
Yeah, like this.
Yeah.
Okay, so this would be -2, and this would be 3. So -2, 3, is that the correct answer here? -2, 3. Or Wait. No, this is wrong.
Hmm.
Or either I fucked up something up. That could also very well be the case. So -3 to -3 2. So that's -3 2. Yeah. And that becomes.
I think there's a slide with
-2,
this
3.
information on it. If
There probably is. So let's see. We're already giving examples.
You're the one with the houses.
Reflection across the line. Well, they give an example, but they're not giving the formula that comes with it. What
Let me
if?
check in my book. I did this question before.
Wait, I think I know it. So what if instead of having -1 here, it's just like 1 1? Because we know for a fact that this 1 1 will make it stay the same, right? Because this is just the identity matrix, and multiplying something by the identity matrix doesn't change much.
Mhm.
But if we do it like this, yeah, this definitely changes it. So this becomes 2, and this becomes -3. So this is the thing we have to do.
Oh yeah, because then the x becomes the y and the y becomes yeah.
Yeah, that makes a lot of sense. Okay.
Yeah, makes we're ooga boogas, man.
Okay, but so let's see. Then all this does is it turns around these two variables, so we have to work a bunch less with this. Anyways, this is the right row. So the right row stays. Yeah. So this just becomes this, and then instead of multiplying this around, it just becomes. Oh. Then we just swap these two around. Oh. Yeah. Okay. And then for these two, we just grab these two and swap them around as well. So this. Oh. This will go here. And this one will go here. And we already did some calculations on the sine and the cosine, so we know that whether the sine was 0 and the cosine was -1? Let me actually look. No, the cosine was 0 and the sine is -1. So this is -1, this is 0, this is 1, this is 0. You. Nice! Ugh. Dankjewel, Jelle. We are almost done with this post lecture thing, and then I'm gonna have lunch as well. There's even more! Okay. Be linear transformation that first reflects through the line and then rotates. Isn't that exactly the same? No, that's not. We don't know that for sure. So that's basically what happens if we insert this matrix into here instead. So instead of inserting this matrix into here. So what happens then? If I have this one, then this row becomes. Yeah, so this is different. So this row becomes the cosine of. Oh no, this becomes the negative sine of 3 pi over 2. And this becomes the. This is good. And then the second row is actually this one. 0, 1. And that just stays like this, but then this sign gets changed. Okay, so then we get a 2 by 2 matrix with. So this was 0, yeah. So this is 1, 0, -1, 0. Okay. So this is just this matrix, but with the minus sign swapped. Oh god, is this just a bunch of this? Okay, I'm gonna do like 1 or 2 more, and if we get them all, then I'm just gonna call it a break. Okay. The linear transformation first perform the horizontal shear that transforms E into E2 minus 2E1, leaving E1 unchanged, and then reflects it through the line. Okay, they actually want us to build a geometric intuition of what matrix multiplications like these do. I'm very bad at those, but we're gonna see how far we get. So we want something that when you that turns E2 into E2 minus 2E1 and leaves E1 unchanged. So wouldn't that be like E2 into negative 2E1 and E2. Let's see if this actually does what I think it does. So we have the vector 3, 4. This remains 3 and this becomes 4 minus 6. So that is, yeah, okay. So this is the matrix that we want it to be like for that. And then reflects it through the line. Okay, well we already work with that, so that's 0, 1, 1, 0. But that's just equal to the matrix of like this one when we swap these two around. So that will become 1, minus 2, 1, 0. Fuck, why is that not oh.
You should also change the first row,
Yeah,
first
I
column.
forgot, I
Yeah.
forgot to swap this one.
What?
First performs a horizontal shear that transforms E2 into this thing. That's this matrix, yeah. And then reflects it through this line. Okay, wait.
You're supposed to change the second column instead of the first one, I think.
Let me actually check then, because okay, so the first line is gonna be is negative 2, and it's gonna be 1. Yeah, so that was correct. And 0, 1. This is gonna become 1, 0. What the fuck? This should just be correct, huh?
You might just skip, and we can see the correct answer.
A very good call.
Huh.
Wait, so it's what I have, but then flipped around.
What?
I think I was doing it like in the other direction. Like unintuitively, but or unintended, but I think that's what's happening.
Okay, I'm actually confused by this. How does it get the result? Wait, I don't get it.
Mm-hmm. I don't know, but oh shit, what they said made sense though. So I don't know.
I'll have a look back when you upload it to YouTube, maybe.
Yeah.
Because this
Sor-
does
I
confuse me a
accidentally
little
skipped
bit.
it. I accidentally skipped it. That was my bad.
No worry. No worry.
By tx is equal to. Wait, by dx is equal to. Oh, huh? Well, okay. I mean that's not too bad, because that's just equal to 0x1 plus 2x2. So that's just this vector. But how?
0002. That's
So then
the
I
one
just-
I come up with.
So then I just enter 001 into here, and I see what comes out of there. So here we get 0, and here we get 1. Is that what I'm saying correct now? Huh. Okay, wait. So we have the matrix 0, 2x, 2, and I'm gonna call it 0x1, which is equal to 0x1 or 0, 2 times x. No, wait, that's not, because then it would be like this entire row would be that. So this is not what I'm supposed to be doing. They really want us to have a geometric intuition. That sucks. Dx is equal to, first thing is always 0, second thing is, I mean, if the first thing is always 0. Okay, first of all, our standard matrix should be it goes from 3 to 2. So it should be how long? 3, 3, 2, 2. So let's see. So if I have a matrix like this, if you enter a 3, yeah, okay. So our matrix should look like this. And this thing is going to be, all the top rows are always going to be 0. Oh, and I should put it downwards one more. Because no matter what we enter here, the top row is always 0. And this is going to be 0, 2, 0. Yeah, this makes sense. Because what this matrix actually says is the vector is going to be equal to 0x1 plus 0x2 plus 0x3. And the bottom one is going to be equal to 0x1 plus 2x2 plus 0x3. So this makes sense. And then the standard matrix is just going to be that one. There we go. From T4 into R? Interesting flex. So that means our vector of our matrix will look like this, and we will enter a, yeah, we enter a, wait, no, like this. And we enter a 4y thing, and that's just going to return into something in x1. So let me cut this, put it here. Yeah, so when we enter it like this, then the output is going to be x1. So we have a 1/4 matrix, and that's literally just going to be 1, 2, -2, 1. There we go. Oh, this one is so easy. I love this. Which one? So where U and V are shown. Okay, so this is one U, V, and this is one U. So if you have, yeah. So if we have 2 of this one and 1 of this one, that's going to be 1. Oh, -1. Sorry. So 1, 2, and then -1. So that's going to be C. Does everybody like understand what I did here?
Can you explain?
Okay, good. So we have the T of 2, V, 2, -1. That's equal to T of 2, 0 plus T of 0, -1. And that's equal to minus like this, and this is equal to 2 times like this. So you have 2 times transformation of 1, 0, and minus 1 times transformation of 0, 1. And since this is a standard matrix U, V, I know that U is equal to this vector, and V is equal to this vector. So like these are E1 and E0, or E1 and E2. So if I have 2 times the E1 minus 1 times E0, or E2, fuck, I keep fucking that shit up, I get, okay, so this is E1, so we get E1, E1 again, minus E2, and then we end up here. Yeah, this is really like an intuition thing.
I got it. I got it. So you're just using you're just changing it to like something times a unit vector, and you based on the scalars and trying to figure out which point. I got it.
Yeah.
All right.
Yeah.
Thank you.
Okay, you're welcome. You figured to find a vector in x so that such that t of x is equal to f. Okay, well that's relatively easy. So we get to f by having going 1 times to v and then -3 times, or 1 times to u and -3 times to v. And since the it's like this, therefore the vector is going to be 1, -3. Two more to go. Ugh. Huh, this is interesting. How are we supposed to do this? Let's have a look. Oh, actually, that's easy. So I'm gonna use the fact that I want to have E1, which is equal to 1, or actually let's start with E2, which is equal to 0, 1, right? Therefore, this is equal to U minus V. Therefore, the transformation of E2 is equal to the transformation of U minus V is equal to the transformation of U minus the transformation of V. So we know the first row is -5 minus -3, -5 plus 3, that is -2. And -12 minus -9, that's -3. And now that we have the transformation of the first one, we can just, let's see. So we know this one. Okay, so we know that V, so that's this one, plus 2 times E2, right? Because E2, or is it plus? No, it's minus, sorry. V minus 2 times E2 is equal to -1, 0, right? So then if we multiply that all by -1, then we get the first like vector. So E1. I fucked this up. This should be E2. So therefore, if I do T of -1 opening bracket V minus 2E2 is equal to T of 1, 0. Therefore, -1 times T, or just negative V minus 2E2 is equal to, is equal to transformation, I keep mispressing stuff, 1, 0. Therefore, negative T of V plus T, 2 times T of E2 is going to be equal to the transformation of 1, 0. So negative transformation of V is going to be 1, -2. And then we add 2 times what we already had. That's going to be -4, -6 is equal to -3, -8. Oh. Damn it. You know what? I actually believe.
Should it be -1 and 3? Yeah, that's what I got. You probably make a calculation mistake
Yeah,
somewhere.
I made a calculation mistake somewhere. I see. Okay. But my method itself was correct, so that's good. Okay, so now I'm going to calculate this again. So E2 is equal to V minus 3U. So the transformation of E2 is equal to the transformation of V minus 3 times the transformation of U. Therefore, the transformation of E2 is equal to 3, -9, 3, -9, -3, minus 3 times transformation of U. So that's minus 0, -9, -3. I'm using this scuff notation now. I won't be using this for long, but for now it should be fine. So that's going to be 3, well, 9 minus 9 minus -9 is 0. And then -3 minus -3 is equal to 0 as well. So it's going to be 3. Oh, I'm calculating E3 or E2. Okay, so now we have to find a way with to go to E1. Well, that's going to be U minus E2 times -1, right? So then we get the transformation of negative U, or negative U minus E1 or E2 is equal to minus the transformation of U minus E2 equals is equals to minus t times transformation of u plus transformation of e2 is equal to transformation of e2 minus transformation of u. Oh, forgot my bracket. We know the transformation of e2, that's 3, 0, 0, and we know the transformation of u, that is 0, negative 3, negative 1. Therefore, this is going to be 3, 3, 1. Okay, so my method was correct. Okay. Well, that is the end of the post-lecture exercises, at least I think, of...
For yeah.
Yeah, except for the additional practice material, but fuck that. Let me see actually about my settings. So do I have a way to pause this stuff? Page up, okay. Okay, so let's have a break. Let's say, what do you think? Like 10 minutes, 30 minutes, some. It doesn't take too long.
15. I would say 15 minutes.
Yeah,
maybe.
something like that. We can do until like 5 past
3. So that will work.
Yeah. So we are already 4 out of 11. Good job, everybody. Enjoy your break.
All right.
spare coochie?
Oh, hell no. I hate men. Hey, girl. Oh, God.
Alright, that should be back. So I've got somewhat of an idea. Because I've extrapolated the data that we have so far. And if we continue on our current pace, we are going to be done by 9 PM tonight. I'd like to have dinner. So I think it might be best to just do 1 to 10 now, and then like 11 and 12, like Wednesday. What do you guys think?
Sorry, I just came back. What did you say?
No worries. I thought, what if we did like 1 to 10 today, and then like 11 and 12, and like Wednesday?
I mean, we can see at what time it is when we reach 10.
That's true, but like with the pace we're currently going, it's gonna be about 9 o'clock when we reach 10.
I mean, isn't it kind of going to defeat the purpose if you do the last few ones on Wednesday when we have the midterm tomorrow?
Yeah, but the
The
last few
midterm
ones aren't
doesn't
on a
include
midterm.
11 and 12.
Wait, they aren't?
No.
No, they aren't.
It's just the 10?
Yeah, 1
Yep.
to 10.
Yeah.
Oh, okay.
That's also why we are doing like it wouldn't be too much of an issue. We did not then like 11 and 12 somewhere else. It's just that I want to do them because I used it. I'm not gonna do the midterm, but I use this as a as a way to not have to do this twice before the exam. If you get what I mean. So I'm just splitting up my workload, and then if I can help you guys prepare for the midterm, then I might as well, you know. Anyways, I think we should be ready again. I think my unpause button is the same as my pause button, so I can just do Okay, let's start with the lecture 5 pre-exercises because we're not going to do any of this shit.
Oh yes.
So let's
Freaking
see,
hell.
what is lecture 5 about? I mean, to be honest, that 50-minute break did help a lot.
Yep.
I was just so fucking dull, man. Okay, lecture slides. So we have matrix addition and scalar
That was easy.
multiplication. Yeah, matrix addition is just add, add the things and multiply the things and woo. It's not. This isn't all this important, I think. This is important. Like see the identity matrix makes sense. The diagonal matrix, okay, we know that, and the lower and upper triangle, yeah, we also know that. Okay, so we know this. This all seems relatively easy. Yeah, I'm still so not used to the fact that like multiplication is like a times b is not the same as b times a, which is like really weird for me. Oh, this as well. Ugh, like this stuff makes sense, but it's like so annoying because this is s after t, but by reading it, like I don't know, this stuff sometimes fucks with my brain. Now we have to
Just
you have to do t first, but t is like the last one, if you get what I mean.
yeah. I mean, just consider the dot as another bracket I was thinking of. Like, the last one always has a priority because that was close. Like, which one is closer to the x? Which one have the more priority? That's how I
Yeah,
remember
okay,
it.
that's a good one. Or you could think of like the dot as another bracket, so you have like s
Yeah,
of opening bracket, t of opening bracket, x closing bracket.
yeah, that's a definition. But like, I just remember which one you have to do. Which one is closer to x, and you do that first, and then onto it. Like you are doing it from inside out.
Yeah, that makes sense. Okay. The standard matrix of the composite mapping. Okay, well this So wait, the product of A and B in that order equal to the standard matrix of the composite mapping of doing T first and then S, so S after T. S after T. Okay. Okay, that makes sense. So AB, so that is, so wait, AB is equal to A after B then, or let's see. Product AB is T first. Yeah, okay, so if you apply B first and then A, then you get the matrix AB.
Yeah, yeah,
Yeah, okay, cause like, yeah, here, B first and then A, and then you get this
yeah.
thing, which is AB. Okay. So as you can see, I have a little bit more issue with these slides than the previous ones, but that's alright. That's the matrix vector product. That can become the matrix product, which is not too much difficult. This thing is interesting though, because people here are using like only a specific row of a certain matrix. Because I usually just do the entire thing, but this is also a lot smarter for doing like smaller multiplications. Yeah. So let's see. I thought there was a list of. What is this? Oh yeah, okay. So these are, it just added the rule so that the identity matrix can be multiplied as well, and that's like allowed.
Wait, what? The I underscore n. That's the identity matrix, right?
Yeah, identity
The
matrix
IM,
of
yeah.
size m.
Okay.
Yeah, so m by m.
Okay.
Yep. Yeah, this makes sense because this is like, if you rotate it by whatever the fuck this is, phi radians, and then doing it again, that's equal to rotating it by 2 phi radians. So this is intuitively true, and probably also true by the double angle formula. Ooh, the transpose of a matrix. This is interesting. So it's interchanging the rows and columns, which is like, I kind of imagine it by drawing a line through this and then flipping all of them, but that's also not quite. It works, but you have to draw the line like this in this case because it's like it gets put on their side. So I think their way of explaining is like interchanging the rows and columns of A works better. Yeah, that's actually a good one. So we know this about it. Oh, that's interesting. So this is not true. That's okay. Oh yeah, because I forgot about this one. So when you have the product of A, of like matrix A and matrix B, if you transpose that, then you get the product of the transpose matrix of B times the transpose matrix of A. So that was like, that was something I didn't expect. And let's see. Okay, so this is all for this lecture. It's gonna be quite interesting. We'll see. Luckily, this one should be relatively easy. Yeah, easy. So this is 15 minus 10, so that's 5. This is 21 minus 2, that's 19. This is 18 minus 10, that's 8. And this is negative 9 minus, or negative 9 plus 2, that's negative 7. I really hope I have that one wrong. Okay, now. It does exist. So then we have negative 7, negative 2, 3, 9. This one doesn't exist. Yeah, so about this one. So if we transpose this, then we can look at this row, and we can write that as a column. And then this row, we can write that as a column. And then this row as well. So we get negative 4, 2, 1. Okay. The matrix of A and the transpose of the matrix is this, but we know that the transpose of the transpose is the original matrix, so we can just transpose this again. Then we get negative 4, 0, 5, 1. Well, that was a short split. Okay. Update your knowledge. Practice now. Is the sum A plus B defined? Well, yeah, because they're the same size. Is sum A plus C defined? Well, no. Is the product A times C defined? No, I don't think so. But C times A is defined, because they have a 4 times 7 and a 7 times 3. And the way I remember it is, if you have like, let me actually remove this real quick. If you have a n times m matrix, and you multiply that by m times p, that is allowed. So as long as these two numbers are the same, it's allowed. So in our case, we had a 4 times 7 multiplied by a 7 by 3 matrix. This is allowed because these two 7s are the same. However, it's not allowed if if this is just any other number. Suppose A plus the transpose of B exists. Does A plus B exist? No. What? Wait. Oh, because you also have I forgot to think about square matrices. But if you have a square matrix, then the dimension of B transpose stays the same. So then A plus B transpose is the same as A plus B.
Yeah.
And for this one, it may exist as. Oh yeah, because even if this is like a 2x4 and B is a 4x2, then this becomes a 4x2 and a 4x2, and this becomes a 2x4 and a 2x4. So it does always exist. I see. I got both of these wrong. I'm just pretty bad today. This may exist or may not exist. And ooh,
Yeah. Because the number of rows will be the number of columns.
yep, that's a good call. So imagine we have like a equals n times m, and b equals m times n, or yeah, m times n. Then if we transpose that, you will get a plus b t is equal to, they're both n times n. But if you have
Yeah.
a times b, then we'll have n times m multiplied by m times n, and these two m's are the same, so therefore it exists. That was really confusing with a lot of m's and n's, but I hope you guys get me.
Plus the symbol you used aren't the best because you
Yeah,
had
correct.
times n and then you use cross for the multiplication.
Yeah, I should probably just write down by instead. If the size of matrix 3 by 5 matrix A is 5 by 3 and the product AB is size 5 by 7, what's the size of B? So that is 3 by 7. Yeah. 3x7. Yeah. How many rows does B have if BC is a 4 by 5 matrix? Well, that's 4. Because if we know that BC is equal to 4 by 5, then we know that B times C is equal to 4 by M times M by 5. And we don't know what M is, but it doesn't matter because we only care about the amount of rows, and that's the first one. How many columns does C have? C is a 3 by 2 matrix. 2 by the same logic. Let A be an M times N matrix and B be an N times P matrix. Which of the following statements is true? Each of the columns of AB is a linear combination of A. Okay, as I was like somebody said earlier that they visualized matrix transformations by having it like imagine we have the matrix 1, 2, 3, 4. I multiply that by like 1, 2. So what they imagined is they had like this one, turn it on the side. Oh shit, and multiplied that by these columns. So this will be a linear combinations of the columns in here. And even if this is a matrix instead of a vector, that will still hold. So it will be a linear combinations of the columns of the first one, so A. They probably do a way better job of explaining this than I do, so. Yeah, okay, this makes sense. Yeah. So we know this one is true. This one isn't true because this is going to be BT AT. This one is true. This one is true. And this one is true. Okay. Whoa, that was the update your knowledge. And now the post-lecture exercise. And now it's going to get interesting. Well, this is... Okay, that's... This is going to get interesting. That's the easiest fucking question in the universe. Okay. So let me see. Let me first get rid of this. So if we have the matrix 3, 0, 0, -2.
You actually have to write that down.
Very much so, because I am very dumb. So this is going to be -9. This is going to be -6.
Well, talk about being dumb.
This is -8.
Your top left answer.
Top left center. This one?
Answer. Yeah, that one.
Well, this is 0 times 3 plus 0 times 3.
Oh wait, yeah, bro. I'm so stupid. I'm so tired.
It happens. So this is 0, -9, -6, -8. I think. Let's go. Yeah, this is allowed as well. Oh, fuck. So let me erase all of this. So then we have here the matrix -5, 2, -5, -5, -2, -5, -3, -2, 1, -2, 5, 1, 3, 2, 2, 5. So this row is going to be, first of all I'm going to write down the scale. So this row is going to be -10 plus 2 plus 10. So this is just going to be equal to 2. This is going to be -25 plus 6 minus 25 again. Is that true? Yeah. And it's -50 plus 6, -44. And here we will have -10 minus 2 plus 10, so that's just going to be 2 again. Is that the case? Wait, no, that's not true.
Negative?
Yeah, it's -2. I was about to say, that doesn't make sense. So then we have -25 minus 6 minus 25. So then we have -56. And here we have 2 minus 2 plus 6. So that's going to be equal to 6. And this is going to be 5 minus 6 minus 15. So this is going to be equal to -16. Okay, 2, -44, -2, -56, 6, -16. There we go. Okay, well, if all the questions are like this, I don't mind. Especially these ones. Oh. Okay, so we have -4, 4, -2, -2, -1, 1, -1, 1, -2. And here you can write down -3, 2, 3. So this is going to be -6 plus 8 plus 12, which is going to be equal to 14. Here we have 3 minus 2 plus 6, which is equal to 7. And here we have -6 plus 2 plus 3. So that's equal to -1. So we have a 3 by 1 matrix, vector, whatever. That's 14, 7, -1. Thank God it didn't register that backslash. Ooh, now we get more. No, not more interesting. It's still like the same difficulty. It's just longer. -3, 0.
We basically just got more to compute.
Yeah, exactly. They think we're computers.
But like, that's the 4th out of 16 questions. At this rhythm.
Realistically speaking, if we extrapolate using just the latest data. So this is going to be -9 plus 8, so that's going to be -1. This is going to be 3 plus 12, that is 16. Is that correct? Yeah. And this is going to be 6 plus
3 plus 12 is not 16.
Thank you. And this is 26. I said it. I was like, is that correct? And I was like, no. And I was like, yeah. And I was like, no. thanks for correcting me. So then we have 3 minus 6, that's negative 3. Here we have 5 minus 9, that's negative 4. Here we have just literally minus 15. Here we have negative 15. Minus 10, so that's negative 25. Here we have negative 25 minus 15, so that's negative 40. And here we have negative 25. By this rhythm, we are going to be done with all of these questions within like... There's going to be a gold split if you get what I'm saying.
No, what I'm saying, I was talking about the fact that we had increasingly large things to compute.
Oh god,
And
that as well.
And so that's the fourth question. So at this rhythm, we'll have a 9x9 matrix or something for the
Yeah.
final one.
Oh, this is actually plus 10 because it's positive 25 minus minus 15. So this is not negative 40. This is plus 10. No, we're good 3. Oh no, fuck off. So this is 5 times. Okay. I think it's probably some mistake with me fucking up negative sign, negative number times negative number, like, you know, this one. This positive 5. Oh no, actually I did that one right. Huh. 12 plus 3, that's 15, yeah. Negative 9 plus...
I think the left bottom one.
The left bottom one. So this is negative 15. No,
It's
this
not
is
negative.
positive 15. Okay, yeah, thank you. I knew it was something with 2 negative signs because I fuck that shit up all the time. So it's positive 15 minus 10, that is 5. We've been busy with linear algebra for 4 hours. We're almost, well, not even halfway, but you get the point. Like, let's go. So this is, oh, lovely. Can we have more like that? Oh, fuck. I have a song in my head by Mother, and it's super annoying. It's also a super good song. So it's negative 1, negative 3, negative 1, 5, negative 5, 4, and then 4, wait, I fucked it up. 4, negative 4, which is going to be 12, minus 4, that is 8. This is going to be negative 20, minus 4, that is negative 24. This is going to be oh, I looked the wrong number. This is going to be negative 16, minus 20, that's negative 36. I hope all questions are like this. 8, negative 24, negative 36. Graph linear algebra, any or single question percent, like 10 seconds. Okay. So what we have now is...
I'm sure that there is one question that we've answered in less than a second already.
Yeah, okay, that's true. I know there's like that one question where it's like longest, and then it took like less than 5 seconds.
Yeah.
So we have a times b, that's 0, negative 15, negative 12, 1. And b is 1, negative 15, negative 12, k. So then we will do... why these large numbers, man? What did I do to you guys? So 12 times 15, that's like 3 times 5 times 12, that's 3 times 60, that's positive 180. And then, yeah, plus 0, okay. And this is going to be positive 180 plus k. And this is going to be negative 12 minus 12, so that's negative 24. And this is going to be negative 15k. And then the other way around, that's going to be, where am I going to do that? I'm going to do that right here. So then we have 1, negative 15, negative 12k. And then over here we'll have 0, negative 15, negative 12, 1. So well, this is just going to be equal to 180 again. This is going to be, yep, yeah, that makes sense. Here we have negative 15 minus 15 again. That's going to be negative 30. Yeah. Here we have k plus 180, and here we have minus 12k, and that's it. So we have to have negative 24. So like the things we have is the top left is always the same. We have negative 15k is equal to negative 30. We have negative 24 is equal to negative 12k. And we have k plus 180 is equal to 180 plus k. These systems of three equations only hold when k is equal to 2. K is equal to 2. There we go. Construct a 2x2 matrix such that AB is equal to the 0 matrix. Use two different non-zero columns for whatever, blah blah blah. Okay, so we need to have AB equal to 0. So this is negative 3, negative 6, 3, 6. And then this is what we have to fill in over here and over here. So the easiest solution would be having what would that be? 1, negative 2? Because this would be 6, negative 6 plus 6. And this would be negative 6 plus 6 as well. And now if we have 2 and minus 4, does that work as well? But then we'll have negative 12 plus 12 plus 12, negative 12. Yeah. So then we have a 2x2 matrix. Negative 2, negative 4, 1, 2. Nice. Okay. If at any point I go too quickly, by the way, just let me know. Because I tend to go pretty quickly in over exercises like these.
I think it's fine.
Yeah, I think so too. But just in case people want it. So we have 1. Let's see. I'm not sure if I put this at the right place, but we'll see. 1, 2, 5, and then we have negative 1, 2, negative 1. Hey, level 80 fishing in RuneScape. Poke champion, guys.
Bruh.
Hey, that's a W in my book. And then we have to find numbers so that this works out. We can write like a little system of equations for this one. So we have negative 2 times if we write down like a here, a here, b here. So we have negative 2 times b plus a is equal to negative 1. And here we have 5b minus 2a is equal to 6. Huh. They should make like a system where you can plug these in and solve using row reduction to solve equations like this. That would be funny.
Probably already exists.
Yeah, it's almost as they're called matrices. So we're gonna subtract 2 times this, or we're gonna add 2 times the top row to the bottom row. That's gonna give us b. This is gonna go away, and this is gonna become 4. So b is 4. And now we can fill this in. So this becomes negative 8 plus a. Then we're gonna add 8 to both sides, and this is gonna become a is 7. So we have 7, 4. Oh, 4. And just to check if this is correct, I'm gonna do a little test so we can have, yeah, this is gonna be negative 8 plus 7. Yeah, that makes sense. Doing the same for this row, or same for this. Is it a row? No, it's a column. Same for this column. So we get negative 2b plus a. Yeah, plus a is equal to 2. Negative 2b, or negative 5, or positive 5b minus 2a is equal to negative 9. I mean, we can still use like the same strategy for solving this every single time. Just add top line to bottom, so we get b is equal to, see, 2 times top 1, that's like negative 5. Filling that in here gives 10 plus a is equal to 2, so a is equal to negative 8. This is going to be negative 8, and this is going to be negative 5. Wait, b is negative 5. Then this will become, oh yeah, okay, then I did do it right. And just to check, so in this one, b is negative 5 will result in, it's going to become minus 25. Minus 2 times minus 8. That's going to become plus 16. Yeah, okay. So this checks out. The math checks out. Okay, and then the last sum. So then we have this one is -1 and this one is 3. Add the top one twice to the bottom one. Then we have b is 1. This one is 1. And a is then -2. -2 plus a is -1. So a is then 1. Alright, so let's see. We'll have 7, -8, 1, 4, -5, 1. Dude, holy shit, we're good, guys. Okay, next one. Okay. So we have
U transpose.
U transposed, which is equal to 4, 1, 3. Oh, and V, which is A, B, C. So then we'll get 3C plus B plus 4A. Woo. Strictly
What?
speaking, the correct answer is a 1-by-1 matrix. They are
No,
correct.
but like, why did they put parentheses
Good question.
about around for A and B?
I would realistically have to put it like this. That's kind of dumb, but it makes sense. But it's kind of dumb.
I mean, that you can also just remove the parentheses. Like it does not matter. It's a
Yeah,
plus.
for this one, yeah, definitely. Like the
Yeah,
parentheses are there for no reason. It's just
I know it
them
just,
being dumb.
just weirds me out.
Yeah. So this is gonna be, wow, look at this. Is this the exact same thing again? Yeah, right? Yeah, it is. So then I'm gonna make the 1-by-1 matrix of 3C plus B plus 4A. Let's see, so let me check if I actually got this correct. Yeah, so this is V transpose and this is U. Compute U times V. Wait, didn't I already do this? No, I did U transpose times V, okay. Is that possible? Okay, let's have a look. So, U times V transpose. So that's 4, 1. Oh wait, no, 4, 1, 3. And then we had A, B, C, because it's V transpose, right? Yeah. So then it's going to be, oh god, 4A, 4B, 4C, A, B, C.
3A, 3B,
3A,
3C.
3B, 3C.
That is so hard.
Yeah, dude, I'm monkey brain. VU transpose, so then we'll have A, B, C here, and 4, 1, 3 here. So then we have a 3-by-3 matrix of 4A, or actually 4, what's 4 plus 1 plus 3? What's 4 plus 1 plus 3? So then we have, wait, no, I
4
can't
plus
do
1
that.
plus
That's
3
sad.
is 8, mate.
Hmm?
4 plus 1 plus 3 is 8.
Yeah, but like, I thought maybe I could like merge them, but I couldn't, obviously. So that's sad. 4B, B, 3B, 4C, C, 3C. Suppose A plus B transpose. Did we already do this one? Okay. Suppose A plus B transpose exists. Does A plus B exist? It may exist, it may not exist. It depends on if it's a square matrix or not. Suppose A plus B transpose exists. Does A plus B exist? Yes, it exists because 2 by 4. This would originally be 4 by 2. This becomes 2 by 4. This becomes 4 by 2 and 4 by 2. So yeah. Does this thing exist? We don't know. Maybe this is like both 3 by 3, then it does exist. But if it's just, if it's not, then it doesn't. A plus B transpose exists. Does A times B exist? Yes. We already did this one. Okay. Let A and B be the matrices whose product AB is defined. Suppose the second column of B is equal to the first column of B. What can you say about first and second? Huh. Okay. Whose product is defined. Suppose the second column of B is equal to the first column of B. So imagine we have a matrix here. So let's have a 2x2 matrix. So we're talking about columns. So that's this, like A, B, B. And then we have like it's equal. So it's like this. Yeah. So then we have 2b plus A. Here it's 2b plus A. Here we have 2b plus A. 2b plus A. Or wait, they just say what can we say about the first and second column of B. So I'm just gonna say A, B, C, D. This is gonna be 2b plus A. This is gonna be 2b plus A. This is gonna be 2D plus C, and this is gonna be 2D plus C. Hell, fucking hell, they're gonna be identical. Yeah. Yeah. Okay, that makes sense. Suppose the second row of B is equal to the first row of B. So the second row of B. So then we would have one. Wait, didn't we just have this? Huh?
The rows are identical. Now you have the columns that are identical.
Oh. Yeah, I see. So then we'd have 1, 2, 1, 2, which will lead to like let's see, A plus B, 2A plus 2B, C plus D, 2C plus 2D. We cannot draw any conclusion from them. That's sad. Let A and B be matrices whose product AB is defined. We were doing so well as well. I'm so sad. Suppose the third column be equal to the sum of the first two columns. What can you say about the third column of AB? It's not this one. So it's either this one or this one. So the third column of B is equal to the sum of the first two columns. And B is the one up here. So imagine we have 1, 2, 3, right? So this is the third column, this is the first two columns. And we have a number here, 3. It's gonna be 3, 6, and it's gonna be 9. So I think, all in all, yep, homogeneous. Suppose the columns of B are linearly dependent. What can you say about columns of AB? Ooh. So let me think about this. So we know that for the columns of B, so let's call them B1, B2, B3. We know that they are linearly dependent. Therefore, C times, or C1, B1, I'm going to do everything in caps because then I don't have to be bothered by autocorrection, plus C2, B2, plus C3, B3 is equal to 0. But what can we say about columns of AB? So if we have AB, that means this is the same as saying AB1 plus AB2 plus AB3, which would be the same as saying C times A times B1, C2 A times B2, C3 A times B3. And multiplying these things by A is the same, like, we can say that A is a standard vector for a linear, what's it called? Linear transformation. And if we know that this is a linear transformation, we already did this exercise, so the columns are linearly dependent. We did this exercise a while back with linear transformations instead of this. That was, I think, the fastest. Oh wait, no, this probably wasn't the post exercise, right? This was just the. This was the post exercise. I thought it was like the update your knowledge. Holy shit, we rushed.
I mean,
through.
that was still like a good 30 minutes.
Yeah, okay, but it felt pretty easy. I didn't have anywhere I was like,
Oh yeah. No, it wasn't difficult,
yeah.
but like,
So
yeah.
that means we're almost like halfway. Only 20 hours in. Okay. So let's go over the lectures of so let's see, that's invertibility. Oh god. Let's have a look.
It's the extended list.
Yep. Invertible. Well, we know the determinant of a 2 by 2 matrix is that one times that one minus that one times that one. And an invertible matrix, a matrix is only invertible if we have
Non-zero determinant.
yeah. So let me see. What was the inverse of a 2 by 2 matrix again? Does he say that everywhere? Okay, no. Whatever. I mean, from this we can guess that it's the for a 2 by 2 matrix it is 1 over the determinant, and then you swap these two around and swap the sign of these two. All right, that's interesting, I guess. If A is an invertible n by n matrix, then for each B, the equation has the unique solution by taking the inverse of B. That makes sense. But it has to be a square, which also makes sense. So let's see what else. If A is invertible, oh, let them be invertible matrices. Then the inverse of A is also invertible, and that's just A. If AB is invertible, then AB inverse is inverse of B multiplied by the inverse of A. And we've seen something like this before, right? So we've seen this with the transpose. So if you did AB transpose, it would be transpose of B times transpose of A. Let's see what else. If A is invertible, then the inverse of the transpose is the transpose of the inverse. Okay. Algorithm for finding the inverse of A. Theorem. An n by n matrix A is invertible if and only if A is row equivalent to I of n. So this is just saying that it can be put into reduced echelon form, right? Or wait, no, reduced echelon form doesn't have, like, can have free variables. So this is just a reduced echelon form without any free variables. Is the identity matrix of n, of size n. Okay, this makes sense. Oh no, here we go, guys. Let's go. Ugh. I'm curious how many of these still hold if you, instead of having an A by A matrix. Oh wait, actually, can you have an inverse for a matrix that is not n by n? Like, for example, m by m, like 2 by 4 or 4 by 2 or something. Okay. I don't know, we'll see. Yeah, well, we just did this.
I don't think so. I think it's only square that has inverse.
Okay, thank you. That helps.
All right.
If A is an n by n matrix and linearly dependent columns, then A squared is also invertible. Invertible linear transformations. If there exists an information so that such that they are both, yeah, they're the inverse of each other. Okay, well this makes sense. This is all pretty logical. Okay. Okay, cool. Well then we have all the information for this. Let's have a look at the pre-lecture videos. Or the exercises. Compute the inverse of this matrix. Okay, well, we can do that. So then we have the original matrix and the identity matrix that's 2 by 2. And we row reduce the left part. So what I can do is I can I'm going to subtract multiply this one by 4, or this is going to be 12 then. Multiply this one by 3, be negative 15. This is going to be 12, and this is going to be 3. Then I'm going to add this one to the. I'm going to subtract. Now I'm going to add the top one to the bottom one. That makes sense. It's going to be 4. This is going to be 0. Then I'm going to multiply this one by minus. Actually, let me swap the rows first, real quick. Oh shit. Okay, and then I'm going to multiply everything by by 1 over negative 15. And it's just equal to negative 1 over 5. This doesn't simplify any further. I'm going to multiply this by negative 1 over 12. So this is negative 1 over this divided by 12. That's equal to this divided by 3. So this is going to be the yeah, this is going to be the matrix that we have to fill in, I think. So negative 4 divided by 15, negative 1 over 5. Oh shit. Negative 1 over 5, negative 1 over 3, 0. Okay, cool. Compute the inverse of this matrix. I have a feeling we're going to get a bunch more of those questions. Negative 2, 2, negative 2, 2. So let's see, we have this one times this one, that's negative 4. Or this one times this one, negative 4, minus this one times this one. This one has a determinant of 0, right? So then it doesn't exist. Negative 4 minus negative 4, yeah. So the inverse does not exist. Cool. And then the inverse of this one, well, negative 12 minus 6. Or minus 6, that's like negative 6, so whatever. Now we have 4, negative 2, negative 3, and 3. And I know there's a better way to do this for like 2 by 2 matrices, but I'm just going to do it this way because it works for me. So then I have 1, 1, 0, 0. Then I'm going to multiply the bottom row by, let's do 4, so that's 12, negative 12, 4. I'm going to multiply this row by, well, I mean, I don't have to, I think. So then I can subtract 6 times top row from the bottom row. Or let's just do 3 times top row from the bottom row, because that will be easier for me. So then this will become 0. Negative 12, negative 3, minus 3 times negative 2. That's plus 6. This is going to yeah, like that. And it's going to become negative 3. Then I can divide this all by 3. So this is going to become 2. This is going to become 1. This is going to become 4 over 3. Then I'm going to subtract this row from the top row. And this is going to become 0. So 1 minus minus 1, that's 2. And this becomes negative 4 over 3. I'm going to multiply here everything by negative 1/2. So this is going to become, flip the sign 1/2. Flip the sign 1/2. And this is going to become 2/3. I'm gonna divide everything here by 4. So this is 1. This is 2 over 4. That's 1 over 2. And this is 4 over 12. That is 1 over 3. Is that correct? So I had 4 over 3 divided by 4. Yeah, that's 1 over 3. That makes sense. I think I forgot to flip the sign, but we'll see. I think that's still correct. So 1/2, 1/2. And it's going to be negative 2/3, and this is going to be negative 1/3. Hey, that's pretty good. That's the pre-lecture exercise. Now the plot. So let me go back to lessons. I really hope the rest is just as easy as this one. Update your knowledge. Set to be invertible if, well, this is not true, this is not true. Well, this is not true because AC can be the identity matrix, but CA doesn't necessarily have to be, right? Not every square matrix, so then I guess. I mean, if this is the case, then it is invertible. That makes sense, so I guess this is the answer now. What? Then I guess this one. That's the definition? Oh, wait. Yeah, I guess that makes sense. Because if you have like A times A inverse is equal to identity matrix, and the A inverse is equal to times, oh shit, no, fuck, times A is equal to the identity matrix. I guess they just cancel each other out no matter which way you put them. Okay, that makes sense, cool. A and B are invertible matrices, then A, nope, this is false, this is inverse B inverse A. AD minus BC is not 0, then AB is invertible, true. Okay, wow, okay. I suddenly have a feeling I'm gonna get to eat tonight. I really hope the post-lecture exercises are better. Or, okay, 19. So then we have 4 minus 3, okay? Or negative 4 minus 3. Okay, whatever. So then we have... I leave my writing, shouldn't it? Negative 4, negative 1, 1, 0. Negative 3, 1, 0, 1. So then I'm gonna add this one to the top one. Then that will give me negative 7 here, 0 here, a 1 here. Then I think I'm gonna start by multiplying this one out by 7 and the top one by 3. Yeah, so this 7, this 7, this. The first one's not 7, right? No, it's the first one's 21. This one's 7. This one's 7. This one is 3. This one is 3. This is negative 21. Then I'm gonna subtract the bottom one. No, yeah, the top one from the bottom one. So then this becomes 0, this becomes 0, this becomes negative 3, and this becomes 4. Okay, then I'm gonna divide this one by 21. So this is gonna get, or divided by negative 21, so this is 0, 1, this is 1. Negative 1 over 7, this is negative 1 over 7. And then I'm gonna divide this one by 7, or by 1 over 7, sorry. And this is negative 3 over 7, this is 4 over 7. Okay. So then I'm gonna put the matrix 2 by 2 of negative 1 over 7, negative 1 over 7, negative 3 over 7, 4 over 7. Okay, that's nice. This is 0 minus 0 does not exist. I wish I exercised like this. This is -8. Yeah, okay. So we have to calculate this one out. 4, 5, 1, 0, -1, -2, 0, oh, 0, 1. So I'm gonna start out by adding this one times 4 to that one. So that will turn this into a 0, this into a -3, and this into a 4. And then I'm gonna multiply this one by -1/3. That's gonna turn this one into a 1, this one into a -1/3, and this one -4/3. Then I'm gonna add this one twice to this one. That's gonna come 0. This is gonna come -2/3. And oh god, what have I done? This is -8/3. And then I can subtract this, and this gets -5/3. Okay, and then I'm gonna multiply this one by -1. I think all in all, like, calculating the inversion of these is still relatively easy, but that's just because it's a 2x2 matrix. I'm interested to see how long it will take for me to do a bigger one. No, I didn't even fucking do that. Holy hell. Oh, I'm a dumbass. Okay, if you look at my right hand side, this is not an identity matrix. So this is 2/3, this is -1/3, this is -4/3, and this is 5/3. Oh my god, that's definitely gonna cost me points on the exam if I do stuff like that. Use your
Wait, what
previous.
exactly did you do?
So
Sorry,
I have this one. That should have been this one.
Oh, right. Yeah.
Yeah, because identity matrix is like from top left to bottom right, instead of the other way around. Use your previous result to solve the system. How? How does this help me solving a system? I genuinely don't know how that helps me. Okay, I'm just gonna do it again, honestly. So I'm gonna add 4 times this to the top one. So then we know that x2 is equal to -1. Then I can add 2 times this one to over here. This becomes 0, this becomes -2. So then x is equal to the matrix 2, or yeah, 2, -1. Is that findable anywhere here? No. Oh yeah, I guess I could have multiplied this by its inverse. Yeah. I guess. That makes sense. Fair. Ooh. So we have to calculate the determinant of this one. Did we actually learn how to calculate determinants yet?
Yeah.
In this one?
As in,
Yeah.
when
Yeah,
you
yeah.
teach in the lecture, no.
No, not in this
They
one.
said it's
Like not by this, like by lecture 6, but like we did learn it later, obviously.
Yeah.
Oh wait, but then I guess they would want you to try.
I guess they want us to just try then, right? Huh?
I mean, try with the identity matrix, please.
Yeah, exactly. So 0, 1, -2, -3, 3, 0, -9, 6, 8. And then we have the identity matrix here. Okay, so what I'm gonna do is I'm gonna add this one to the bottom one. Yeah, until this thing is gone. So I'm gonna add it 4 times. 4, 0, 10. Okay, then I'm gonna add this one to this one 3 times. Or subtract this one from this one 3 times. That's gonna be 0, This is gonna be 1. And this is gonna be -3. Then I'm gonna subtract this one from this one 3 times. This is gonna be 0, and this is gonna be subtracted 3 times. If I subtract -3 3 times, that becomes adding by 10. So, or adding by 9, that's gonna become 10. Then I can get this one as a 1 by dividing by -1/3. -1/3. And then I can get this one to there by dividing by... Is this true? Oh yeah, it is, okay. So I subtract this one from the top one, and this one goes like this. And this becomes -4, so that's like 3. This one becomes -3, that becomes just 3, and this one becomes -1. Then I multiply everything by -1/2. That will leave me with 1, -3/2, -3/2, and 1/2. And then I order the rows correctly. So it is possible, and the matrix is 0, -10/3, 0, 4, -3, 1, -3/2, -3/2, 1/2. So I made a calculation mistake somewhere. That's annoying. Okay. Let me follow my steps back. Okay, so this is the first thing. So then I add 3, or I subtract 3 times this one to this from this one. That will turn this into a 0, turn this into a -3, and this will stay the same, and this will become a -3. Then I'm gonna add 3 times this one to this one, turn this into a 0, turn this into a 2, and turn this into a 1. Then I'm gonna divide everything here by 2. And then I'm gonna... Okay, can you not? Then I'm gonna divide everything here by 1/3, or by -3? Yeah, I can do -3. That's 1.
That's -1/3.
-1, and this is
Wait, no, that's
-1/3.
Yep.
Yep, and I'm gonna add this one twice to the top one. So that's gonna become, make this 0, make this, well, twice, so that's just gonna become 1. This is gonna become -3.
It was already 1.
Oh,
If
then
you're
it's gonna
adding
become
the-
2, yeah, that's a good one.
Yeah.
Okay, and then I'm gonna add this one to this one, so it's gonna turn this into a 0. This is gonna become 2, this is gonna become this -3, this is gonna, yeah. So minus 1/3,
-10/3.
so that's gonna be -10/3. Yep, good call. So I'm gonna copy this one. I would totally prefer having Microsoft Word over pen and paper once I get my, or once I like have to do the exam. So what's different?
Yeah, the problem with pen and paper is it takes so much space.
Exactly. I like legitimately bring so many pieces of paper. It's not normal. So this is just normally 1/2. This one was correct. So I made a mistake somewhere, and this should be correct.
God damn it. I'm sure it's like one number off somewhere.
Yeah. How did I mess up twice though?
I think I know if you, because where you have the 1/2,
Yep.
I think the left bottom 1/2.
Yep.
I think you did some really weird calculations there, and I was kind of confused, but nobody noticed.
Yeah.
So if you go back, you might have to go back a bit, because you did something like subtract 3, and then it became 1 or something.
Okay, let's
I
have a
don't know
look.
what. I could be wrong, but that was the only thing that I.
So here I divided. Okay, so it was I think it was the first step I did then.
No, it was go back like you were at the right point.
Yeah. Okay. So I I subtracted 3 times the top one.
Yeah.
Or the middle one.
That was
Why do you
correct.
subtract? Oh yeah, okay, because minus minus plus.
Yeah, so this is gonna -3, this is gonna stay the same. And this is
Minus
-3.
3.
Yeah, but now you add 3, and you only added 1.
Oh, so
So
I
you
added
added
3 times the top one. Okay. So I think I can just change this one to a 3 then, and it should be right.
no.
Also, no.
You have
No,
It should be
because then
4
you
and
added
4
the
is up
last
to
one.
2. Yeah.
After you added the last one to the top one 2 times.
Okay, so this one should turn into
So
a
4.
4.
And also the middle one, the second 2 should be also be 4.
Okay.
And I think it's correct.
Ah, nice.
There we go.
Okay,
Yeah.
that was an experience.
I mean, same. If you didn't mess that one up, you nearly messed up the adding twice half.
Yeah.
Why the invertible is just the inverting matrix is just so hard to like, because if you make a mistake, it like took you like 10 minutes just to figure out where you were on.
Yeah, exactly. You just practically have to do it over again, and it's like really annoying.
Yep.
Oh. Okay, so what I'm gonna do is I'm going to subtract the top one from the. Wait, no, that doesn't make sense. I'm gonna subtract the bottom one from the top one. This is gonna become 0. This is gonna become -6, and this is gonna become -1. And then I am going to subtract the top one from this one. This is gonna become 0. This is gonna become 12. This is gonna become -1. This is gonna become 1. Then I'm gonna multiply the bottom one by 4. Yeah, that's probably the best way. And this is gonna become 36, and this is gonna become 4. Then I'm gonna subtract 3 times. Wait, are these multiples? Therefore, A is not invertible, right? Because there's no way we can get this to an echelon form since these are multiples of each other.
Can you go like 2 steps back so we actually can see the there? No, that's wait for like just where you multiplied.
This?
No, just the moment where you multiplied the bottom one, so you can actually see if you there. Yeah, there. Because you can also divide the middle one by 4. Then you have -1 and 3.
Yep. So that
Yeah,
doesn't exist.
And it's still.
I think it's a singular matrix. Yeah.
Yeah.
Oh,
That makes sense
this
because
is
if you cannot get to an echelon form or like the identity matrix, then it means it's not invertible. That's pretty cool. Okay. 0, -1, -3, 1, 0, 0. -3, 1, 12, 0, 1, 0. -9, 0, 27, 0, 0, 1. I love how they give us like some zeros already. Like they're like, hey, do a bunch of bullshit, but we're nice people. You can have this one. Okay, so I'm gonna add this row to this row. So that's gonna become a 0. That's gonna become a 9. This is gonna become a 1. Then I'm gonna see that these two are multiples of each other, and we're done.
Yeah.
Wow.
Singular matrix again.
I wish all of them were that easy. Like 2 steps in, you see, okay, that doesn't make sense. Well, unfortunately, I'm gonna guess that these two are not multiples.
Oh no.
Never lucky. 1, 5, 0, 1, 0, 0. It does give us a good starting point though, because I can already see what my first step is gonna be. 0, 1, 0, and then 3, 16, 2, 0, 0, 1. So I'm going to subtract this one from that one. Then we get -1 here. I should keep that one. This is going to become 0. This is going to become a 0. And this one, so 1 minus 2 is just going to be -3. Then I'm going to multiply by -1/3. That's going to turn this into a 1. Going to -1/3, and this is going to become 1/3. Then I'm going to multiply this one by 2 and subtract that from this one, yeah. This one is going to turn into a 0, and this one is going to become... Wait, so what did I do? I subtract 2 times the top one, okay. So I subtract 2 times negative 1 over 3. That's going to become adding 2 over 3. And I subtract 2 over 3, that's going to be 1 over 3. Okay, then these two, well this is, I just subtract 3 times the top one from the bottom one. Oh dude, this is such a good life, man. And then I'm gonna subtract 3 times the, 5 times the bottom one from the top one. So it's gonna be subtracting 5 times 3, same as adding 15. That's gonna be 16.
16, yep.
Yep, subtracting 3 times this is same as subtracting 2. Subtracting 3 times this is same as subtracting 1. Then I'm going to rearrange these.
I think you said
Uh,
subtracting one,
I
but
think you
you
meant...
added one. Yeah.
Which
Yeah, it should be minus 10 over 3.
Which one?
No, like so the last you said subtracting -1, but you made it +1.
Yep.
So let's see, for my last step, let me see what I did there. So for this one, I subtracted 4 or 5 times this one. Oh yeah, I thought I was doing 3 times that one, my bad. So then I subtract 5 times 3, 5 times negative 3, that's adding 15 at
15.
Then subtracting 5 times 2 divided by 3, that's subtracting 10 over 3. Wait, was there something here already?
No, just 0.
Okay.
No, just 0.
So that's just negative 10 over 3. And here's going to be negative 5 over 3.
5 over 0. And that should be it.
Yeah, I should not forget to...
Just the order is,
yeah.
the second row should be the 3rd row.
Yeah. Okay.
Oof.
16, negative 10 over 3. You guys remember when we had exercises, and if the numbers were fractions or anything like not really nice, then you know you did something wrong? That time was
Exception
long
for
gone.
inverse.
Hmm?
Mm.
Oh, God.
Let's go, baby.
Find the third column of the inverse of A without computing the other columns.
Huh?
What?
What?
How do you do that?
Wait, find a third column of the inverse of A without computing other columns?
I mean, we can try to
Well,
calculate.
okay, think about it. The inverse is when you multiply it with the matrix, it gives you the identity matrix, right?
Yeah.
Is there a way to...
No.
No, not that I can think of. What? That's weird.
We have a channel, like 15 people, and everybody's just like stumped.
Shouldn't we take the third column from the identity matrix and only use that one?
The third one or the first one?
Third.
Okay, yeah, that makes more sense. Yeah, we could. Let's see if that works.
I don't know, but maybe.
So then we have...
Let's hope.
We can try it, see if it works.
I would say the inverse is one of the hardest one. I would say.
This is stupid, because then we're still calculating everything.
You can leave the first and second column of the identity matrix away because they're all 0.
Oh, like this one? Like this, and then just...
Yeah.
Yeah.
Without
that's
computing
still
the
dumb, 'cause
other
we're still
columns.
reducing to an exponent
Oh.
form.
Yeah, that doesn't that like that.
Well,
doesn't
but at
change
least you're not
anything.
computing with the other columns.
Yeah, okay.
I mean,
As a
like,
question says.
sure, but that I don't
Doesn't
think
make
that's
sense
what
to
they're
do.
asking.
Yeah. Whatever, I'll do it. I'll bite. So, actually, is there anything I can do with these columns first? Because that's definitely going to be way easier. Because I don't have to add 1. Because I'm dumb. So, I'm going to add 2 times this one. So that's going to make this a 3. I'm going to make this a 3 as well.
Wait, go back. You're not adding 2 times that one.
I'm adding... Oh, I'm adding 1. Oh.
Mistake spotted.
Okay. Dude, this is such a fun course, man.
Beautiful.
Okay, then I'm going to subtract 2 times this one. So that's going to become a 0. That's going to become a 1. Is there anything else I can do? Not really. I mean, I guess to make it easier, I can multiply by... No. Okay, cool. Then I'm going to subtract 2 times this one from this one. No, I shouldn't do that. That's dumb. Why am I doing that? I should subtract... I should multiply this one by 2. Let's start with that. And then I'm going to subtract this one from this one. So then we have 0, up, 0. This becomes a 5. And this still stays the same, I think. Yeah.
Yeah.
Then I'm going to subtract... I'm going to multiply this by 2. So then I get... What's that? 10, 16, and 4. Then I'm gonna take 5 times the top column and subtract that from this column. So then we get this one becomes a 0. A 5 times this one. So that's like 1. And then we know that the last column is... Oh wait, no, actually we don't. Never mind. Then I'm gonna add 4 times this column, or subtract 3 times this column from the top column. So this is going to become 0, and this is going to become minus 12. Then I'm going to divide this one by 2. And then I'm going to add this one, or subtract this one from this one. That's going to become positive 6. And then I'm going to turn this into a 3. And oh my god, we're finally done. Yeah, so I'm going to reorder these real quick. Why does it keep thinking I'm trying to do some stuff with copy pasting when I'm actually doing stuff with copy pasting, but not what they want me to? Okay, so the answer is going to be the vector 3, -6, 4. So it is true. I mean,
Yeah,
I guess that's easier because...
They also say that you have to do it that way.
Yeah,
I guess.
exactly.
It's easier, but it's pretty stupid to do.
Yep.
Why would you only want the last column?
Yeah.
Yeah, exactly. Compute the inverse of this. Well, that's just... Well, I mean, there is that easy way, but I really CBA. 3, 3, 3, 5, 1, 0, 0, 1. Okay, subtract the bottom one from the top one. 0, 2, 0, minus 1. Divide this one by 2, then we get 1. That took way too long. And then divide everything by 3, so then we get 1, 1, 0, 1 over 3. Then subtract the top one from the bottom one, so then we get -1/2. And then this one is 1/3 minus 1/2. That's going to be -1/6.
Wait, you were subtracting a half, but you were subtracting minus a half.
Oh, you're right. So it's 5/6. I didn't know where I was in my row addition thing now. So where was I?
Yeah, you divide it by 3.
Oh yeah,
Because
I
it
was
was
busy with
3.
dividing by 3. Okay, it's going to become 1, 1, 1 over 3. Then subtract the top one from the bottom one. 0, -1/2. And then I add a half here, and a half plus a third is 5/6. And then I do the old switcheroo of the rows. Okay, and then I get the inverse. I'm gonna like do it less hastily when I'm actually doing an exam, by the way, so I can actually like take my time and
like as we said when we did the midterm
calculus.
Sample exam.
Yeah.
For the practice exam, you have a lot of time.
Yeah, exactly. And like I'm going to take my time on the actual exam, but I kind of want to be done with this as soon as possible. Like the.
Oh, because you want to sleep tonight.
Yeah, exactly. I know, I'm a pussy.
That's a good point. You want to sleep. Yeah. Yeah. You should not sleep. You want to study for linear algebra.
Yeah. Imagine sleeping. Okay, now realistically speaking, we know that if we have it like this, and we multiply both sides by the inverse of this thing. Well, actually, I'm not sure if we have. I know if we have x, a inverse, that's equal to x, right? Because a times a inverse is the identity matrix. But is that also the case if we have AXA inverse?
No, depending on the size, no.
But in this case here, right? So we have a x here, and we have a inverse as well. So they're saying, huh? Wait, can we multiply it so that it's on the left side? Then we'll have a inverse ax, and this is equal to x.
I mean, it was still equal to x, but it's.
And then we'll have a inverse times like whatever is on the right side. I'm gonna call it b, and that's gonna be equal to x. So then, okay, I think that will make sense. So I'm gonna take our answer, however not pretty it was. So I think it's this one, and that's gonna be the thing that we multiply by, and then here we have -1, 2, 1, -4, 5, -3. Is this actually the only way of doing this, or whatever?
I assume it's the only way because they want you to use the inverse.
Yeah, but like, is there a way to do it without the inverse, or no?
I guess not with the stuff we have. Maybe possible if we have more, but
That's true. I'm gonna, by the way, write everything in terms of sixths, and then I'm gonna get rid of the sixth, and I'm just gonna remind myself to put it like back afterwards, because that makes all the calculations a lot easier for my brain, my small little monkey brain.
okay, we'll try to remind you.
Yeah, thank you. So we have -20 plus 3, so that's going to be -17. Here we'll have 25 minus 6, so that's going to be 19. And here we'll have -15 minus 3, so that's -18. Yep. Here we'll have 12 minus 3, that's going to be 9. Here we'll have -15 plus 6, that's going to be -9. And here we'll have and here we'll have +9 plus 3, that's 12. So then I copy all these values and I go to the matrix here and I go
and divide them by 6.
Divide them by 6. Thank you. That's 19 over 6. That's -3. That is 1/2. Oh, 1. It's actually 1/1/2, but I CBA, so that's going to be 3 over 2. Is that correct? Yeah.
Minus 3 over 2.
Minus 3 over 2 here, and this is going to be 2. We are literal gods. We are untouchable. Okay, the statement is never true. Well, actually,
True for some particular matrix,
there
yeah.
are some matrices. Wait, I'm curious what their reasoning here is.
I think it's just basically saying if A-1, if AB is A-1 equal B inverse. Like if A inverse equal to B inverse, then that should work.
Yeah, I'm just like looking at the proof real quick. I mean, this makes sense. This is a pretty cool proof, honestly. Okay, whatever. Next one. Statement. This is always true. Two-by-three matrix. There exists a 3x2 matrix such that. Huh. True for some particular matrix A. Imagine if for all matrices A and B, if you just multiply them, you get the identity matrix. That would be cool. There could be some matrix where this is true, right? Is it not? And it's never true.
That's a long explanation, Jesus Christ.
I really don't want to look at this, but we're finding this for in terms of the diagonals only.
The identity matrix is 1, 1, 1. Multiplying that by itself. What would you even get?
I mean, the identity matrix squared is still the identity matrix, I think.
Yeah.
Yeah. Okay. If the determinant of a 2x2 matrix is non-zero, then A is invertible. Correct. If a 2x2 matrix is invertible, then the determinant is non-zero. If A, then B.
I think this is one of them that is both are true.
Well, the thing is, we know that A implies B, but we don't know if A is equal to saying the same thing as B. That sentence came out of my mouth very butched, but you get you get what I mean.
Yes,
No,
but
it was pretty clear.
Okay.
okay. But I do think it's both of them are true.
Yeah, I think it's only one. What?
Yeah, I think just check both. I think both are true.
Huh.
Because you have to be invertible with it's basically a condition. Because if wait, can you scroll up again? Like
oh yeah.
I was thinking like for the if it's invertible, then it has to be non-zero since it's part of the condition to make it invertible.
Yeah, okay, that makes sense. Alright, Yellow, what do you want to say? Nee, geen waar ik het over heb, dus waarschijnlijk niet. Saus? Ja, ja, ja. Ja, ik zie het. You idiot, you sold. Yeah. I don't think it's gonna go down to 120 again. Yeah, no, exactly, but it's for when I buy. Yeah. Anyways, I'll think about my stonks when it all is over, unless something drastic happens, but we'll see. If it dips, I'm buying the dip. In order for matrix B to be the inverse of the matrix A, both equations AB is I and BA is I need to be true. Well, yeah. That's like the definition. If A is an invertible m by a matrix, then the equation... Yep, this is consistent, that makes sense. So it has a pivot in each row. If A and B are invertible matrices of the same type, then A plus B is also an invertible matrix. Nope, doesn't have to be. Find an example to the statement above. Well, that's really easy. So, if I have the matrix 1, 1, 0, 0, the determinant of this one is 2 minus 0. That's, or 1 minus 0, which is just 1. If I have this one, 0, 1, 1, fuck me. 0, 1, 1, 0, then this is 0 minus 1, that's minus 1, also true. But if we add these two together, you get 1, 1, 1, 1, which is 0 determinant, and doesn't work. Oh. That also works. I thought this was a theorem. Yeah. Okay, cool. Let A be an invertible matrix and B and C be okay. AB is equal to BC. Does it follow that? Okay, my go-to for an invertible n by m matrix is honestly just 1, 0, 1, 0, or 1, 0, 0, 1, depending how you write it down. And if I have a 1, 0, 0, 1, so let's see, 1, 0, 0, 1, and I want the answer to be something. That AB is equal to BC. Well, if I have let's see what happens if I do 2, 2, 3, 3. What happens here? This is going to be 2. This is going to be 3. This is going to be 2. This is going to be 3. Okay, this is the identity matrix, so that makes sense. Okay, for the identity matrix, it won't hold. I know that much. What if I do... Huh. Actually, I think this does hold.
I think it's yes.
It doesn't. It doesn't. It
yes.
doesn't.
Oh no.
It
Wait.
doesn't hold. It doesn't hold.
Okay.
How come?
Can you give a counter example?
Yeah. You can use the I'm pretty sure you do 1 1 1 1.
1 1 1 1. All
But
right.
that's not invertible.
Yeah. And then
No, it's not invertible indeed.
oh wait, hold on. Okay. I'm pretty sure. I think it did. If I did
We're gonna
this,
see.
I would say yes first. I would
No,
say
no, it's
yes.
not. Wait,
It's
what?
true.
Wait, hold up.
Yeah, we can
I
we can
swear I did-
multiply by A inverse.
Yeah.
Oh, maybe it was
'Cause A
another
inverse-
question. Oh my god. Wait, go down. Oh,
Okay.
this was the one. Oh,
Yeah,
is
this
the
one
Oh,
is
sorry,
yes.
My bad. Yeah. Oh my god.
It happens. Okay, so A is invertible is necessary in the previous statement. So if it's not invertible, well, I mean, okay, hear me out, guys. Super interesting one. No, I'm gonna go a step further.
0 0 0 0. Are you gonna do a cast?
This is real high level maths, guys. Oh. University level.
Big brain.
Big brain.
This man. This is what do you call it?
Divide by 0.
Super math.
PogChamp. Oh. They're all square matrices.
Supposed to. What
Huh.
the?
This is interesting. So the inverse of this thing is the inverse of x times b. Determine x. Honestly, this just seems like something I'm just gonna plug into. Where is it? This one. And I'm gonna have a look with this. I'm gonna have fun. So if I have a minus ax, or let's actually say the one equation we have is a minus ax inverse is equal to x inverse b. So this is what we have, right? Like this is a given. Oh, x inverse actually, so that should be -1. Then I mean, we can check if x is the identity matrix, then A times the identity matrix is just A. The inverse of the identity matrix is just the identity matrix, right? I think it is. And therefore, then A minus A, that's just 0, so B could be 0. So I'm not sure if this is the only solution though. We just know that this one works.
But you now divide it by. Wait, why did you remove the x?
Because we said that X is the identity matrix. Like suppose this is true.
Oh, okay.
So we know that one works. We can try all the other examples, see if there's another one that works, but we can also try to determine it exactly. So what we can do is we can multiply by just A minus AX on both sides. See if that helps us. A minus AX. Then this will be just become the identity matrix. And then what does this do for us? We know that if we have a minus sum of a matrix like this, we can pull this stuff all inside of it. I know that much. And I also know that x times x inverse will lead to this. So we have the identity matrix equal to A times the inverse of x times b minus A times b. I guess I can get b out of the brackets. So then I'll have this. Isn't this exactly what I had before? No, okay, I didn't. I'm really curious what the solution to this one is going to be. Okay, wait. What happens if I indeed multiply this one out, then subtract by this one, multiply everything by -1, then multiply by A inverse on the left side. Oh, I see. So we can solve it like that. That's cool. So A inverse on the left side. That will leave us with this. But A inverse and A will cancel out here. And so will it here. Oh, actually, and this should also be A inverse then. And this was I. So then I can... Wait, was that the case? Let me check what I did just now, because I think I made a mistake. Why the hell do I have a 1 there? Oh, yeah, okay. So I was flipping the signs and I put a -1 instead of a -I. I should have been a -I. But yeah, I can multiply by A inverse on both sides. And that will also multiply it over here. Then we recompile and we get this. This looks like a fucking mess to work with. I get rid of the A over here. I get rid of the A over here. And I add the... Also, a matrix times identity matrix is just the original matrix, right? So I can get rid of this one. Then I can multiply this by, or add this on both sides. Then... Huh. I'm doing stuff wrong, but we'll see what. So I can multiply by the inverse of... Oh, wait, no. I cannot multiply by the inverse of B, because we don't know that B is invertible. What happens if I multiply everything by x? I get x here, I get xb here, I get x here. This thing falls away. So that leaves me with this solution. B equals to x times B plus x times A inverse.
That's weird.
I have given up on this question.
It is impossible.
No,
Damn it. It's the identity matrix. Damn it.
No,
I
I was
think
in
it
the
might be BA plus the identity matrix.
I was in the other.
Oh,
No,
it's
okay.
any of the other ones.
we correctly use the switch out to avoid off the correct answer. Damn,
Yeah.
we.
Left multiplication of the given equation. So we did this. I know this one. Expanding the brackets. Oh, I didn't think about expanding the brackets. So then we get this. Yeah, that makes sense. Fucking hell. This is like really cool to look at how this works though. So
Anyway.
and like you can also left multiply and right multiply by matrices. That's also pretty cool to think about.
But...
Okay, so this is, was it the lecture 6 all the post or was this
Yes.
just... Oh, it
Yes.
was. So then I can go to my...
I think finally.
And we can skip everything of lecture 7. So we only have 8, 9, and 10 to go, and then we're gonna do like 11
Let's
and
go.
12 tomorrow.
I don't think anyone would do that tomorrow.
Or not tomorrow, like the Wednesday.
Wednesday maybe? Yeah,
Yeah.
that would be better.
Yeah, no, I meant Wednesday. My bad.
Alright. Subspace.
Oh. Okay, the subspace stuff was pretty reasonable, I think. So that's good.
I think one of the hardest is one is inverse and the other one is like the what's the other one? What's the other one called? Nothing. Never mind.
Okay.
It's just my brain started falling apart now after hours of math.
Yeah, I understand. I think we might actually I think this one might actually end up being the longest we have done so far, even when skipping a bunch of the exercises. Because I think the longest we did so far was like 8 hours and a bit from calculus.
And that was the whole course.
Yeah, that was the whole course. So if we did everything from this, it would be even worse.
Yeah. God. Oh.
Okay. This one doesn't pick subspace because it doesn't go through 0. Subspace, or yep. 0 is in W, makes sense. Yep, cool. Well, we just had that. Okay. Null space and column space. Well, it's just the solutions so that AX is equal to 0. Column space is the span of all the columns. Oh, that's cool. We didn't have this picture in our slide. That's actually really cool.
Max just making his slide. He just.
Yeah. Mox makes his own stuff, but Mox is cool. I like Mox.
Yeah, I do.
He
I mean,
goes really
only
fucking
by.
fast, but then like we're done 15 minutes early.
But I mean, the only issue is his noise always makes me sleepy at the same time. But, like.
Yeah. What is the column space of A equal to? Oh yeah, I remember this one. We did this. Yeah, this one is like an easy to see because you can tell that these three are linearly independent. Okay. Basis of a subspace. Different bases for a subspace W will have the same number of vectors. That's good. It's good to know at least. Okay, basis of column space. The pivot columns make a basis for the column space, but that makes sense because the rest is not linearly independent. So that actually makes sense, yeah. Okay. What the fuck? Okay, flex.
I hope the idea of traffic flow won't be on the test.
No, it won't be because we didn't have it.
Oh, okay, nice.
Yeah, I think it's just like. Oh, I think this sign might mean that it's something like more than what you have to know.
Oh, it's more like a detour, as in for
Yeah, exactly.
for
Like
linear
one
algebra.
of those useless detours.
I think it's it's more like deep knowledge, like interesting to know, but not necessary.
Yeah.
The detours, I don't know if it's really interesting to know.
Yeah, I'm not gonna pay any attention to them. Yeah, like we are here to learn what we have to learn and what's gonna be on the test. It's that easy. At least it's that way for me.
That is all what uni is about.
Exactly. Blocking and getting sixes. That's what we do. Okay. Figure below shows a set in R squared marked in blue. Is it a subspace? It goes through R0 and it's a subset of R2. So yes.
No, it's not. For CU, it's not.
Oh fuck! Yep.
Also for U plus H, it might be not.
Yeah, no, I didn't realize about those conditions. I thought, yeah, okay.
There is 3, remember?
No. Hey, I got it right, Pog.
Bruh.
Wow, you got a 50-50 in 2 tries. Good job.
Thank you. Well, this is obviously not because it's not going through the origin.
Yeah.
I don't think it is.
No, it's not. Because if you have the edges one sum it together, yeah, that will give you one like out of the bound.
But does that mean that everything within bounds, if you sum it, they cannot be out of bounds?
Yes, you have to be every one of the UNH within bound. If then sum it has to be in bound also.
That's really cool. Okay, cool. I mean, that's yeah, okay. That's literally one of the rules, but now I know what it means. Okay. Decide which of the three conditions hold for the following set. So for the empty set, well, this one, not. Well, this one is, and for this one as well, because there are no. So it is vacantly true. So only A. What do you mean?
No, it's B and C. Which holds? Which holds? A doesn't hold. A doesn't hold because there's no vector.
So it's all.
No, it's B and C. It's B and C only. A doesn't hold, and B and C holds
Holy
because
shit!
there
I
is
forgot.
vaguely true.
I didn't read the question right. Thank you. I got
Hey.
I got something that I knew how. What? Oh, okay. Which of the following? Yeah. R3 is a subspace of R3. The solid sphere consisting of all vectors which have a length of at most 1. I mean, realistically, if you have a subspace that does not infinitely reach on, then it's not a subspace, because then you cannot multiply it by like a really big number and it will be in there,
Yeah.
So we can say, okay, which length has at most 1? 0 is in there, which is good. I mean, yeah, okay, we know that, yeah. The addition is not true and the scalar is not true, so only A, I think. Yep. Whoa, okay, so... the set of vectors... Well, I mean, yeah, 0 is in here, so we know that much. And... Let's see, if we have a scalar of that, if we have like 1 and 1, and if we do that by like 5, then we get... Okay, 1 and 1 is a bad example. Wait, I mean, this is only the ones for which x1 is x2. So I think they all hold. And the sum...
Yeah, I think so.
Yeah, okay. No, okay.
Oh wait, no.
I mean, here x1 is.
Oh.
They could also be negative, positive.
Oh, yeah, I forgot about negative.
Right.
Dude, holy shit, man. Negative numbers exist?
What?
What the fuck? No way.
Recently, a Dutch student had just discovered there is negative numbers.
Dude, negative numbers? Oh, holy shit. Okay. I was like, yeah, we can just take the square root on both sides. No worries, man.
So A holds. At least A holds. That's all we know.
Yeah, A holds. We know that. What about B? If I have negative 1 and 1, and I scale that by like 5, I think that one holds as well. But if I take negative 1 and 1 and I add 1 and 1 to that, then I get like 0 and 2, which is not the same. So I think only A and C. Only took me 3 tries. The set of vectors on a plane. Well, yeah, they do, I think. All 0 is 0. If you multiply, yeah, I think they hold. Yeah, there we go. 2 vectors in math 3.
When Grossois is stuck.
This one doesn't, because the A is not in there. For B, I don't know.
I don't think so.
No, I don't think so, because if we do like, first of all, if we do 2 times all the vectors, then this one will hold and 3 out, so none of them. Yeah, okay.
Yay.
Yeah. Holy shit. That's the pre-lectures of 8. We're going hard, boys. Only 2.5 more to go. And now we get the fun stuff of 8. Update your knowledge. Only 4.
Let's hope we can get it done before 6.
Is it possible for the bases of a subspace to contain a 0 vector? No, because they have to be linearly independent.
Right, and
oh
the
right,
vectors
yeah.
are always dependent to other
Holy
vectors.
fuck! They're writing in cursive. They're doing some fucking what's that called? Lexicography or whatever the fuck when you write really cool. Holy hell! Okay.
Calligraphy.
Thank you. That's the word I was looking for. They're doing some calligraphy bullshit. Whoa. Okay. Give integer p so that's the null space v is a subspace of a subspace.
of RP.
Wait, if I have like the span of, like if I have a span containing one, like one vector, can it be a subspace of R to the power 5?
It could.
Okay, well then, what?
No, I swear you need
No.
5 vectors.
So it has to be exactly. It doesn't have to be that or more.
Yeah, it needs to be exact.
Oh yeah, then we'd need to have like 5 null vectors. No, wait.
Shouldn't it be R2 though?
It's either R2 or R4. We know that much, but either that
Oh,
or
okay.
maybe one of these is like, maybe they're not all linearly.
I mean, it is linear independent. Quite obvious because there's only 2 vector. So it's, if A is not multiple of B, then it's linear independent.
Yeah, yeah.
As a 4 too, we can make a guess. I think it's 2 though. Yeah.
Right. Yeah.
Because you only have 2 null space
they're not
possible
dependent,
maximum.
That means they have 2 pivots.
Yeah.
And then yeah, okay, that makes sense. Give integer q so that well, I mean, if this is 2, then I'm gonna give a nice little guess. Okay. Such that. Oh god, wait, no, that's like. There's either 3 and 4. Oh fuck. So the column
Promo,
space
can
is
I help you?
the column space is the amount of columns, right? So the column space is 3, 4.
Should be 4 and the null space should be 3.
Oh.
Null
wait.
is always a vertical and column is always horizontal. It's quite different than understanding it, but
Rows
yes.
and columns. Wait, so
There's a theorem on the slide if you want to have a look. There's like the null space of null A of an mx and m times n matrix of A is always a subspace of Rn.
okay, let me have a look if I can find that, because that's actually interesting if that exists.
Yep, there you go.
The null space is always equal to the amount of rows, columns, and the column space is the rows. Why? Name it the row space then. Okay. I'm just fucking around, by the way. Which of the following statements true for each matrix A? The pivot columns of A itself form a basis of the column. Yeah, this seems right. Pivot column is a reduced. No, this is not true. The solutions are equal. No. The columns are. No, it's only the pivot columns. I'm super smart. That's not true. Okay, how many does this have? Only 16. 16, that's alright. What's the geometrical interpretation of a subspace of R cubed which has a basis consisting of 4 vectors? Such a subspace does not exist. Because 4 vectors in R3, a subspace has to be linearly independent, right? You cannot have 4 linearly independent vectors in R3. I am like, if like 10-year-old me would be hearing me babble on right now, like all of these fancy ass words, he'd be like, holy shit, I am a smart person in the future. Okay. Can 2 subspaces...
Until you learn linear algebra.
I wish I didn't. Can 2 subspaces of a vector space be disjoint? No, a subspace has to go through 0, right? So they can't.
What does it mean by disjoint again?
When like they have 0 elements in common.
Oh.
But they have at least the 0 element in common. So. Okay. Is W in the subspace generated by V1 and V2? Well, then we just have to solve for C1 V1 plus C2 V2 equals W, right?
Yep.
So we can do that relatively easily. We can say I'm gonna call C1, I'm gonna call that X, and C2 I'm gonna call it Y. So we'll have 2x minus 4y is equal to 8. I'm gonna have well, I mean, actually the question is only, is it in the subspace? I think it's... It doesn't actually have to be, so I'm actually gonna calculate that, yeah. 3x
I think...
minus 5y is equal
No.
to 2, and 5x plus 8y is equal to -9. Okay, so I can multiply all of these. I probably should do this in like a vector form. That would be, or in a matrix form. That would be probably a lot easier. I'm gonna add 2 times the top one to the bottom one. That's gonna get rid of this. That's gonna add 4 of these, so that's like 9, and it's gonna add 16, so that's gonna be positive 7. So we have 9x equal to 7, so x is equal to 7 over 9. And then I can fill that in here to find. Oh, that's a multiplication. So then we have 7 over 3. Then we get a 5. Yeah, okay, so I can subtract this one to the other side. And I can multiply everything by -1. And then divide it by 5. 5. Then I can get rid of these ones. And I can divide this by 5. Divide this by 15. However, if we then fill that in the last thing that we didn't use yet, then I'm going to turn this to a plus and make brackets out of this. And we also had an x value that I by this time already forgot, which is probably pretty dumb. I'm going to copy this, put it in here, and then Control Z. What was my x value? Seven over 9. Okay, so what I have is this thing, and x is 7 over 9, so this is going to be 7 over 18. No, that's not correct. That is 14 over 9. So I'm going to multiply these all by 4, so that's going to be 8. And it's going to be, what is that? 4 times 7, that's 28. Let's see, this is less than 2. So I have like 158. This is less than 2, this is 138, and this is less than 2. This is like 113. So there's no way this is equal to 8, so this is not in subspace. There's probably an easier way to do that, but I don't care. So we have these 3 things. How many vectors are in this thing? I mean,
Set.
3.
Yes.
Holy hell, guys!
This kind of our
This is
question
amazing.
always pissed me off. Just like they're playing wording with this kind of question.
Yeah, exactly. God. Jimmy is going to the moon, but I want to buy more. Stop going to the moon, SMH. How many vectors are there in the column span of A? They should have used square brackets here, SMH. So the column span, well, it's a 3 by 3 matrix, so the answer is going to be 3. Oh,
No.
wait.
No, you have to row reduction
Yeah, I
at
have to do
first.
row reduction is first. Yeah, you're right. So that's 2, -8, 6. And see how many pivot columns there are. -3, 8, 7, -4, 6, 7. I'm not even going to add anything to the right side, so I'm going to add 4 times this one over here. So that's going to be 0, 4 times -3, that's 12. I'm going to add -12, that's going to be -4. I'm going to add 4 times -4, that's going to be -16. So that's going to be that's going to be like -10.
And both of the 7 should be -7, I think. Both of the
Yep.
7 should be -7.
Yeah, you're right, both of them. So then I'm going to subtract 3 times this from here. So now 3. I subtract 3 times -3, that's same as adding 9, that's 2. I'm subtracting 3, that's same as adding, okay, yeah, so then I end up with 5. And we can see these are multiple of each other. So this becomes a, well, I mean, I can literally say that this is 0, 0. And then, yeah, this doesn't matter. We know that this is like a pivot. So we can take these 2 columns, put them here, get rid of this. So we see that the column space only has 2 vectors. Come again. It's more than just 1, right? Infinite?
What?
Oh, how many? Oh my god, how many vectors in a span? Of course it's infinite. Of course there's infinite amount of vectors in a span. Fucking hell.
There's only 3 in the basis. There's actually only 2 in the basis,
Yeah, there's
but
2 in the bases.
it doesn't matter.
Oh.
Yeah.
Oh.
Oh, holy shit. Is P in the column span of A? Well, then we just try to see if there's a linear combination of these 3 that end up with this. Well, I mean, we can say no, right? Oh wait, no. We can only say no if this number gets turns to 0 when we row reduce. Oh, yank, 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 yank. 6, -10, 11. I'm gonna add negative signs to the 7s, and let's try again. Fun stuff, guys. Oh, what a fun assignment! What a fun life. So this is gonna be. What am I doing again? 4 times. Okay. So it's gonna be 0, then 4 times -3. That's same as subtracting -4, I guess. And here we get same as adding 4 times -4. That's -10. Same as adding 26. That's 16. 24. That's 14. Excuse me. Then what? Then I add. I subtract 3 times this from this. Yeah. So that ends me up with -3 times 3, so that's going to be +2. -3 times 4, that's going to be +12, that's 5. -3 times 6, that's going to be -18, that's going to be -7. So these 2 are indeed multiples, so therefore in this matrix there's only 2 pivot positions instead of 3, therefore it is not in there. What? Oh, not only is it in there, there's infinite solutions. Yeah, it only would be the case if this was a number like 1 or something.
Yeah.
Yeah, I see. Okay, yeah. I keep making that mistake.
I mean, it's late now, so
Yeah,
that makes
it
sense.
is. Okay, luckily I can do the exact same fucking question again. So now I can prove that I actually know how to do this. Isn't that fun, guys? Isn't that fun? Am I right? It's fun, right?
It's fun.
I pity the fool who stays here and looks at me. There we go.
I mean, I think the number has shrunk more than half right now, so.
Hmm?
The number of person.
Yeah,
Yeah.
definitely. We started with like 30 and we're now with like how much? Like less than.
Still about 20.
We're like,
no,
we're not 20, we're like 12 or 13 or
15 or something.
something like that.
You're 14. I just can't because I'm bored.
Somebody thanked me for doing the math exercise and used my wrong name. I'm Jelle, my brother is Jelle, for the people watching. I don't blame him though. I get myself confused all the time as well.
Until Yura and Yala are in the same class and then the professor get confused.
I mean, we are.
Oh, really?
Yeah, Jelle Jure is here as well. Like, I'm Jure Jelle, that's Jelle Jure.
Oh.
He's not here right now because he already did the exercise, but he is in the same class.
And is he actually your twin, or are you just like?
Yeah, we're identical twins.
Okay.
The worst part is that you sound very similar, so it's difficult to know who's talking, and you're both there.
Yeah, I have a trick for that. If I'm not talking, it's not me. 400 IQ, ladies and gentlemen.
400 IQ, yep.
Okay, I'm gonna
No,
add
no,
2
not
times the
only
top one to the bottom
400,
one.
2 million.
That's -7. I'm gonna add. These are integer multiples. Yeah. So that is this. Oh.
So, yeah.
Let me have a look at the calendar. Okay. But it doesn't mean it's not in there because this is still 1, so it is. There we go. Can we stop?
They're asking for null here. Careful, they're asking for null.
Ooh.
So
But-
basically, the question is if P.
Wait. So basically, what they're asking is, if I multiply this by.
By P, does it give
No,
you 0?
wait. No, it should automatically be no, because P should be 0, then it will be not in null A. If it's not 0, then it's
No, no.
automatically not.
No, but that would mean that null A is only the vector null.
Null A is the values that, when transformed, become 0.
Yeah.
That's what the
It's
null
not
space
just
is.
the value
Yeah, no,
0.
wait.
So we can check this. So if we have
Oh yeah,
-44,
just multiply. Yes, sorry. Yes,
No
my
worries.
bad. Ah,
And we know that this is already not 0. So. Okay, which of the following are subsets subspace of R cubed? So let's see. This is. Huh. So I'm pretty sure this one is a subspace because this is just x plus y plus -1 times z is equal to 0. But this one I'm not so sure about. So can we have? Let's actually try it. If we have a set of numbers. So if we have 0, 3, 5. Oh yeah, no, it's definitely not. And now we have 2, 1, 0. Then both of these are in a subspace, but 2, 4, 5 is not in a subspace. So 1 is not a subspace. I think 2 is a subspace. And for 3, I think because it has squares. Is it though? Let's actually try. So if we have 2.
Probably going to be something with the negative numbers as before.
Yeah, exactly. So if we have 4. Oh wait, actually we can do this even easier. So we have oh wait. This equation, if we're restricting ourselves to real numbers, is only 0 in the case that they're all 0.
oh, because it's plus. Yeah, never mind.
Yeah, so I think this might actually be true because the only element in there is 0.
Then 0 plus 0 is also 0, but then 0 times any number is also 0, so
Yeah.
3 should be the subspace.
3 is a subspace. 2 is a subspace, so only 2 and 3. Let's go, boys.
Let's go.
We're gaming. That's a lot of text.
Wait, why the first was not subspace again? Oh, never mind.
Yeah, because we could have like 1, 1, 0, 0, 0, 1.
Ah.
They're both. If you multiply them, they're both 0. But if you add them, it's like 1, 1, 1, which is not.
I see.
Okay.
Thank you.
You're welcome. For the subset H, should the vector space R3 to be a subspace, 3 conditions need to hold. We know this. Okay. Decide which
Oh,
of the
this
3
is the same
conditions hold.
question.
Wait, did we fucking?
Yes, this is the
Whoa.
same, exact
This is like
same.
exactly the same question. Okay, let's see if we've learned. So we know. Let's
Empty
see.
set.
The empty set. So only B and C.
Yeah, because that's vaguely true.
R cubed. This is a subspace. This is only A.
Yep.
And this is. So the A holds. I know that for sure. And
Oh, crikey, what's the one answer for this one? Shoot.
it's either only A holds or A or B or A and C.
I think it was A and C because it was with the one with the multiplying. Was it C or B? Yeah, C.
Oh yeah. Okay, that makes sense. Yeah, because the C is okay, cool.
And that's a subspace.
That's a subspace.
And
Math. And this is
none.
not a subspace, so yeah.
Let's go 10 out of 10.
Determine if the following vectors form a basis for R cubed. Well, that's easy because this is just the same as saying, are these 3 vectors linearly independent? Okay, in like less than 3 minutes, GME dipped 195 and it went down to 170. Welcome to GME.
Jesus Christ.
Yeah. I'm kind of just waiting for it to go down. I like the stock. The squeeze will happen eventually anyways. So I'm gonna add 2 of this row to this row. It's gonna become 0. It's gonna become, so 2 of -7, that's gonna become -10. And 2 of 3, that's gonna 11. I'm gonna add 2 of these to this row, so that's gonna be 0 here. And this is gonna be 2 of 6, that's like what? 23. And since these 3 are pivot positions, they form a basis. We don't have to like further reduce at all. No? No? Why the hell would it be a basis if there's only 2 elements? Okay. And like, you know, by the way, that a basis for R cubed could, for example, be 1, 0, 0, 0, 1, 0, 1, 0, 0, right? Because any linear combination of these 3 will fill R3, right? Then, like, we know that everything has to have this amount of numbers, because different bases for a subspace have to have the same amount of vectors. So you cannot make...
No, because it's R3 and you have 4 vectors, so it has to be linear
there was just
independent.
explanation for the last one. This one obviously doesn't form a base because they're not
Yeah.
independent. But yeah. Oh god.
Oh, this is the easiest one. This
Okay,
is one.
they
This few.
already row reduced. That's nice. A basis for the column space is only the vectors with pivot positions. So that's this one, that one, and that one. So that would be, in the usual way, a set of vectors depicted by commas. So we have this one, comma, comma, this one, comma, this one, and we know that it's 2 and -6, -2. Second one doesn't have a pivot. Fourth one has a pivot, so that's -1, 7, 1. And
No, 4 has a pivot.
the fourth one has a pivot.
Oh yeah, and it's no, and the second
Yeah,
column.
the second.
Oh wait, you're
one
right.
is
You're right. I
from
thought of
the-
this one, this one, but
yeah,
this
that's
one,
what I
and that
meant.
one. Yeah, you're right.
Also, I think you should add the curly braces around the set.
No, it just says set
No,
of
you don't have
vectors.
to. No, you don't have to.
Oh,
You don't really have to. Yeah.
Okay.
Okay, let me make a new vector then, and then I can add the second one. So that's -2, 10, 6. Alright, and the base for the null space, that's just the answer of this is equal to 0, right?
Yeah, I think those
Yeah.
are like the ones that do not have pivots.
Basically, have the 3 variables.
So that would be 0, like this one and this one. So -2, 10, and 6, and
No, it was the -2, 10, and 6 were already in the column space.
oh wait, you're right. So it's this one and that one.
Yeah.
Okay, yeah. I sorry, I get stuff confused sometimes. So it's 0, 8, 0, and -3, 16, -4. So we have 0, 8, 0, comma, -3, 16, -4. I'm gonna check if those numbers are correct. They are. Check my answer.
Oh, you did not. You wrote the 080 wrong, because it should be 088.
Yeah, and
because
this
you
one should
have
be
to
wrong as
get
well.
it. Oh yeah.
Yeah, I
right.
should have used the original one, not the row reduced one. So then we get oh, I'm too far. -3, 25, 15. -3, 25, 15.
No, you have to solve it. You have to solve it and express with other 3 variable and stuff. You have to solve the equation. I don't
That's a
think I
lot of
showed it off
effort.
in the way. Yes.
It truly is.
But you do get the echelon form. Echelon form.
Yeah, we
Echelon
already got
form,
the
so you gotta
echelon
go
form.
start.
That's nice.
Hmm.
I'm gonna write it to reduced echelon form real quick, just so that I can like that it's easier for me to work with. Well, this is gonna be 1, 1. This is all gonna be divisible by 2. 4, 2, 8. I'm gonna subtract 2 times this one, so that gets 0, 6. I'm going to add 1 to the top. That's going to be 0, negative 2. I'm going to add... Oh yeah, because this column doesn't matter, so I'm going to add this one to that one. That will make this into a 0, this will become a 4, and this will become a 4. Then I'm going to divide this row by 2, so that's 1, 2, 3. I'm going to divide the top row by 2 as well, that becomes 2, 2, 1. So now we have 3, like, yeah. Okay, so we have 3 pivot positions, and we can say this is equals to minus this, minus this. We can say 1 is equal to minus that, and this is equal to minus that. So we have okay, let me actually write the answer in LaTeX real quick first. So if we have x1 is equal to negative 2x3 minus 2x5. What else do we have? We have negative x2 is equal to negative 2x3 minus 3x5, and we have x4 is equal to x5, or is equal to negative x5. So therefore we have, we also have x3 is equal to x3, and x5 is equal to x5. Therefore, and let me write this down so you guys can see it as well. There we go. So this is the system of equations we have as answers for the homogeneous solution. So then we have, let's see, in terms of x3 and x5, we have, so this is an x3, so that's minus 2, 1, 0, 0, and minus 2, minus 3, 0, negative 1, 1. That is correct. All right, that's actually pretty easy. And it's a training for like turning this into a vector form, which is hard, at least for me. A basis for the column span. Wait, isn't this like? Doesn't this mean that there's only one? So a basis would be 3, negative 6.
Wait. Oh yeah.
Yeah. Wow. Cool. And
Or any of the 3, I think. In that
yeah,
case.
it could be any of the 3, but they're like multiples. Yeah, so this is like times 5, this times 3. A base for the null space. Well, we can figure that out as well. Oh, wrong one. So we currently have 3, 15, 9, 0, 0, 0, 0, 0, and this becomes 1, 5, 3. So then we have 1 is equal to a negative minus 3. So we will have the vector negative 5, 0, negative 3, 0. All right, does that make sense?
And should it, because isn't it just like the matrix multiplication? So shouldn't it be like the same amount as the columns? Because like right now you have vectors which have only 2.
Yeah, shouldn't be minus 5, 1, 0, and minus 3, 0, 1.
Yeah, because the vectors should be like in R3, and you have like.
Oh yeah, it's like
height
x1,
to-
x2, x3. Yeah, I forgot about that.
Yeah, and you
That's a
should
good
add
call.
the ones at the bottom.
So we have x2 times minus 5, 1, 0, and x3 times When I say it out loud like that, it makes a lot more sense in my head as well. 0, 1.
Yep.
Yeah, okay, that makes sense. Cool. So now we have to do this one exercise a bunch of times. 0, or actually let me write down the row reduced form. -1, 2. Okay, real quick, we know the basis of A1 is just equal to -1, 3, comma. I mean, to be fair, would have been pretty easy to see from the first one as well that this one doesn't count. And then 2, 4. Or 2 minus 2, okay. I'm glad I didn't press accept. Okay, and then the base for the null span, well, that's just calculations. That's like 0, 0, 4. And this is 0, 0. So that's going to turn this into a 1. I'm going to subtract 2 times 1 from this one, and I'm going to turn this to a 1 as well. Everything I just did was allowed, right? So
Yep.
Yeah.
So then it's just the basis for null A is just 1, 0, or actually, sorry, it's 0, 1, 0 plus 0, 0, 1.
No. Oh yeah.
Huh?
Oh.
Could we have?
Oh wait. No, because x1,
Oh.
x2, and x3. No, you just 1, 0, 0. No, just 1, 0, 0.
1, 0, 0.
Because x1 is free.
Oh yeah.
Right.
So no, it's like expressed in the
Yeah.
free variables, not the not free variables.
Yep.
Okay, that makes sense. Yeah.
It's quite gets me sometimes. Like.
Yeah. This is why we practice. Find a basis
Yeah.
for.
Oh, wait, I'm sorry. I zoned out for a second.
No worry.
What
Okay.
exactly did everyone just was like, oh, I know, and everything?
Okay, so we had to find a subspace for the null space, or we had to find the null space of
The basis
a
of the null
basis of
space.
a null space of a homogeneous equation which row reduces to this.
Okay.
And I first thought it was 0, 1, 1 plus 0, 0, 1, but that's not the case. It is actually the free variable a1, which is not affected by any of these columns. So it's just literally the basis of that subspace is 1, 0, 0. Because a1
Oh,
can be
right.
anything.
The null space is just the free variables.
Yeah, just the free variable, like 1, 0, 0. So just the free
Okay.
variables, yeah. Okay, okay. Well, let's enter that then. Oh wait, this is the next question. Find a base for subspace for which x2 is equal to x3. Wait, so we know x2, well, isn't it?
This is quite easy.
Can we just
Yeah.
like 0, 1,
No, that's
1,
not
0?
easy.
Yes. And
Oh wait, no, it is
including
easy.
more. You can
It
include
is easy.
everything.
My bad.
I mean, can we just say this then?
No,
Why not?
I don't think so. Because
It doesn't
for subspace,
specify that 1 and x1 and x4 do not have to be equal to x1, x2, and x3. So I think this would be a right answer.
you could give a shot, but I don't think this is the right answer.
Oh wait, unless they mean for which only, like the only thing we know about it is this. In that case, then the answer would be, comma.
Yeah, 1, 1, 0, 0, 0, and 0, 0.
Man just fucking leaves. He's had enough. I don't blame the guy.
F my internet.
Yeah.
This keep me offline for some reason. Probably he just hates seeing linear algebra.
Yep, mode. Find a basis for the subpage R5 for which this holds. Well, wouldn't this just be 2 minus 5 minus 1, 1, 1? Because all the variables are in there.
No. Because that's the only thing we know, and
Yeah, but all the variables are in there, so we. No,
no, it's not. No, it's not. It's not. It has to be all the. how should I say it's like you have x1 equal to something like that, or like x5 equal to something like that, and you have everything else still have to be represented alone, like 1, 1, 0, 0, 0, because that's the only thing we know. Again, it's like this last question. It's the only thing we know about that.
Huh, yeah, that's right. Huh. Hmm. Okay, wait. So they told us as a hint that we could represent this in some kind of way. So we know that 2x1 minus 5x2 minus 3 x3 or minus x3.
Minus
Sorry.
1.
So that's minus 1, and then 1 1 is equal to 0. So it's some sort of null space. So I guess we could write it in a way like is equal to, and then we flip all the signs, and then we have like the. And then these are all free variables. Maybe we could regard it like that.
Yeah.
Because that's what we usually do with the null space, right?
Yeah, but I think that it should be also divided by 2, because the first pivot
Oh yeah, because it should be
be
like a 1.
in 1.
Okay, so now we have a 5 by 1 vector. So x2 is equal to I mean, do I have to do anything with x1? I know this is. Wait, huh?
Yeah, you do, because you do have x2 being part of x1.
Yeah, it should be like 1
That's
and
what you do.
then the rest.
No, it should be 5/2. It should be 5/2 for the x1. And then you have 1 for and then you have 1, 0, 0, 0.
So wait, so this is the. So this is the expression for x2, right?
Yep.
But x2, wouldn't this be like. If we express f2 in x1 in terms of f. Oh wait, yeah, okay, I see. So I think this should indeed be correct, and then like the rest as well. So again, a 5 by 1 matrix. Oh god, 5 by 1 matrix, and then we have 1/2, 0, 1, 0, 0, comma. Negative 1/2, 0, 0, 1, 0, and negative 1/2, 0, 0, 0, 1.
Comma.
Oh,
Comma.
yeah, good one.
And shouldn't also. Oh no, yeah, because the first one does not.
Yeah, it's not a free
yeah.
variable.
Okay,
Fucking
right.
hell. That's yeah. Alright, interesting. Back to lessons. So this was all the post-lecture exercise material for lecture 8. Only 2 more lectures to go, guys.
Nice.
And it's only coordinates and dimensions and determinants. Surely that won't be hard, right? Easy. It's gonna be
Oh,
easy.
we can sleep on time. That's good.
I mean, determinants are pretty fast to calculate, to be honest.
Yeah, especially if you have like some of the tricks. Like reduce it to a
I mean,
Try
yeah,
it.
just properly using the zeros they so nicely give us.
Yeah, just try doing determinant of like 25 by 25 then.
Well-
easy. Easy game.
I mean, calculating the determinant of a 25 by 25 matrix should not be part of the skills we're required to have.
Yeah.
Because at this
definitely not the
point, we're
case.
not like linear algebra students, we're computers.
Okay, let's see. So about this one, let's see lecture slides. We've only been busy for 6 hours. I think we might have this finished before like the 8-hour mark. That's pretty sick. Oh
Yeah, but
god,
that's
this
because we're not
stuff.
doing the
I forgot
extra
everything about
exercises.
this.
It's not that hard. Well, like
I don't
after
even know what
doing
the hell
those
this was
spaces.
again.
Basically, are you seriously, you don't know what that is?
No, I completely forgot. I zoned out during this lecture. Like the
Oh my
entirety.
god. Okay, so these two vectors here are a basis for a subspace,
Yeah.
right? And so the way you mark it is look at C here at the answer C.
Yeah.
It's 1, 1, so it's one time
Oh,
the
one
first
times this,
vector
one times
and
this.
one time the
Okay.
second vector.
And then here you would only have to fill in like 5 and 5 here.
Yeah, it's 5 times the first vector. 5. Oh wait, no, sorry, my bad.
This
No,
is the other
no,
way
no.
around.
This is the other way
Yeah, this
around.
is like
It's
2
2
times
times the
this
first vector
minus 1 times this.
minus.
Okay, yeah.
Exactly, and so basically, it's another way to apprehend positions by basically having the multiples of these vectors forming this basis.
Yeah. So, yeah, if we have a vector and a subspace, then this thing, I don't know how to say that, is just the amount of times you have to multiply these two together to get this.
Yeah, I'm sorry. I'll be right back.
Yep, take your time.
Continue
Okay.
without me.
Oh no! Okay. The dimension of dim W of a subspace W is the numbers of vectors in the basis. Yeah, so as we said before, for like the dimension of R3 would just be like this. Oh, and this would be just 3-dimensional. I love how we're finally using the word dimension. That's when you know it's gonna get interesting. ASMR YouTube channel now.
Nice.
Okay. Basis theorem. Let W be a p-dimensional subspace of Rn. Any linearly independent set of p of exactly p elements in W is a base for W. Okay, yeah, I knew this. And any sets of p elements that spans of W that spans W is a basis for W. Yep, that makes sense. This is just the dimension of the column space, and the dimension of the column space plus the dimension of the null space is the total amount of dimension. It's total dimension. Okay. No, guys, no, let's not.
God. There might be a reason why I hate linear algebra, and I couldn't figure out why.
Yeah, no, I have no idea. It's almost as if they have so many fucking things to remember that there's 3 dots here. Okay, to be fair, most of them can be quite intuitive. Hmm. Okay, yeah, okay, this makes sense because there are 4 columns, 3 of them are pivot columns. Then there's 1 free variable. Okay, that's good. Yeah, okay, that makes sense. Okay, I think I understand this. That's good. So let's do the pre-lecture. Hmm?
4 more to go. I was just gonna say.
0 out of 1.
Let's go.
Let's go. Okay.
I mean,
so depicted are B1, B2, X1, and Y. Okay, makes sense. For each X and R2, the coordinate vector X relative to basis B, vector C1 and C2, where C1 and C2 are the weights such that X is equal to C1B1 plus C2B2. Use figure to estimate XB. Confirm the estimate of B by using it and compute B. So we want to get to the vector X by from the basis B. How do we get there? Well, we use 1 times B and 1 times B1 and 2 times B2. So that is 1, 2. I wish all of them were like this. And then we have
I mean,
Well, I mean, this is just
you can understand how I was like really astonished you didn't remember that because it's so simple.
yeah, I understand. And now this is interesting. So this is kind of in the middle of these two. So I would say it's 1 times b2 minus 1 times b1. So it's minus 1 1.
No, no.
Minus half, I'll say.
Minus half.
Oh.
Yeah.
Wait, minus half?
Because it's not on the line.
Oh
if
yeah.
It's on the line,
So
it's
I
one and a
multiply
half.
both of them by half. So if I add negative b1 and b2 together, I get here, and then I multiply both of them by half, and I get here.
Exactly.
So it's
Yep.
let's see. So it's negative. So it's negative 1 1. So it's negative 1 half 1 half. Negative 1 over 2 1 over 2. Dude, I got a green square on my pre-lectures, and we also only spent 7 minutes, including going over the videos. Fuck you with your only 27%. I think we're doing great. Green square. Update your knowledge. Only 3. That's.
Let's
I
go,
think we
baby.
might be sleeping tonight, boys.
Don't give
Who
us
knows?
too much hope, you know.
Okay, that's fair. I think I might be sleeping tonight. You guys are still gonna learn.
Yeah. God damn it.
Let
Darn
B
it.
be a basis for a subspace if X is a vector in H with B, with the coordinate vector of B of X in B is C1, C2, C3. Then
That's A, right? Should be the first one. Sorry.
yeah, I think it is. Like this one, this doesn't make much sense. So I think this is it.
Let's go.
This is the true definition. The rank of a matrix A is equal to the number of
The dimension of column A.
Yeah.
The dimension of column A. Yep.
Yeah, that makes sense. So it's also equal to the number of pivot positions in A, right?
That's yes. That's the N. So it should be equal to N.
Okay, let's see. For this one, rows, columns. We only care about the columns, so it's N. Wow!
Let's
We are
go.
doing really good.
100.
If
I think
it
that's
just-
the first 100 we got. I think that's the first 100 we got. 10 out of 10. Like.
I mean, we got 100 here and like everything that's green.
Oh yeah.
So we've
No.
gotten ones before, but it's
You
still
can get
good.
green and
No, that's green. It's 80 plus, right? I think.
Oh,
Something
really?
like that. Yeah.
Yeah.
Oh. Well, I mean, we've gotten hundreds before, like the one just now, but yeah. Let's see. The vector x is coordinate vector xb equals okay. So what this is saying, and I'm totally not struggling with the definition and keeping the two apart, right? This is really easy. There's no way that someone intelligent like me would be struggling with that. So what this is saying is if we multiply this thing by 4 and this thing by -2, then we get x.
Yep.
Okay, thank fucking God. So this is 12 minus 10, so that's 2. And this is -12 minus
8.
minus
Plus
8.
8.
So that's
No, plus 8.
plus 8?
Well, no, minus 8.
No,
my bad.
no, minus 8. Minus
Okay,
8. Sorry,
so
sorry.
-12 minus 8 is -20. There
Let's
we
go.
Sayonara. So now we have to think. Oh, wow. Okay, cool. I'm gonna do some very, very quick math and say that it's a 0, 2. Oh, actually no. I thought it was. I didn't see this minus sign. So it is -2, and then we need to turn the -8 into an 8. So we add 4 to the first one.
Smashed it. Let's go.
I'm kissing my. You can't see it, but I'm kissing my biceps, flexing and shit. The vector blah 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 is contained in the subspace blah blah blah. Compute the b coordinate vector of x. So that's just how many times of this and this do we have to get this? Wouldn't it?
Row reduction.
Yeah, I was about to say.
That's
Can
only-
we just say 3 -3? Oh, sorry. 3 -3 15 and -15, and then I'm gonna put them in the right column because I'm an asshole, or not an asshole, an idiot. There's a difference. -2, -4, -2, and 3, 3, -3. Okay, now it's time to row reduce. Woo! Actually, it is such that.
I mean, actually, that one.
No, it's like b1 plus b2 is equal to x. Therefore, minus x is equal to 0. So if I do.
I mean,
Oh, I mean, we don't have to actually do that. We can just say that this is like the augmented form, right?
yeah. Also by inspection, I think we can know that x1 equals x2 equals 3 because that's the only one they fit, and that's the only one coming up to my mind.
That's 9 or not. Yeah. I think you might be.
I'm not sure that's correct, but I think so. And wait, shouldn't it be 2? Because
Yeah.
Because you're squeezing into 2, yeah.
Yeah. So just to be sure, right? So I'm gonna oh. So -3 times -2 is -6. Then we add like
9.
that becomes 3. That makes sense. We have -12. We add 9. That becomes -3. Oh yeah. Okay, that's correct. I was looking at this vector. And then I have negative like 6, and I subtract -9, or I add -9. Okay, yeah, that makes sense. Dude, we are so good. Us as a group, mostly me, but us as a group is so good.
And this is the same question.
It's literally the same question, but just different numbers.
I mean, we could just skip it if you don't want to do it. I don't really mind. Nothing. I mean, if you want, just skip it because
Yeah,
we
like
already
we've
understand
done this
question.
before.
I mean, it is very easy though.
Exactly.
Yeah.
Whoa. Whoa.
No. Okay.
Oh, I
But
got an
anyway.
orange. Oh no. So the basis for core A is just like
The
Yeah.
The first, second, and third column.
the first, second, and third.
The first.
The
first, third, and fifth.
Okay, yeah, that
and
makes
fifth.
more sense. Okay.
I don't know why I said that.
Oh, yeah, no. Oh, that's
I mean,
I
it's
was
6.
thinking. I
It's
was
6
thinking.
now.
I was thinking first, third, and fifth, and I said first, second, third for some reason. I don't.
Dude, I just made like a 3-dimensional vector for a 4-dimensional thing. I understand. We're all tired. I'm pretty sure we're all just like barely hanging on to dear fucking life after this all. And we're not even doing all of them, right? My original plan was to do all of them. Okay, check. The dimension for Noi is equal to 5 minus 3, that is 2. How?
It's a basis again, not the dimension.
Oh, okay.
It's
Okay,
again.
no,
the-
then this is like 3, this is 2. Motherfucker. I thought it said basis. Or I thought it said dimension.
Oof.
Okay, it's been 6.5 hours, guys. It happens. So I have 1, 2, -4, 3, 3, 0, 1, -2, 0, 0, and like -5, 0. Well, this is just 1. I can turn this into a 0, and I can get like add 5 times or 4 times this one to here, and 4 times -2 plus 3 is -5, and then I can turn this into 3 equations where I turn around all the signs, and there we go. So then we end up with a basis for the null space being. So we have this one, which is just a -2, and then 1, and then 0, 0, 0, comma. Is that correct? 1, 2, 3, 4, 5. Yeah. Then we make another 1 by 5. So this is then 5, 2, or is that correct?
You sure
Yeah, I
you
think
need
so.
you sure you have the one in the. Oh right, yeah. Wait.
That should be it. Shouldn't that be it? You only have 2 vectors, right? I don't think you have 3. Last one, the right
Oh wait,
one.
that's a pivot.
Yeah, that's a pivot.
But okay, yeah, that makes
The
sense.
the last column is a result, so I think the equal to what? Huh?
Did I really fuck up row reduction of an already reduced echelon form? Or yeah, but it's not already reduced, but like, did I fuck up row reduction of that? Yikes.
Wait, can I go to the vector again? I just didn't write it down because I'm too lazy calculating it. So this. So 1, 2, minus 4 is 3. Let's write it down.
Wait, shouldn't this be -5 then? Oh wait, I think it was, and then I swapped signs.
Oof.
No, but I
Yeah,
think that's
got it.
correct because like, so it's.
Yeah, I should.
I think this was the thing before we started doing like swapping signs and stuff.
Yeah. Yeah, that's.
Yeah, that is correct. Yeah, so then I started swapping signs and it turned into this.
Huh.
And that's what I have, a 5 and a 2 and a 1 here, because it's the 4th column.
Then
and a
maybe it's
-2 and a
actually
1
you
here.
have no, but then you don't have a free variable. No, wait, never mind. No.
These are the only 2 free variables here.
1, 2, 3, 4, 5. Yeah, what?
What? Huh. That is super
Do you mind just
weird.
skip it and see?
Maybe
I think that.
Gasple, yeah, Gasple may be doing some shit.
0.
So.
5.
Oh, that's for 3. Oh.
What?
You have 5201. It's 5021. That's for x3. You have to count it from left to right, not up to down.
But then this would be x4, right?
Yeah, but that's for x3. What the 1 is on x3.
Yeah.
Wait. Show the.
The 2 is on x3 because x3 equals to x4. You have 520010.
Wait, give me a sec. So 5. Yeah, I get that it's a 5, like the first one.
Yeah, because 5 is
but this
from
is
the
like
first
row.
column, and the
Yeah,
2
the
is from the
column
third.
Oh, wait, so it's column 3 that it starts from.
Yep.
Yes.
Okay,
Yes.
yeah, that makes sense.
It's 6 o'clock, guys. And I think our brain is dead.
I didn't think about that, but because I'm used to having it like just like this, so I thought it would be the same, but it's not.
Wait a second. I'm tied.
Okay, so the reason that it's this and not like 52120, it's 502, is because the 2 is in terms of x3, no x1. Oh, okay, it's gone now. But yeah, that's fucking sick. Okay. So for this one, that's just not that. That's like the opposite of what I wanted. No, you cannot get more opposite of what I wanted to do. 1, -3.
Microsoft
2,
knows you're
-4.
hard.
Yeah. -3, 9, -6, 12. Well, I can already tell that these two are not like are gonna be in some kind of trouble. 4, 2, and -4, 5, -3, 7. Okay. So then what I will do is I will now proceed to... Well, I mean, since this is a integer multiple of this one, right? Yeah, it is.
Yeah,
It's
the
-3.
second one is definitely out.
So I can just do a yoink. Or actually, yoink.
I mean, it's the same.
True. So then what? I'm gonna add 3 times the top one to this one. Yeah. So that's gonna become this. 3 times that becomes this. 3 times that's gonna become this. Oh. I'm gonna subtract 2 times top one from this one. That's 0. Subtract that becomes this. Subtract 3 times 4. That's same as adding 3 times 4. That's like same as adding 12. That's 9. And I'm gonna subtract I mean, realistically, we know that this is a pivot position, this is a pivot position, this is a pivot position, so this one can be turned to 0 anyways, right? Like, if we know that all three of these are pivot positions, then we know that this can be row reduced to do something like this.
Yeah, I think so. So yeah, so you
Yeah,
can
and
just
then we can
go
just
for the
multiply and get rid of this.
yeah. So for the basis, I think you have all of them except of the second
Yeah,
one.
so let's do that. So we have 1, -3, 2, -4. That's a dot, not a comma. I hate being not scrolled down enough that I can barely not hit the thing. So annoying.
Yeah, and I don't know if you notice, but when you click the matrix and then it closes, you have to click it twice to
Yeah,
open
I
it
have
again.
noticed.
Oh,
Unfortunately,
really?
It's
the
terrible.
dimension of the subspace is 3-dimensional because there's 3 vectors in the
Yeah,
basis.
it's really annoying when you have to like click a few vectors because each time you have to click twice to open this.
No.
Gasple in a nutshell.
No. Column with A is not equal to R5.
Once I'm done with these, I'm gonna do like a viewer sent question. Because I just got a question sent from the book. That's actually a really interesting one. Or well, not really interesting, but at least somewhat interesting.
Wait a second. Wait a second. It's a 5-row. Wait, no, yes. Column
5
A
rows,
equals
First one
5
should
5.
be
5 columns.
yes.
Row, 9 column, but it has 5 pivot
Yeah.
positions, so that means
Literally
Yeah,
pivot
that's
in
the first
every row.
letter. Column is always the first letter, and the null is the second.
no,
column
rows.
is the
It's
first
rows
number.
by columns. But
Yeah.
Yes.
there is too
Alright.
many. There's too many columns for that.
That's it.
But 5 of them have pivot positions. Therefore, it is equal to R5.
Yep.
But you see,
Yeah.
the next question is
Is no A equal to R4? Well, yes. Wait, not?
no.
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 No A
A
is equal
is
to 9.
null A is
Oh, it's a subspace.
is a R4 in
Yeah, it's a
the
subspace with
9
dimension R4.
R4.
Yeah.
Yes.
Okay, suppose subspace of all.
Wait, what?
So we had that
Oh,
coincidentally the column space of a 9-column matrix was R5. That doesn't
Yeah.
mean that the null space is R5. That means the dimension of the null space is 5.
Oh, I got it.
Yeah. Okay, so suppose subspace of all solutions AX0 has a base consists of 2 vectors. What is the rank of A? Well, let's just do that, right? Oh wait, no, because this means that the null space has 2 vectors, but the column space has 4 minus 2. So, wow, okay. Cool stuff. So it is 4 minus 2, but if you just guessed it because of this one, you also would have had it correct.
Yeah.
What is the rank of a 9 by 8 matrix whose null space is 1-dimensional? Well, 7.
Ooh.
Yeah, quick math. It's possible to extract 3 before matrix as the dimension of the null space is 2 and the dimension of the column space is 2. Yes. 1.
That's not a
1.
3 by 4.
matrix.
Oh, fuck. It should be 3 by 4, so it's 3 rows, 4 columns. 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So it has 2 pivot positions and 2 non-pivot positions.
That is a work of beauty.
Thank you.
You have pushed too much effort into the work, man.
Yeah.
What a great work.
I can feel the dedication, the hours sunk into this.
Yeah, for sure, man. It's like I've been trying really, really hard. Okay, let's see. Let's see. Let H be a subspace of R3 with basis B1, B2 defined. Okay, yeah, cool. This like the dimension here does not matter at all. Whose columns are basis vectors of H. How are vectors H, X and H and its B coordinate in vector B related? So let's see, we have the bases, and if we multiply that by the thing, we will get so let's say we have x b is equal
So
to
x equals p, and then
let's say
coordinate vector.
AB, and we have P being the so we have like a matrix here that's like let's see, where is it, like B1, B2, and like these will of course continue down because they're columns. And then we have the XB being equal to A comma B, because this is like the, yeah. So then this will end up, I should not have named these A and B. I'm gonna make a guess. Dude, I'm so good. Literally guessed that one. Okay, now the last one, guys. Determinants, and then we are done for the midterm. I feel like I could have done a midterm if I wanted to, and I would have gotten a decent score, but like, it is so situational, and my brother got like nipped for supposed cheating, and he almost had his like BSA rescinded. Or not his BSA, but like his calculus ECs rescinded.
Really?
Yeah.
Damn.
I mean, to be fair, he so they wrote down how you should do it with the headset, like at 5 different places, and the only place he read is that you could use your headset as a microphone. So he
Oh
put
yeah,
his
yeah,
headset
yeah.
on,
Yeah, yeah. I heard.
and like,
I thought that was you though. That
no, that
was
was
him.
my brother.
Every time your voice is the same. So like I'm in a call with many people. I hear the person talk, and I'm like, I just assume it's you every time.
Yeah, understandable, honestly. Okay, well we still remember this one, right? 4 times 1 minus, you know, yeah, yeah. Ik kan nu niet. Ja, zo. Fucking hell. I
What?
will be back in approximately 15 minutes.
15 minutes.
Yeah.
5-0 or 1-5?
No, 15.
Okay, okay. I thought it was 1-5-0. I was like,
Oh,
hold
no,
up.
no, no. It'll be 15 minutes, and then we can finish this off.
Or then I'll probably leave because I'm gonna
Yeah,
get
yeah,
some
no,
CTV
it's
maybe.
okay. Like, this is only the determinant, so you're okay to leave. I'm gonna be back in 15 minutes. If you guys want to take a break, if you're still here afterwards, that'll be great. If not, that's fine too. And I'll see you guys then. Alright.
All right.
What? You just accidentally unmute yourself, I guess.
Bonjour, I am back. Sorry for that. My
Nice.
my grocery store deliver stuff, and then I have to like help unpack.
Ooh.
Yeah.
Aucun problème.
Okay. So we were busy with determinants, right?
Yes.
Okay.
Oh god.
So yeah, we know for the 2x2 matrix, easy. Oh, here we have a cofactor expansion thingy. Let's see. So let's see. We have a matrix like this. So it would be. Wait. Is it correct? A1 C1. Oh wait. So this is like. These words are very, very interesting, but they don't mean anything to me. I remember doing this, but I don't even remember anything. Can somebody explain me how a cofactor cofactor calculation, like expansion, works on a matrix like this one?
I can explain you how to get a determinant for 3x3 matrix.
What did you say?
I can explain to you how to get determinant for 4x4 and 3x3 matrices.
Go ahead. Well, I mean,
Is
I know
that
about
what
row
the
reduction and then
cofactor
multiplying
expansion-
the things, but
Is that what the cofactor expansion is?
yeah, like across a
Okay.
certain row and column.
So select either a row or a column.
Okay, let's do this one, like the
top one.
Yeah.
All right. So now what you're gonna do is you're gonna do one time the determinant of 5, 6, 8, 9. The determinant of the two other columns.
Okay, yeah, this rings a bell.
Then 2 times the determinant of 4, 7, 6, 9, or 4, 6, 7, 9 rather. You see what you see how it works?
Yeah. So it's 4, 6, 7, 9. Okay, this makes sense. It's just
And
that
then-
they explained it like this, which is fucking hella
Yeah,
annoying.
which is weird.
Yeah, now I understand. Okay, I remember this. Yeah, so in this one I would pick like this one. So let me actually try this exercise real quick. So if we have 5, 1, 3, 3. I don't know where I'm copying this. I don't need to copy this. I'm not gonna copy this. So if I pick this row, then I first have so that is 3 times the determinant of and then everything except for this row and this column. So that is just this matrix. So I'm gonna actually put that in here. So that is the determinant of this thing. 1, 0, 1. And then I can pick like this one. Like this row. So this that's 3 times the determinant of. Okay, 3 times the determinant of 0, 0, 2, 0, 0, 0, 1, 0, 1. And that is and it's equal to 3 times the 3 times, and then I can pick like. Wait, can you not just pick something that has a 0 in it, and then the answer is 0?
Yeah. If you take that's the whole point. The point is to use the zeros to reduce the most of the work you're doing. So if you look at the determinant on the slide
Oh
here,
yeah, okay, so
you select the third column, or the third row.
or this one. So then we
Yeah.
have 3 times the determinant of everything except for like this row and this thing.
Yeah.
Plus 0 times whatever, 0 times whatever, 0 times
Yeah,
whatever.
you don't give a shit.
And then for
You've
this
got-
one, I can pick like. Can I pick this column and then the answer 0?
Where's the 0, 0, 0 from?
Oh wait, okay, I took the wrong one. Okay, that makes a lot more sense because I don't remember the answer being 0.
Yeah.
So this one makes a
yeah.
lot more sense.
Yeah, that makes
But then
a bit more
I can
sense.
take this column.
Yep,
So then
you can take that.
the
And
answer will be
therefore
3
it's two
times
times
2
the
times.
determinant
And then
of
the determinant of like 4, 6, 1,
what?
0, which is 3
Which is
times
just
2 times
minus 6.
4 minus 6, so that's negative 2.
What do you mean 4 minus 6? There's a 0, mate.
Oh yeah, so that's just negative 6.
Just minus 6.
Okay.
And so minus 6
Minus
times
6, yeah.
times
And
6.
that's minus 36.
Exactly.
Okay, so that's good. Now we've recapped determinants. How about triangular matrices? So
Triangular matrices, you can literally just take the pivot point in line and multiply all of them. Because
yeah. And this
just
also works for this works for like
um,
diagonal, but also triangular matrices.
generate any triangular matrix, just whatever.
So I'm gonna say 5, 2, 1. Yeah, like this.
Right. Okay. So the first thing you do is you select the first column.
Yep.
So then you do 2 times the determinant there.
Oh yeah,
and
then you do this one, and then you do this one.
Because there's the 0, it's basically just 2 times 4 times 1.
Yeah.
And because you can make it bigger, you can add another layer every time you're multiplying by 0 for the rest, so you don't care.
Yeah, so this will be like 8 times 6 times 5 times 1 times 4 times 2.
Regardless of what's around. Well, actually, it needs to be zeros on the.
Yeah, it needs to be 0 on
bottom
either
side.
side.
On the bottom side. The top side doesn't matter.
Yeah, but it can also be the top side and that the bottom side doesn't matter.
Oh, yeah, okay, I guess. But then you just flip it around, probably.
Yeah, but you can't just flip it around. You just. But I mean your method.
Interchange
Yeah.
the rows to make it fit.
Yeah. Okay. Determinants and elementary row operations. Well, I knew this. Add a multiple to a row to another row. That's allowed.
It does change the determinant, though. Like, you have to know, interchange 2 rows, the determinant becomes negative.
Yeah, but like, if you do just this, then the determinant stays the same.
Yeah.
So like, oh, excuse me, we have been working for a bit. Should have been counting. Okay. Determinant in a. I thought it said inevitability. I was like, oh yeah.
Yeah, let's go, boys.
Inevitable. A square matrix is invertible if and only if the determinant is not 0. Well, I knew this, but I thought it only worked for 2 by 2. That's cool. If A and by a matrix, then the determinant of A transpose is equal to the determinant of A. This is cool because that means that we can use the diagonal line thing. So, I mean, intuitively it makes sense. We can also now just say we transpose it, and then we just use the top one. Then the inverse of the determinant of A is 1 over the determinant of A. And like this is like one of the key parts. Okay, what else do we have? That's it.
That's it.
Ooh, let's go. The last two.
Determinant. I told you, determinants are easy as fuck.
They are. Okay.
Basically, how do you calculate it? And that's basically
14.
it.
No, not minus 4, just 14.
Oh yeah. Okay, that makes sense. Linear map. Let R be the rectangle R with corners. Yeah. What can you say about the shape of T of R? A linear map. Don't I mean a linear transformation? What a bunch of bugs.
Yeah. They're like, we're not going to use x and y. We're going to say x1 and x2. And they're like, we're not going to say linear transformation. It's called like a linear map.
Yeah. So you multiply all the columns or all the corners by a
I would say it could be just be a parallelogram.
parallelogram.
Wait, parallelogram. I think that's the answer.
And it can also be a collapsed parallelogram.
Yes, and also collapsed one. Yeah.
Because if it's like if the matrix for A is like 0, 0, 0, 0, then it's just gonna collapse down to the point 0.
Yep.
Okay. If T has a standard matrix, what's the area of TR? The area. Okay, well.
That's where the deaths come in.
Oh, so the determinant of this is the area of.
Yes.
Well, but how does R play into this then?
Wait, if you scroll down, can you scroll down?
It's the determinant of
50.
TR, or the area of TR.
Yeah, you have that of you have calculated that of
You're lagging out. What do you think?
because sorry now it's better.
Yep.
So basically the that of the linear transformation is the multiplication of the area. For example, if a that is 2, that basically means if you have over standard matrix
Oh,
and
yeah.
the size is
Yeah, yeah.
1 and now it's 2.
Okay, yeah,
That means
I knew that. That's cool.
That-
Okay.
Yeah.
That's what I was telling
it
you
is
like
-8
4 hours ago
minus-
about rotation.
So
And
if it
because
is-
because cos squared plus sine squared is 1, it never changes. It just rotates.
Yeah.
Yep.
So this will be -22, right? The determinant of this thing. -8 minus. Yeah, -8 minus 15. 23. So then I take the area of this, and I wait. Huh?
Huh? Yeah, minus 23. Yeah, that makes sense.
But does that mean it gets multiplied by 1 over -23 or something? No, that
No,
still
it
wouldn't make
just
sense.
it just
no,
minus
no,
23.
it's time 23, but in the
Because you're expanding in opposite direction.
Oh,
but
so it goes.
basically
It's,
what happens
yeah.
is that it's time 23, but the points will be reversed in the
It's
direction towards the
flipped.
origin.
Yeah,
It's
so
flipped in
so
short.
basically what happens is like say we have a real big point and we have like this thing, then what will happen is it's gonna go like yeet and yeet and
Yeah, that kind of
and
stuff.
yeet. So it's just gonna go the other way and we'd have like
Curve. Yeah.
wavy.
Yeah.
Okay, cool. That's pretty cool. I didn't know that.
But then it's just gonna be the absolute value. Just don't forget you're gonna have minus area.
Yeah, that's what I was worried about. So the area of this is like, if we have a thing like this, it would be 1 here, 0, 1, or yeah, 0, 1. So it would be yeah. So it would be this square, but this just has area 1. So then it would be the area of 23, but then in the other direction. Yeah.
Let's
Okay,
go.
cool. That's the pre-lecture. So now it's only the post-lecture for 10. My voice is like...
Last one.
My voice is succumbing. Update your knowledge.
This is like only 2 on it,
AB
right?
or AD minus B, BC. AD minus BC, yeah. What's the statement about the relation between the invertibility of the square matrix and the determinant correct? This is not true. This is not true. This is true. Man, I'm good. I'm just gonna take that L.
Oh, cofactor expression.
I really CVA. I can probably deduce the cofactor expression, but do I want to? Eig. Eig. Determinant of A is 5, and matrix B is constructed by multiplying the second row of A by 2. What's the determinant of matrix? The second row or the second column? The second row, okay, that makes sense. So then, 10.
Let's go.
First row 1, okay, and then that's like -12.
Also, remember, if you multiply the whole matrix, the determinant is squared.
Yeah, yeah.
Like if you
You
do
multiply by the square of the thing, because
a constant time a matrix, then the determinant is the same times the square of that constant.
Yeah, because if we have like 1, 1, 1, 1, 1, and we multiply this matrix by 2, that means we multiply this row by 2, and we multiply this row by 2, so that means the 2 is square because we multiply 2 rows by 2. And it's not only squared, it can be more than that, I think. Depending on
sorry, it's to the power of the size of your matrix.
Exactly. Which statement is true? Well, we know this one. No. I know this one is not true. I know this one is not true. Okay, it's this one.
What do you mean? No, determinant of the A transpose is the same as determinant.
Fuck! Okay, yeah.
Bruh, we literally talked about that.
Yeah, we talked about it, but this one looks like something familiar. But what is this then? Oh, this is like the inverse then, or?
Oh yeah, it's inverse. Yes, 18 inverse.
So let me see if I can find that back. Yeah, this one. I was thinking about this one. Okay.
F.
F.
Big ol' F.
So it's this one. That's true. Square make it invertible if and only if the determinant of A is not 0. That's true. K is fixed constant and determinant of K times A. No, this is false. Because as we said, it will be K to the power n.
K squared. K to the power of n. Yeah. Is it K to the power of n or?
Yeah, but n is like size of the matrix.
Yeah.
Because
Okay.
if it's like this, if we had like 1, 1, 1, 1, 1, 1, and I multiplied it by 2, that's the same as multiplying 3 different rows by 2. So you multiply by 2 to the power 3. Yeah.
So multiply by the number of rows.
Yeah.
So it's okay.
Find the determinant of well that's 9 or yeah. Find the determinant of okay. Well, wait. The determinant of A times B is the determinant of A times the determinant of B. So this is -5 times 5 minus is that 0? No, it's 10. So that's 50. Yeah, 5 plus 5 and just 5. No. This is -5 and this is positive 10. So that's minus 50. That was an interesting one. So we need to calculate the determinant of this thing and b cubed. Well, we know that the determinant of b. Okay. So my reasoning for this is that b to the power 4 is equal to that b equals that b is equal to that b to the power 4. So that's my proof for that you can get a square out of the determinant. Or powered out of the determinant. So we just need to calculate the determinant of this and then cube that. So I'm gonna do cofactor expansion and do it like across this row. So I'm gonna have -3 times the determinant of 1, 0, -1, 1. Which realistically we already know that this is gonna be 1, so I'm just gonna add 1. Plus 0 times the determinant of 1, 0, 1, 1, plus 1 times the determinant of 1 minus 1, 1, 1. And we know that the determinant of this thing is -1 minus 1 is -2. So then the total determinant is equal to -5. Yeah, and then we have to do that to the power 4, so it's 5 to the power 4. Use the determinant.
What was that?
Hmm?
Da, 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 da.
Oh god.
No,
Yeah, I've heard this before.
Yeah, no. Everybody has heard that one.
Everybody's heard this before, but like
everybody knows that. I just don't know where it's from.
Oh my god.
If I Google Papo Pay meme song, I'm gonna figure it out. I'm 100% certain. It's called Scatman's World.
Oh wait, yeah,
what?
of course.
Yeah, it's called Scatman's World.
Catman.
No, but
anyway, back to linear algebra.
No, I think we're talking about a different song.
No,
we
that's
were
not
talking
the
about a
same
different song. You were humming something else.
Okay, then.
Yeah. Use the determinant to decide if the set of vectors is linearly independent. Well, we do this by determining if the determinant is not 0, then we know that this thing is dependent, and otherwise not. So let me actually see. What would be the best way to calculate the determinant of this thing? Just suck it out, I guess. I'm gonna do that. Whatever.
I guess the best would be to take the 0 already on the
so I'm
first.
doing this one. So we have 6 times determinant of, let's see, this times this one. So that's 14 minus this time 1 times this one. So that's 14 plus 21. 14 plus 21 is 36. 35. I wrote it down correctly. And then I add -5 times determinant this one times this one. So that's 28 plus 14. 28 plus 14, that's like 42. And then we multiply by that by -5. Well, that's like quite obviously not 0, I don't think. Actually, no, it is 0. Because this is 5 times 7. And this is 6 times 7. 6 times 7. So we have... Oh. So we have... Yeah, this will become 0. So this is linearly dependent.
Isn't it linear? Oh, damn, okay. It's also linear independent, never mind.
Yeah. Like, at first, I saw these numbers, and I was like, yeah, no way that's, like, linearly dependent. But it actually is, because 42 is 6 times 7, and 35 is 7 times 5. So we have 5 times 6 times 7, minus 5 times 6 times 7. Okay, now this thing again. I'm gonna take this row, so I'm gonna do 7 times the determinant of this thing, so that's negative 24 minus, or positive 30. So that's 24, is it 24? No, actually 28. 28 plus 30, so that's like 58. Plus, and then I'm going to do this one, so that's negative 5 times the determinant of these 4, so that's like 35 minus, what's this, 28? 35 minus 28, that's like 7. So then, this is not equal to 0, obviously, so it's linearly independent. I'm going to take this row, so it's negative 2 times the determinant of this thing. So it's negative 2 times the determinant of, and I'm going to use this row. So it's 3 times, so it's negative 2 times opening bracket t times, that's what, negative 18 plus 10, so that's negative 8. Plus, then I'm going to take this one, and that's negative 6 times determinant of, so that is negative 2 plus 12, that's like negative 10. So this is the eventual math. This is negative 24. This is positive 60. I think we can quite healthily assume that this is linearly independent. Is this 0? No, it's not. Then I fucked up my calculation somewhere.
That's probably the case.
It's 3 times. Let's see, what's this? Well, actually, we can think about this like this, right? So we have negative 2 times, but we care about it if it's 0 or not, so we can get rid of this negative 2. So this is 3 times. That's what, 10 minus 18, so that's 28. Plus minus 6 times, and that's what, 2, or negative 2 minus 12. Negative 2 times, or negative 2 plus minus 12, or negative 2 plus 12. No. Okay, yeah, it's minus, so that's negative 14. Oh, yeah. I put a minus sign too many, but yeah, I think this actually is linearly dependent. Because it will eventually turn out to be 0, because you can do like, this is 3 times 2 times, and this minus sign can go here, and 2 times 14 is actually 28, so yeah. Cool. Ooh. Find determinant A if A is equal to PDP inverse, where P is this and D is this. Wait, so the determinant of the inverse is equal to 1 over the determinant of the thing, right?
Yeah, basically you can just cancel it out.
Yeah, so the determinant of P and the determinant of P inverse, this is just going to be equal to 1. These two together. So that's just equal to negative 15. Or no, positive 15.
Yep.
Yeah, cool.
Let's go. Find the determinant of, why are they exploding point numbers? Okay. I'm gonna take
the middle
this
one.
It doesn't matter.
Oh,
like,
wait, no. I think it. Yeah, you're right.
It doesn't matter too much because we're gonna have to work with the numbers regardless.
Yeah.
So I'm gonna do.
Or
7
maybe
times.
maybe we can try to row reduce it.
We could, but like with a 3x3 matrix, I don't think is it's like that works. Everybody's leaving. Come on, don't leave me. Oh, we're still with like 10 people. 1, 2, 3, 4, 5, 6, 7,
I
8,
think
9.
exactly 10.
We're like no, less than 10. 1, 2, 3, 4,
Oh.
5, 6, 7, 8, 9. Okay.
By the way, the answer is 13 if you're too lazy to calculate it.
Nice.
I mean, probably we already know how to do this.
Yeah, exactly.
Now
No,
it's
stop
8.
leaving people.
Oof.
This is not true.
That A plus that B.
Right?
Not.
No,
Wait.
there are cases where it is.
Not
true,
always, yeah.
but
you can have that A and that B equal to 0, and then you have that A plus B is also equal to 0.
Yeah.
Like, if it's all 0, 0, 0, 0, 0 plus 0, 0, 0.
Yeah, exactly. Okay, wait. So
what the?
So we have -2 A inverse.
Okay, this is
B
square.
squared C transposed, right? So that's equal to so we want to have the determinant of this thing. This is equal to
which is
the determinant of. So we know. So first of all, we can take like these things apart.
Yep.
Okay. Then we know that the determinant of negative. I'm gonna leave this one B for now. We know the determinant of B squared is equal to the determinant of B times B is equal to the determinant of B squared.
Which is 1. Yeah.
Yeah. Times the determinant of C transpose. But the
C,
determinant of transpose matrix is the determinant of C. So we know that this is just -4. We know that this is just 1. So
As a determinant.
Hmm?
It's a -2. Shouldn't that be outside the determinant? It's because -2 is not bracket. It's not -2A bracket like with power of -1. It's just A to the power of -1.
Yeah, but this is something that we multiply A inverse by.
No, because without the bracket, I don't think so.
No, like this matrix.
No, okay, no, we're talking about the same. Never mind. Yeah, we're talking about the same.
Okay.
I thought you were talking. Okay, never mind. Ignore me. It's 6.
Okay.
It's almost
this
7.
This is a 3x3 matrix. So getting this out of the brackets would mean that we multiply this to that we raise this to the third power. A -2 raised to the third power is just equal to 8 or -8. Negative signs cancel out. This is 32. And then we have the determinant of A inverse. That's equal to 1 over the determinant of A. And 1 over the determinant of A. We know the determinant of A is 1, so 1 over 1. That means the answer is 32. Feels so good, man, to like just fill in an answer like that. Okay, what's the logical relationship between the statements A and is thing? Yep. There are 2 rows of A, one of which is a multiple of another. So if we have determinant of A is equal to 0, then that means that there is that they are linearly dependent. I know for a fact that 1 implies 2, but the question is, does 2 imply 1?
No. There's 2 columns, not 2 rows. If it's linear dependent, right?
Yeah,
if it's linear dependent, there's 2 columns. That's not 2 rows.
You're right.
So 1 cannot imply 2.
But then what? Then does 2 imply 1?
If 2 rows are... No, 2 doesn't imply 1. It's also...
Yeah, but
wait,
at least
hold
1
up.
and 2 has to be the case. I'm gonna go for 1 implies 2. What?
No.
Okay, I brute
So
force
2
the
does
question,
imply 1. If row J is 1.
Oh!
Oh!
Motherfucker.
Oh, you have to do linear simplify. Oh,
because
yeah,
you can,
okay.
Oh, yeah. And you can multiply like a row. You can like that. Fucking hell. Okay. Find all possible values for determinant A. You in a row matrix you use the equation editor. The fuck is an equation editor?
Equation editor.
I know. Okay, so if A squared is equal to 2A. So we have A times A is equal to 2A.
And that A is equal to 2. No, wait, no. Not necessarily. No, never mind.
We just divide by A. We don't know if it's invertible though, so we can only say A is equal to 2. Well, we couldn't say 8 equal to 2, right?
We couldn't say 8 equal to 2. Yes, we could not.
Oh, it would be 2 times the identity matrix.
Why? Oh
Like,
yeah.
If it is invertible, right? We don't know that yet.
Right.
But we could say that A is equal to 2 times the identity matrix. Just curious. In the oh wait, it's all possible values, and then we disregard one of the values. Okay, whatever.
Yeah.
But we can say, like, if we know that A squared is equal to 2A, then we
Then
can say
that's
the
A
determinant
square.
of A
Yeah,
squared
that's what I was
is
thinking.
equal to the determinant of 2A. That becomes the determinant of A squared
Yep.
equals to the determinant of 8A, or the 8 times the determinant of A.
8 times the determinant of A, yes.
Therefore, we can get determinant of A squared minus 8 times the determinant of A is equal to 0. Therefore, the determinant of A is equal to 0. Or determinant of A is equal to 8.
Let's go.
In a
0,
row matrix,
8.
use the equation editor though. I still don't.
Row matrix. I think that will be just 1.
Wouldn't it be 1, 0, 1? No, that's not true.
No. I think just 1, 8. I mean, we know the answer. I mean, if you don't mind, we can just fuck it up. It doesn't really matter.
Yeah.
No, in row. Nothing.
Oh, and
Yeah,
I
0,
said
8.
1, 8 anyway. Whatever.
But we know the answer anyway.
Find the determinant of. Well, okay. This is just like horseshit easy. This is like negative, this is like negative 80 minus 90 is equal to negative 170.
Let's go.
Let's go. We are so good. 2 times this thing.
We can just leave the 2 in the end. Oh yeah, well no, we have to. No, ignore me. I'm stupid.
I mean, we can just multiply this in our head, right? So we can have.
Yeah, just by 4.
Well, that as well, or we can multiply the numbers itself, but we can multiply by
Yeah.
4 as well. Let's try that. So this is 5 minus, so that's 5 plus 6. That's
6,
22.
11, 40, 44.
Oh,
No,
yeah.
multiply by 4.
Yeah.
Aha!
Good call. Find the determinant of.
And they're using float again. If you don't mind, let me just plug it in. Yeah, okay.
So this is the determinant of this thing, which is 0 minus 3. So that's minus 3 times. And this is the determinant of this thing. This is 20 minus or plus 3.
23. Yep.
Website takes the. Hey, nice.
69.
Nice. We're 7 hours in. Okay, I can make sex jokes.
Let's just
okay.
skip it. I think wait. I think this is even the same form. I think just try 13. I think this is no.
Sad.
No, it's
okay.
not. Anyway.
Anyway, use cofactor expansion. Okay, I
Oh,
can do
this.
that. So this is 3 times the determinant of this thing, which is negative 6 minus 3, plus 3 times the determinant of that thing. So like that is 6 plus 1. I've taken like this row, by the way.
Oh, okay.
Yeah, I should probably tell which rows I'm taking as I'm taking.
I mean, we can see that fast enough.
And actually,
you know.
this is not true because oh wait, yeah, it is true. So I said this one and then this one, and then for the last one it's this one and then this one. Yeah.
I should just have minus 48. That's the answer. If you already know, minus 48.
But is this like equal to minus 48 then? Like.
Good question. I don't think so.
Then I made a mistake somewhere. Oh. No, it's minus 6. Okay, then I made a mistake somewhere.
Okay. Or maybe I make a mistake somewhere.
No, you didn't.
Oh, it is.
The compute determinant b cubed. That's equal to the determinant of b cubed. And this is just a bunch of 1s and 2s. So this is 1 times the determinant of that thing. So that's like minus 2 plus 2. So that's 0. I'm using the top row again, by the way. And this is the 4 plus 1. So that's 5 times minus 2. So that's like negative 10. Plus 1 times 4 minus 1. So that's plus 3. So that's like minus 7.
What?
Oh, yeah, now we have to cube it.
No.
Hmm?
Oh, I got a different one. I got 5.
Okay, so wait. When we get rid of this one, we get this thing, which has a determinant of 0, right?
Yeah.
So then when we get this one...
Yeah.
When we get this one, it's like 4 minus minus 1, that's 5, so that's negative 10, yeah?
Yeah.
Okay. And then we have this one, we get 4 minus
Mi-
1. Or, oh, negative
No,
4 minus 1.
Then it's -3. Wait, wasn't this more wrong? Wait.
Wait, no, I'm wrong then. Because this means it's -3, but I did +3. So it should be negative 13.
But that still doesn't make sense because I got 5.
That still doesn't make sense.
According to my information intelligence, which I trust more. I think it's more trustworthy. But
Okay, so you had -5, right?
yeah. I think no, 5, no, 5, not -5.
Okay. Huh, you're right. So where did I go wrong then? Because I thought, let's see, this is negative
-2
plus
Oh,
2.
-2 plus 2.
Yeah, so this
So
is
it should be
0.
4. No, this is 4.
Oh, okay.
No, wait, no, wait,
Wait,
no. No, it's 0. Yeah, it's 0, sorry.
Yeah, so determinant for this one is 0. Determinant this one is 4 plus 1 times
plus 1
minus
is
2,
5.
that's negative 10.
This is negative 10, yeah.
Does that mean that, wait, so then we have 1 times...
Wait.
1 times negative 4 plus 1, so that's, yeah, that's negative 3, so it should... I think this one is incorrect. I no cap. Okay, so find the determinant of C of this thing.
Oh, fuck.
Well, no, this is easy. So,
let me just...
determinant of C, determinant of the copyright sign, is equal to the determinant of A transpose, which is equal to the determinant of A, times 1 over the determinant of B. And the determinant of B is negative 10. So it is negative the determinant of A times 1/10. And the determinant of A is equal to...
-35.
Oh, I know.
How many did
I
you
know
say?
what we've been doing wrong the whole time.
What then?
It's alternating positive and negative signs.
Fuck, we forgot the...
Oh, right!
We forgot our design table. Holy shit. Ugh.
That's
know.
That's why I mean the easiest way is just always takes the first column, so you don't have to remember the alternating
Basically,
sign and
top
stuff.
left is positive, and then every time you move in every direction, it switches.
Yeah, like this. Ugh, that makes so much sense. I thought we were already forgetting something. Okay, what's the determinant of A?
-35.
-35?
Yep. Determinant of B is -10. I wish you already got it, yes.
Yeah. And they cancel out, so that's 3.5. Find determinant.
Oh,
Isn't this like 3.5?
oh, that's basically the same thing, but no.
No. They changed the numbers. Sad. I'm gonna go
It's
take a leak real quick.
280.
Gamer piss. I'll be right back.
All right.
I'm so sorry, I forgot that. Like,
No worry, I totally forgot about the sign table stuff also. So.
but like for a good while.
Yeah, it's like. Wait, but then still, how do we get 5 out of that question? Then I made a mistake somewhere because then it still should be 7 then.
Yeah, that's weird actually.
That's what I'm thinking. Yeah, because that shouldn't happen. God, I couldn't pull up the. Let's just see the recording maybe later, but I couldn't pull up the question right now. Welcome back.
I am back.
Buongiorno.
Okay. Find the determinant of C. Is C equal to 2A transpose?
So that'll be to the power of 4 times 4.
Oh yeah, 4 times The determinant of
35.
A, it's 35. Okay, thank you. And
Minus 35 actually. Sorry.
okay, and then the determinant of B is equal to negative like 20.
Negative 10. Negative 10. Yes. Sorry. Negative 10. Oh. 1 over. Shouldn't it just be minus 1 over 10?
This is 5.
Oh no, it's changed. Okay, never mind. It's changed. Yeah.
Yeah. Yeah, no, they changed it. That's alright.
Sorry.
No worries, it happens. And this is like 1 divided by. So this is 4 times 35 divided by
7.
20. Well, yeah, that's another way to say it. Wait, is it not?
Wait, that's not.
Huh.
Huh.
Did we forget to do the plus minus thing again?
No. No, wait. Maybe they changed the.
Yeah, they
maybe
changed this one as
just
well.
change it. Oh.
Oh, you just used the old one.
Yeah, I thought it was the old one, and apparently
Okay.
it's different. Shoot.
It is shit.
Give me a second.
Yeah.
Minus 5, 0, 5, 2, 1, 3.
So I'm gonna
And that gives you minus 45.
It's minus 45?
Yep.
I'm gonna calculate it myself real quick as well. So it's 5 times the determinant of that thing. So that's like negative 2 times 3. That's negative 6 minus. So that's negative 6 plus 3. That's like negative 3. And then I'm gonna subtract 5 times 2 plus 4. It's like 6. So we have this is negative 15. And this is negative 30, so negative 45. I really feel bad for people who have like watched this far and then they thought, okay, I'm good, and then they didn't notice that we were doing multiplication wrong. What? It's a 3 by 3 matrix, so this should be 8, not 4.
Ah. Right, 3 by
I'm
3.
gonna
Never
be
mind.
honest.
Are
My
you?
brain is so broken right now.
Yeah.
Can we
I
just skip
am
this
not-
question? Can we just skip this question? I want to see how they deal with the square situation, because I have no idea how to actually deal with it.
Okay, let's try it then. So the
Yeah, you
determinant
can
of
go
C
try.
is equal to, well, we have the 6th square root of 5. So that's 5 to the power of 1 over 6.
That A is 5.
Hmm?
Determinant of A is 5.
Okay, cool. Thank you for the future. And we actually, because it's like a 3 by 3 matrix, we cube this. So so this gets cubed. So that becomes 3 out of 6, and that becomes 1 over 2. That means therefore this is just the square root of 2, or the square root of 5. Sorry.
Ah.
And then we multiply that by the determinant of A, which was 5, you said?
Yep.
And then we divide that by the determinant of B, which is negative 15.
What? Can this be 15?
No, it's like negative 5 times negative 3, which is 15, times negative 1, which is negative 15. Interesting.
Wait, maybe I made a mistake somewhere.
I love it. That's like your last conclusion. I'm gonna try this meanwhile. So it should be negative square root of 5 over 3.
Maybe it is 15, but I made a mistake. Wait, if you try if it's 15, can you give a shot?
Well, that's what I had. So we had.
No, I think remove the minus sign. Remove the minus sign. I think still over 3, but like remove the minus sign. Yeah, square root of 5 over 3.
Huh? Where did that minus sign come from then?
You said it was minus 15 for the B, but I get 15. That's the issue. I have no idea what that means.
It's a diagonal matrix, so it's negative 5 times negative 1 times negative 3. So this one is negative 15, and this one is probably negative 5 then.
Wait, let me check. Well, turn the matrix calculator. Give me a second. 2 minus 1 minus 3 5. Oh, minus 5 0. Wait, hold up. Minus 5 0 minus 5 minus 3 1 and 3.
For the people
And
who
they go
like,
minus 5. Yes, I missed a sign.
Okay. For the people who actually care about the Netherlands, there is a press conference right now about Corona.
Lockdown. Yeah.
Yeah, we'll see. It'll probably get extended again. People are dumb.
I don't think the lockdown will be over. To be honest with you.
Yeah, I mean, hell, even now the reproduction number R is still above 1. So
The R is still above 1.
yeah, I mean, this is like an old value. This is the value of like 3 weeks ago, but then it was 1.04. But we're still gaining like 5,000 to 4,000 people every single day, and we have been consistent in that for a while.
Today was 3,309, which does looks better.
What are you guys talking about?
Corona data.
Yeah. Okay, let me try this real quick. So we have a matrix, like this. Let's just do 1, 2, 3, 4, 5, 6, 7, 8, 9. And the result on a 3x3 matrix. So the last column into the first position. Okay, so that would be like doing like this. Let me first of all move all of this over by 1, and then like this. This is a lot of text. No, fuck. I thought we had a theory, guys.
Oh, maybe the shortest one this time.
Hmm?
Maybe the shortest one. This all depends on that. If not the longest, then just shortest.
Okay. Realistically, I do want to check it. So if we have the determinant of
Yeah, sure.
a 3x3 matrix of 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 7, 8, 9. Go. So this is 0.
0.
Well, but then I can't fucking test
man,
it.
that is so beautiful though. That
Is it though?
this-
Huh. That is really cool. Okay.
That is actually 0. Damn.
Yeah. So
that
I
is
swap.
actually just nice.
It does genuinely feel nice.
Beauty of math. Beauty
So
of
then
math.
when I swap around the columns, I get this, right? So I'm gonna try the determinant of this. So that's 3, 1, 2. And
But
this is
the fact that this
6.
determinant is 0 proves that yeah, we need to alternate signs.
Yeah. And then
8, 7, 9.
8, 7, 9. Would it be like -9 then? Oh, it's still 9, but
Yeah,
there.
it's got 9.
Yeah, but that it's just like the n by n matrix. So if we did it by a 4x4, then it probably wouldn't happen. Give it non.
Yeah, whatever.
Hey.
Well, what we just did.
Wait, no. Ours had a determinant of. Oh wait, no, we didn't. We
No,
explicitly
it's
changed
fine.
it.
Yeah. Let's go.
We even did this ourselves.
Wait,
Wow,
that's done. Speedrun is done. I mean, we got a
That's
worse
time.
score anyway, but
So
let's caught it up.
I'm gonna pause it. But we have a 7 hours and 16 minutes record. However,
And that's
before we finish, somebody did a verzoeknummertje. So this guy asked this question, and I want to do this one real quick. It's not that hard, I don't think, because we struggled
Where's
with
that
this one
come
just now.
from?
I think the book.
Oh.
Among Us. Haha. That's so funny. So they have this thing, and this doesn't sound like a lot of. This doesn't look like a lot of fun, but I can assure you it probably won't be. -1 times c transposed plus x transposed is equal to c.
The transpose of transpose. If a thing transpose twice, it's back to itself, right?
Yeah, but I don't know what happens with the transpose of a sum. So it's like this.
I mean, you can still sum it up afterwards as transpose because you're just switching around, right? So you can still sum it after the transpose.
Yeah, but would it transpose of this? Would this should be the transpose of CTT and plus XT?
I mean, we could give it a try because let's just assume like C equals A, B, C, D, and X equals E, F, G, H. I mean, we could just give it a try right now. Let me write that down. Like,
sure. So we have over here.
C equals A, B, C, D, let's say.
Okay, yeah. So we have A, B, C, D. and we have x equals to
EFGH.
GH. So what we're doing is first we're transposing this one. So this becomes A C B D A C B D.
Yep.
And then we sum this with that. So then we get A plus E. A plus E. C plus F. D plus H. And B plus G. And then we transpose that again. And what do we want that to be equal to again?
If we just open the bracket and see.
Oh yeah,
So
so
if
we
we
have
open
like
the bracket,
C plus X transposed.
yeah, C plus X transpose, which is
Well, I mean that's true then. Oh, I
yeah.
fucked up the
So
thing.
EGFH, because X gonna be EGFH, so B and G, C and F. Yeah, so it works.
Yeah, so it works.
So we can just open the bracket.
Okay, so I'm gonna so we can get rid of the bracket. Well, we can't quite get rid of the brackets yet, but we can get the transposed into the brackets. So then this will become. Oh, I have to add new lines to my functions. So now we have this.
Yep.
Okay. Now I'm going to. I think honestly
Now we
the best,
should open the
best idea
bracket,
would
maybe.
Well, that's gonna give us more terms. I like it the way it is now because now it has just one big
Alright,
multiplication.
sure. But I mean, but then you have
How-
this idea of something equal to C, which basically means AT plus B1 has to be 0, and XT has actually to be
What we can
0,
do,
I would assume.
What we can do is we're solving for X, right?
Yep.
So we can left multiply both sides by A to the power T inverse. Because AT is just a normal matrix, and multiplying by its inverse is.
But how do you know how do you know AT is invertible?
Isn't that if A is invertible and AT is also invertible because the
Wait, let me check.
The determinant will be the same.
If AT is invertible. Yeah, okay, AT is invertible. Yeah, never mind.
Yeah, okay. So then,
Then you have C. Also on the right hand side, you still have C,
we
A
have
to the T.
left multiply by A to the power T inverse. And we should just look at this like one term, right?
Yeah.
So then we can get rid of this A to the power T, A to the power T inverse. It should be A transpose, not A to the power T. Then we just have the
whatever
inverse.
it's
Exactly.
You just time B on the left multiple B, I suppose then.
Okay, then we can get rid of this thing.
And also the bracket.
And also the brackets. Hell yeah. So then we can subtract by T on both sides.
Wait, what are we trying to find again?
X.
Oh.
Yeah, so then we subtract C on both sides. And then we transpose on both sides.
Transpose the whole thing again, yeah.
Wow, that was like a 4-minute adventure, man. Holy shit. Let's look at that one of the possible answers. So he wanted to know. Oh god, where was that? I put it down somewhere.
Where did that go? I think it's
here.
Yeah, there you
So
go.
it is.
Well, the answer is B. It's just
Yeah. So we know the answer is this, but that means it's.
Because we can just open it up. Because we can just sum it up. Because
so we know that we can do this, right? Oh, let me actually make a new step for that. So we know that we can do. We can get this transposed inside of the brackets, and then we also. Oh, I have a bracket too many here. And then we know that we can say this thing -1, and then we can get this out of the bracket, and minus I because it's identity matrix. That's like the one of linear algebra, and that is equal to B.
B, there you go.
Is it though? Because this is left multiple. And
Wait, that's different order. Wait, hold up. Wait, yeah.
And this is like different as well. Huh. Okay, so we have like we have like something completely different.
Huh.
A inverse B. Oh wait. I forgot to transpose. Oh yeah, when we transpose this whole thing, so we didn't do that properly. So after this line, we can get C transposed and this whole thing transposed. However, and now I have to think really quick. So if we have this, is this equal to
B transpose and A minus 1 and C transpose.
wait, so we have like it like this, but does that mean we can put brackets like
Yeah.
this, right?
No.
Or do we do the operation from
No.
left to right?
I think we thought for. Wait, hold up.
Because
I mean,
I think because AB transposed is B transposed A transposed, so it does matter in which order we do them. We do the operation from left to right. I remember that much. So
right, then let's go
this
try
is-
that way.
This is equal to this, right?
It should be.
Yeah. So what I'm going to do then is I'm going to say, okay, if we transpose this whole thing times C, that's equal to C transpose times this whole thing transpose.
Yep.
Times this whole thing transpose. Are my brackets still in order or not?
Yeah, I think so.
So yeah.
Oh no, you're having one extra one.
Yeah, one extra. So this one goes away and this one goes away. Wait, no, now I did. There was enough there. Okay.
Yeah, for that one, yes.
Okay. So now this is.
And
like
then
this.
you're doing the same thing again.
Yeah. So now this becomes A times T and this thing.
And A transpose.
And
That's
then-
gonna be just minus 1.
And then just B transposed.
Transpose. Yeah.
And then to get rid of this, well, we know. Oh.
You probably need one more bracket just to make it work. Yeah.
Yeah. But we know that when you transpose something twice, we can we can reverse the order of operations, and when we transpose something twice, we know that just reverts back. So we can get rid of this transpose. We can get rid of this transpose. So this should get the picture across.
And you just have to get the I out.
Yeah. So
Minus I.
Then we just do opening brackets. Or well, we don't even have to do opening bracket. We can just do this minus I.
Yep. And we're done.
And we're done. Yep. Okay, so I'm going to take a picture of this and send it in the group chat because he asked a question there about it. Yeah, that's pretty folks. It's good to know that we can actually do this, and it's good to know there's also multiple. Well, actually, not multiple correct answers because we fucked up the first part. Okay. So he said he put the answer in the LA group.
Oh yeah, separate LA group for that.
Yeah, there's like 5 fucking groups, man. Honestly, I'm not sure if it's even worth joining. So let's see if this the same question as for them. B transposed A inverse minus 1. Yeah, okay. So I can just reply to this one. Okay. Well, I think that's done. Does anybody still have any questions?
No, personally.
No. Well, in that case,
I mean, I am way too tired to have
Yeah.
properly
Yeah.
followed what
I feel ya. In that
I
case,
like
I'm
how we
going-
start with 30-ish, and now we only have 1, 2, 3, 4, 8.
Yeah.
1/5, that's or like 1/4 at least.
Yeah, I feel ya. Anyways, I'm going to end the YouTube video. If you're watching this, it's probably already been the exam, so I hope they went well. If you're watching it before that, then holy hell, my upload speed is amazing. Well, I guess I'll see you everybody. I'll see you again later. Have a good one.